We've now wrapped up the first big feature inside of our application, which was caching. We're now going to move on to the next big feature, which is to set up a testing pipeline inside of our application. So let's get to it. We're going to first start off by doing some of the kind of high-level topics around testing in this video, and then we'll start actually implementing a testing pipeline in the coming videos. I want to first start off by having a quick discussion around the differences between unit testing and integration testing. With unit testing, we try to take one individual piece of our application, like a single function, or a single model, or a single route handler, and test it in isolation to make sure that it's working the way we expect. On the other hand, integration testing tries to take multiple units, so like a model, a route handler, a function, and whatever other pieces, string them all together, and then test them as one individual system. So with unit testing, we try to isolate small pieces. With integration testing, we try to string different pieces together and test them as one product. In our application, we're going to be taking a very heavily focus towards integration testing because it allows us to write fewer tests that test wide swaths of our code base and make sure that many different features are working the way that we expect without having to really obsess about the particular implementation details. In general, I personally heavily trend towards integration testing, but everyone kind of has their own taste. As we start to implement this testing pipeline, I think that you'll agree that this integration testing style or this approach is pretty darn effective, and I think that you'll end up enjoying it. That's just my personal thought. So anyways, let's talk about the flow that we're going to use to implement some integration tests inside of our application. All right, here we go. So we're going to start off at the very top here. We're going to go obviously down to the bottom. So we're going to start off by starting up our React and Express applications. And we've already done that, right? We ran that npm run dev command in our terminal, and that started up the Express app and the React app at the same time. You and I are going to create a new command inside of our package.json file called npm run test. Whenever we run this command, it's going to start up the Jest test suite. Jest is a very popular test runner, very similar to how Mocha and Jasmine or Tape or any other test runner that you've ever worked with behaves. So if you've never worked with Jest before, that is totally a-okay, no problem. Jest is so darn similar to Mocha, you won't believe it. Really, you won't. So as long as you have just some little bit of testing experience, you're going to do just fine in this section. Now here's where things start to get really interesting. If you've ever worked with tests before, you might have written some command to, say, call a function or try to save some model or who knows what. You run the command, you run the code, and then you make some assertion about what gets returned. But to get a true integration style testing approach, you and I are going to take a little bit of a different path. So you and I are going to try to boot up a virtual web browser inside of our application. This web browser is going to try to visit different pages inside of a React application. So we're going to boot up a web browser, and then we're going to tell that web browser to try to visit our application at localhost 3000. We're then going to programmatically tell that browser to somehow interact with our application. So maybe we will tell it to try to make a blog post, or to sign in or sign out, or try to go and view one particular blog post. We'll then write some tests to make some assertion about what content appears on the screen of this virtual browser. So the idea here is that the tests that we're going to be writing are going to be working through our app from the exact same standpoint as users. We're going to kind of pretend that our testing harness is like a user who's clicking through our application. And so if anything goes wrong with any piece of our app, like let's say we accidentally break the ability to create new posts, or maybe the caching isn't working the way we expect, then this testing harness is going to very quickly detect that problem and let us know that something is wrong. Now I want to tell you a little bit more about this Chromium thing that you see here in this diagram. Chromium is a web browser, just like the Chrome browser that I'm using right now, or Safari, or Internet Explorer, or whatever else. Chromium is an open source browser, and it actually serves as the basis for the Chrome browser as well. So you can kind of imagine that Chromium is a project, it's an open source project that exists out there right now. Google takes that code base, they customize it a little bit to turn it into the Google Chrome that you're probably very used to working with today. So when we start to launch this Chromium browser, it's going to look very similar to Chrome, which you're probably already running. You'll also see this term inside of here, inside the diagram, that says headless. So a headless browser is one that works without some user interface. You can see right now that whenever I launch my browser, yeah, I get this user interface. I get some different tabs, I get a window, and it shows me some content on the screen. When we launch a headless browser, however, it does not display any interface for us to interact with, and instead we interact with it solely through code that you and I write. The purpose of a headless browser is simply to run faster. We can run it directly from the command line. We don't have to worry about launching any windows. It doesn't actually render anything to the screen, which means in general it runs much more quickly than a normal browser would, which makes it very well suited for a testing environment. Now, Chromium is not something that you and I have to go and install. When we installed dependencies for the project that we're working on right now, one of the dependencies that we installed was the Chromium browser. So Chromium has already been downloaded and installed into your node modules directory. So we don't have to go install any browser. If you're not using Chrome right now, you don't have to go install it or anything like that. We already have it and we're good to go. Okay, so this is a kind of a high-level overview of how we're going to be approaching testing inside of our application. So let's pause right here. We're going to continue in the next video and point out some possible issues that we might run into as we start to implement this testing flow. So quick break, and I'll see you in just a minute. In the last video, we spoke about the testing setup that we're going to use inside of our application. So we're going to use Jest to boot up a headless browser. That browser is then going to visit our application and try to interact with it in some fashion. And then we'll make some assertions about the content that gets rendered onto the screen. Now, of course, I'm saying screen right here, but I also just said that we don't normally get an actual UI when we use a headless browser. So when I say screen, I mean kind of like virtual screen. We're going to make an assertion about kind of what is virtually being rendered onto the screen. Don't worry, it's going to make sense once we start getting to it. I now want to take a little bit of time to discuss some of the big challenges that we're going to run into as we start to implement this testing pipeline. So let's think about what might go wrong during all this. Okay, so the first one I think is pretty obvious, pretty clear. We need to somehow launch Chromium from our testing suite. Like we need to write JavaScript code that is going to launch this browser and tell it to actually do things. So we need to figure out some way to interact with a web browser by writing some JavaScript code. In practice, this won't be too bad, and we'll figure out how to do it pretty efficiently. Next, once we are able to launch a browser and interact with it in some fashion, we need to figure out how to pull information out of that and make an assertion about some of the content that's appearing on the screen. So this is the part where we actually make some assertion and verify that our application is working the way we expect. So between these two items right here, we're essentially saying we need to figure out a way to reliably launch a browser, tell it to do things, and then get information back from it. Now the third one down here is going to be a little bit more challenging, and we're going to have a long discussion about how to handle authentication with an automated browser testing pipeline. So we need to somehow log in as a user when we launch this browser. When we launch the browser, we can click on different elements virtually on the screen by writing some code to tell the browser to do things. But we do have to also go through our OAuth flow, which involves clicking on the login button and then entering in our Google credentials and then clicking on use this account right here and then authorizing our account to actually sign into the application. So that OAuth flow might be a little bit of a sore spot, and we might have to think a little bit about how to actually implement it. One of the key things to remember about testing flows in general is that we always want to use fresh data as we start to run our tests. And that usually includes authentication as well. So in theory, if we want to have a completely blank slate for every test run, we might have to figure out some way to say create a brand new Google account in the fly, like a brand new Gmail or Google account, and OAuth through that brand new generated account in order to really cleanly test our application. Now that definitely sounds like quite a challenge, so I think that we're gonna have to spend a little bit of time to think about how to actually implement this logging in process with this virtual browser. Okay, so these are some of the challenges that I think we're going to run into. My real goal by showing you these different items here is just to kind of give you an overview of some of the big things that we're gonna be spending time on as we start to actually implement this testing flow. So without further ado, I think we've discussed this stuff enough. let's start doing some implementation in the next video. We've now ran through the flow that we're going to use to implement testing inside of our application, so we're going to start writing some code in this video to make it happen. Now, one thing I want to mention is that you probably have noticed I haven't really said a whole bunch about how we're going to launch this browser and interact with it, beyond just saying, oh yeah, we're going to have to figure this out. The reason I haven't gone into great detail on that is that honestly, I think you're going to agree, it's pretty easy to get started with. As soon as you see the code we're going to write, you're going to say, oh, okay, well that seems simple. So trust me, don't worry about launching this browser too much. As soon as we get to that part, you're going to say, wow, that was pretty straightforward and pretty easy. So let's get to it. We're going to generally follow this diagram right here for our implementation steps. So we're going to first start off by creating a new command to run our test suite. So anytime we run the command npm run test from our command line, it should start off this entire testing pipeline that runs a bunch of tests for us. So I'm going to change back over to my code editor, and I'm going to pull up my package.json file. That's where we're going to create a new command to automatically run our test suite. Inside of here, I'm going to find the scripts section. I'm going to go down to the bottom of that section and add on a new script. Now do make sure that you get a comma on the line right above it. We're going to add in a new command called test, and whenever we run it, it's going to run the command jest, like so. Now you might look at this and say, Stephen, why are we making a command that just runs one word, right? Wouldn't it be easier to just run jest from the command line? Well, in truth, later on, we're going to come back here and add on some configuration options, vaguely like that. And so eventually, we're going to want to be able to run npm run test, and that's going to run not only jest, but also feed in a couple of options to it at the same time. So that's why we're adding this in right now. While we have the package.json file open, I want to point out a couple things. Down in the dependencies section, you'll notice that we already have Jest installed as an npm module. So again, this is our test runner. It's what allows us to run tests from the command line and make assertions about the way that our application is behaving. You'll also notice another module called Puppeteer right here. This module is what is going to allow us to launch a Chromium instance and interact with it from JavaScript code that you and I write. So everything that we're going to do is going to depend very heavily upon both Jest and Puppeteer. Cool. So we've now got our testing command. We should now be able to save this file, then go over to our terminal. I'm going to open up a new browser, or a new terminal tab. And inside of my project directory, I'm going to run the command npm run test, like so. Now I should see a little bit of text appear here on the screen, and then shortly after that, we should see a big error message that says, hey, sorry, but you don't actually have any test files inside your project directory. So let's continue in the next video. We're going to create a new folder inside of our application to house a bunch of tests that we're going to eventually add in. So quick break, and I'll see you in a minute. In the last video, we added in our testing command, and we're now ready to start writing some test files and make sure that our application is working the way we expect. I'm going to change back over to my code editor, and inside of here, I'm going to make a new folder that's going to contain all the different tests that we have for our application. So inside of my root project directory, I'm going to make a new folder called tests, like so. And then inside of this new folder, I'm going to make a new file called header.test.js. So there's a very good reason I'm calling this file by exactly this name that you see right here. And I really encourage you to make sure you use the exact same file name. Let's break it down piece by piece. So first off is the word header. This first test file that we're going to put together is going to test the header of our application and make sure that it works the way that we expect. So when I'm talking about the header, I'm talking about this big bar up at the top. So we're going to write some tests that make sure that, say, the logo appears correctly, and make sure that if we are logged in, we see buttons that say things like My Blogs and Log Out. So that's going to be the first subject that we're going to test inside of our application. So that's why we're calling it header. Now after that, you'll see that we have a file extension of .test.js. Whenever the Jest test runner executes inside of our application, it's going to try to find any file that ends with .test.js, and then it will execute those as test files. So if you want Jest to automatically discover files inside of your project and run them as test suites, you have to name them and end it with .test.js, like so. Okay, so now inside of here, we're going to put together a little bit of code to just get started and make sure that this Jest stuff just works the way we expect. So I'm going to start off by writing a very simple, very straightforward test to make sure that we're on the same page. If you've ever used Mocha, Jasmine, anything like that before, again, you're going to feel just at home with Jest. It's going to work really well. We first start off by using a single function to define a new test that we want to run, and that's called the test function. The first argument to this function is going to be the description of the test that we're about to run. So we might write a test that just asserts that, I don't know, maybe we can add two numbers together. So I might give it a description of something like test adds two numbers, like so. Then as the second argument to this function, I'll pass in an arrow function. So this arrow function right here is what is actually executed whenever the test runs. Inside of here, we can run any testing logic we might want. So I might say like const sum equals 1 plus 2. After we execute some testing logic, we can then make an actual assertion and verify that some value that has been produced inside of our test right here is the value that we expect. To do so, we can write out expect sum and then to equal and then whatever value we actually expect it to equal. In this case, 3, like so. So in the past, you might have used different assert statements, or you might have used, I don't know what else, should is out there with chai. These all behave the same way, and we just use them to make sure that some value is what we expect it to be. Now we'll talk about a lot of the different matchers over time, but for right now we're probably going to be making use of this to equal matcher quite a bit. And again, it just makes sure that sum is equal to some value. Let's now save this file and then run this test from our command line. So I'm going to go back over to my command line, and I'm going to again run npm run test. And now this time, Jest is going to find that file because it ends in .test.js. It will then run the test and make sure that, yep, 1 plus 2 is 3 in fact. So not a complicated test, but it's definitely a place that we can get started. Okay, so that's definitely an easy test to start off with. Let's take a break right here. When we come back in the next video, we're going to figure out how to programmatically launch a Chromium browser from within our test suite and then somehow interact with it. So quick break, and I'll see you in a minute. In the last section, we wrote out one very simple test just to make sure that we understand how our test runner works. So now that we've got a working test, let's now kind of move forward a little bit, and we're going to figure out how we can launch an instance of Chromium inside of our test suite and then use it to somehow work around or play around with our running application. Let's first start off by taking a look at a diagram that's going to give us a better idea of how the Puppeteer library works. So remember, Puppeteer has already been installed into our project. You can find it listed inside of our package.json file. This library is what's going to allow us to automatically create new browser windows and then somehow interact with them via JavaScript code that you and I are going to write. So everything around this browser, it all is coming from Puppeteer. All right. So this is a diagram to give you a better idea of how Puppeteer works. When we require Puppeteer into a test file, we are requiring in the Puppeteer library itself. This library has a bunch of functions tied to it, one of which we can call to create a new browser window. So like you can imagine a new browser window, just like the one that I have open right now. So when we use this library to start up a new browser window or a new instance of Chromium, it returns to us a JavaScript object that represents that running browser. And we refer to that as the browser object. So this is an object with a bunch of functions tied to it that allow us to somehow manipulate that running browser window. The browser object then allows us to call another function that creates a new browser tab, which we refer to as a page. This page object right here is another JavaScript object that represents one running tab inside of this browser. So at present, if you look at my Chrome browser that I'm running right now, you can imagine that I have one browser that's like the entire window, and then I have 4 individual pages, so to speak. Page 1, page 2, page 3, and page 4. In practice, for all of our tests, we're going to create one browser, and then inside there, we're going to create one individual page. So in other words, one tab inside that newly created window. So now that we've got a better idea of how Puppeteer works and how we kind of create these different objects, let's flip back over to our test file, and we're going to write out our first test to try to create a new browser window and then create a new page inside of that. Okay, so back inside my header test file, I'm going to first start off by requiring in the Puppeteer library at the top of the file. So we'll say const Puppeteer is require Puppeteer. Now, already I want to pause right here and I want to give you some very important advice. It is incredibly easy to misspell the word Puppeteer. Very, very easy. So as we go through all this testing code that we're going to write out, I beg you, please triple check the spelling of the word Puppeteer, because chances are, I can almost guarantee you, you will mistype this word at some point as we are working on all these tests. I say this from experience because I personally mistype this word all the darn time. So please triple check your spelling of the word Puppeteer. Okay, so now that we required this module in, let's create a new test inside this file. And all we're going to do inside this new test is try to launch a new Chromium instance. So I'm going to write out a new test that says we can launch a browser like so. And then inside this test, I'm going to use the Puppeteer library. I'm going to use the Puppeteer library to create a new browser instance. So remember, we use Puppeteer to create browsers, and then we use the browser to create pages. So inside the test, I'm going to write out const browser equals await Puppeteer.launch. And then I'm going to pass that an empty object, like so. So a couple things to notice here. First off, don't forget the empty object here. Eventually, we're going to add in a couple of options to customize how this browser window is created. Next, please triple check your spelling of Puppeteer. Make sure you've got the correct spelling there. And then finally, you'll notice that we have the await keyword inside there. So I can tell you right now that every single operation that we do with Puppeteer to launch a browser or to interact with a page or to try to make an assertion or pull information out of a page, it's all asynchronous operations. So it takes some amount of time for your running test process to reach out across your operating system and work with a browser window. It's always asynchronous. So just about every single line of code that we ever write that's going to work with Puppeteer is going to have the await keyword in front of it. Almost every single line. Now, since we're using the await keyword inside this function, we do have to remember to mark this function as being async. Okay, so this right here creates a new object that we're going to refer to as browser. And again, this is an object that represents the running browser window that gets created. We can then use that browser window to create a new page. And this page thing represents one browser or one tab running inside that browser, just like the tab that I have active right now. So underneath that line of code, I'm then going to write out const page is await browser.newPage, like so. This creates a new tab or a new page that is opened inside of the browser that we just created. And then it assigns the result to the variable page. We're going to use this page variable right here throughout just about every test that we end up writing inside of our test suite. This page object allows us to reach out to that running tab and tell it to navigate to some location, or tell it to click on some element, or tell it to, I don't know, try to return some DOM element and make sure that we have the correct text being displayed on the page. So almost all the tests that we write are going to try to interact with this page right here in some fashion. Okay, so I think that we've got enough right now to run this test suite and just see what happens. We're not actually making any assertions here, but hey, let's just make sure that the browser window actually opens up. Now, before we actually run our code, I'm going to add one option to this object right here. So I'm going to pass in an additional option. I'm going to say headless false, like so. So remember, whenever we use the term headless, that means that the browser will open without some graphical user interface. By passing in headless false, that means do not start in headless mode. So whenever the browser starts up, we do want to see the graphical user interface appear on the screen. Normally when we run our tests, we're going to run in headless mode to make sure that they execute as fast as possible. But for this first time around, and for the next couple of tests that we write, we're going to launch the browser not in headless mode so that we can actually see the window appear and see what it's actually doing inside of our application. Okay, so let's flip on over to our command line, and I'm going to run my test suite again by running the command npm run test. Now when I do this, we're going to see a little icon appear inside of my dock down here. If you're on Windows, you'll see it appear in your taskbar down at the bottom. So this is our running Chromium instance that just got launched. So I can open it up right here, and you'll see that there are 2 pages that are open. By default, whenever you create a new browser instance, one tab is automatically created for you. But just out of kind of convenience, we just create another browser tab. So by just launching a browser, we got 1 page. This line right here launched that second tab that we are currently focused on. Again, we don't necessarily have to create the second tab. We could reuse the one that's created for us automatically, but generally it's just a lot more convenient to call browser.newPage and know that you are in fact working with a brand new page. So now inside of this Chromium instance, I think you can agree with me that it really does look a lot like the Chrome browser. Just about everything about this is going to feel and look like Chrome. So we've got the very familiar different tab systems, we've got all the familiar menus at the top, and if we wanted to, we could right click on the page, click Inspect Element, and we still get the very familiar Chrome Developer Console on the right hand side here. You'll also notice the very big message here, Chrome is being controlled by automated test software. This just lets the user know that, hey, something is manipulating this browser instance. That's all. Okay, so we now have a better idea of how to use Puppeteer to launch a Chromium browser. So let's pause right here. We're going to come back in the next video and somehow figure out how to use this browser to visit our application and then make assertions about the content that appears on the screen. So quick break, and I'll see you in just a minute. In the last section, we used Puppeteer to successfully launch a new Chromium instance. Now you'll notice that this Chromium window just kind of sticks around, and it's not automatically closing or anything like that. So in a normal test environment, we would kind of expect to very quickly launch a new browser window, run some code inside of it, and then automatically close it when we are all done with it. So right now, we don't have any code to automatically close this browser window for us after all of our tests have been executed. So for this first time, I'm going to manually close the Chromium window by clicking on Quit Chromium right here. And then when I do so, you should notice that the command line gets kicked back out to the actual command prompt right here. Like I said, we'll eventually add in some code to automatically manage these browser windows for us and close them after our tests have been executed. But for right now, we're going to have to kind of manually clean up after ourselves. Okay, so let's now go back over to our command line, or excuse me, to our code editor over here. We're going to add in some additional code to actually write a meaningful test that's going to execute inside of our application. Let's first take a glance at a diagram that's going to very clearly tell us how we're going to write almost every test that we put together. Okay, so here we go. This is the flow, and we're going to repeat this flow over and over and over again. We start off at the top where we launch Chromium, and we just figured out how to do that. We're then going to use our page object to somehow navigate over to our running application at localhost 3000. We'll then click on some content on the screen. And when I say click, I mean like virtually click. So we're going to write some code that's going to automatically click on different elements, or maybe enter some text, or basically do something on the screen for us. Now here's the part that we're going to repeat over and over and over again. We will then use some DOM selector to retrieve a DOM element out of our application. And then we'll write some code to make sure that the text or the content of that DOM element is what we expect it to be. So for example, our first test that we might actually write for our application, and remember we are trying to test the header and make sure the header works correctly, we might try to write a DOM selector that tries to find this logo on the left-hand side, and then we might write an assertion to make sure that the text inside of that logo element is the word Blogster. That's a very simple test that would just make sure that, yep, whenever our page loads up at localhost 3000, we can, in fact, see the logo appear on the screen. It's a very simple test, but it absolutely is useful because it's just going to make sure that our application can boot up and show content. That's all. So let's now flip over to our code editor, and we're going to figure out how to write some code that will navigate to our app, use a DOM selector to retrieve some content, and then actually make an assertion about it. So I'm going to go over to my code editor, and underneath the line where we created a new page, I'm going to use this page object to try to navigate to our running application. So I'm going to write out await page.goto, and then the URL that we want to try to navigate to, which in this case, is localhost 3000, like so. So now after launching this new tab or this new page, we're telling that page to try to visit the address localhost 3000. Again, notice that we are using the await syntax here because navigating over to this other page is going to take some amount of time, and we want to wait for that process to complete before we try to run the next line of code. So let's save this file and run this and see how we're doing. I just want to make sure that we are able to successfully load up this address before we go any further. So I'm going to go back over to my terminal and I'll run npm run test again. Now after just a moment or two, I'll see my browser window appear again, and now I have automatically navigated over to localhost 3000. That's pretty much it. So now we have to do the same thing we're going to do every time, which is to write some selector that's going to try to find this DOM element right here and then retrieve the content of it. Let's take care of writing that selector in the next video. So I'll see you in just a minute. In the last section, we managed to get our Chromium instance to automatically navigate over to our application. We're now going to go to the next step on our flow. Well, maybe not the next step. So we navigated to our app. The next step on this flow right here says that we're going to click on stuff on the screen, or like basically click on something inside of our application. For this particular case, or this test that we're trying to write right now, we don't actually need to click on anything or interact with the page. Remember, right now, all we're trying to do is get the text off of our header right here, just to make sure that the logo has the correct text. The entire purpose of this test is just to make sure that whenever we visit localhost 3000, our app boots up as we would expect. So in this case, no need to click on anything. So we're going to go right down to the next step, where we're going to use a DOM selector to retrieve the content of that logo element. So I'm going to go back over to my Chromium instance. We need to write a selector, like a CSS selector, a DOM selector, that will select this element. And then once we have that selector, we can use it to extract the text out of that element. And then back inside of our test file, we can write an assertion that says the text right here does in fact say Blogster. So to write our selector, I'm going to right click on this element and click on Inspect. So as usual, we get our Elements tab appearing here. And you can see, if I zoom in a little bit, let me do that right now. One more, that's good. So the element that we want to get access to is this anchor tag right here. That's the element that contains the text Blogster. So we need to write a CSS selector that's going to get access to this anchor tag. I'm going to pull up the console down here, and I think that we could probably do a selector that looks something like a.brand-logo, like so. Yeah, there we go. So that gives me back the anchor tag alone. So then if I wanted to get the content inside of that anchor tag, I could write .inner HTML, like so. And there we go. That's pretty much it. We've got our text Blogster. So if we could somehow run some code like this right here inside this Chromium instance from our test suite, we could then retrieve the text Blogster, and then we could write an assertion to say, yep, the text returned from this thing is in fact the string Blogster. So let's flip back over to our code editor, and we're going to figure out how to run some code from our test suite that gets executed over inside the browser. Before I do, I'm going to make sure that I kill this Chromium instance. Like I had said previously, in just a little bit, we'll figure out how to automatically close that browser after we run our tests. But for right now, we're doing some real interactive back and forth, so it's just easier if we leave the browser open. All right, so back inside of our test file, we're going to write a line of code that's going to get the content of that anchor tag by using a selector. I'm going to tell you right now, before we write this line of code, the code itself is going to look a little bit strange. All right, it's going to seem like it's more complicated than it needs to be. But we'll write it out, and then I'll tell you why it's so complicated, and I think it'll make a little bit more sense. So I'm going to say const text. So this variable right here is going to hold the text that we pull out of the header. And then I'll write page.$eval. Then I'm going to put the selector in there, so a.brand-logo. And then I'm going to pass in an arrow function that takes something called L. And from that arrow function, I'm going to return l.innerHTML. And of course, please make sure that HTML right here is capitalized. Now there's one thing that I forgot on this line of code right here, and maybe you caught it. Remember, anytime we work with a page or anything coming from Puppeteer at all, it's always an asynchronous operation. So I forgot to put in the await keyword. So I'm going to make sure I put that in there as well. Okay, so now the last thing, I'm going to write out an assertion to make sure that this variable text right here actually does contain the string blogster. So I will expect text to equal blogster. Okay, so we still have to explain this line of code right here and why it looks a little bit more complicated than it might need to be. But before we do, let's run this test suite and just make sure that this test actually works. Okay, so back over at the terminal, I'm going to run npm run test again. Hopefully your tests run faster than mine. My test suite actually runs a little bit slower just because I'm running my, the video recording software at the same time. Anyways, I can run the test suite and it looks like that test is in fact passing right now. Cool. So it looks like the line of code we just wrote does in fact pull some text off the page. Let's take a break right now. We're going to come back in the next video and discuss this line of code. In this section, we're going to figure out why this line of code right here to extract some text from an element was kind of complicated. I mean, think about it. Why do we have to write like this $eval thing and the selector and this little inner function right here? Why couldn't it have been just something like const text equals page.getContent a.brand logo or something like that? This is, just to be clear, this is not a function right here. I'm just saying, why is it not a little simpler? Well, to understand why it's not simpler, we have to understand a little bit more about how Puppeteer works behind the scenes. So we're going to look at a couple of different slides to give you a better idea of how all this testing stuff is really working for us. Okay, so let me pull up the diagram. Okay, so just a second ago, we wrote out this line of code right here, and then somehow from our JavaScript environment running inside of our Jest test runner, that line of code got communicated over to the running Chromium instance. But it's what really happened in that communication that's really interesting. So the thing you have to understand here is that when we are running our Jest test suite, that's being executed in the node.js runtime, and we are invoking that from our terminal. That is one running process on our computer. When Puppeteer launches a Chromium instance, that Chromium instance is not somehow running inside of Node or anything like that. It's not running from our test suite. The Chromium instance is being launched as a completely separate process. So whenever we run some code inside of our test suite over here, it is being executed completely independently and completely separately from that Chromium browser. So in other words, whenever we interact with that page variable, or whenever we try to reach into our page and actually pull some text out or whatever it might be, that is not direct communication that is going over to the Chromium browser and somehow like reading memory out of it. Instead, Puppeteer takes that code that we just wrote and it serializes it into text. That text then gets communicated from our node.js runtime over to the Chromium browser. It then gets parsed back into actual JavaScript code and evaluated inside the browser. So let me give you a little bit better example of what's going on behind the scenes. I'm going to pull open my terminal right here, and I'm going to write out the function that you and I just wrote right here as the arrow function. So this thing right here. So this function right here actually gets turned to text and communicated over to that Chromium instance. And if you don't believe me, I'll show you exactly what it's doing behind the scenes. So I just copied that little function. So I'm going to say const func is that arrow function that we just copy pasted. I can then write out func.toString like so. And the entire function gets turned into an identical string to the one we just saw. So that's what's really going on behind the scenes with Puppeteer. When we feed it a function, like the one that we just wrote right here, this function is not somehow being like passed over to Chromium as a JavaScript function. Puppeteer internally turns it into a string, then sends it over to the Chromium instance. That string then gets turned back into an actual function like the one you see right here, executed, and then whatever gets returned is turned into a string as well and communicated back over to our running nodejs runtime. So in short, that's why this API right here, that's why this line of code looks a little bit stranger. It's because of the way that we are communicating with Puppeteer behind the scenes. Now, one other thing you might be a little bit curious about is this $eval function right here. Just to be really clear, $sign is a completely valid JavaScript identifier, and there's nothing like magic about it. There's nothing magic about this function just because we used a $sign. You and I can freely define variables inside of JavaScript that use a $sign anytime we want. So I can say like $sign money equals ABC. And then I can reference that variable just as I would a normal variable. So there's nothing special about the $sign in there. Okay, so hopefully that gives you a little bit better idea of what's going on behind the scenes when we make use of Puppeteer. The real idea here is that all the code that we run is being serialized into text, sent over to Chromium, executed, the result gets serialized back into text, and then sent back over to our Node.js runtime. All right, so that's pretty much it for this line of code right here. Let's take a break. We're going to come back to the next section. We're going to start to do a little bit of a refactor to this test file. So I'll see you in just a minute. We've now got one working test inside of our test file. There's just one little thing I want to mention here. You can notice how the first couple lines create a new browser instance and then launch a page inside that. This code right here is probably something we're going to want to do for every other test that we write inside of our project. So I don't know about you, but I don't really want to repeat this line of code right here, this chunk of code, inside of every single test. So in this video, we're going to do a little bit of a refactor to take this code and instead put it into a before each statement, where it will automatically be executed before every test that we run. To get started, I'm going to go back up to the top of this document and delete the test that we had written previously. I'm then going to replace it with a before each statement instead. If you're not familiar with before each statements, they're pretty straightforward. This inner function right here that we're passing in will be automatically invoked before every single test gets executed inside this file. So it's a great location to do some initial setup for our test environment. I'm then going to take the 3 lines of code where we create our new browser, the page, and then navigate inside the page. I'm going to cut them and put them inside the before each. Now, one quick thing to recognize here, if we define browser and page inside the before each statement, those variables will not be accessible from inside the test statement. This is classic JavaScript scoping. If we define the variables inside this function, they will not be accessible outside of it. So to get around this, we can define both the browser and page variables ahead of time. Now they're available inside the scope of this entire file. I'm going to make sure that I clean up the 2 const statements for both browser and page, because now we're going to initialize those 2 variables ahead of time outside the function. So I'm going to clean up that const and this one as well. Cool. So this looks like it will be much more concise for future tests that we write. Now for every additional test that we add into this file, we're not going to have to rewrite this code over and over again. This code will be executed automatically whenever another test is going to run. So let's very quickly test this out inside of our terminal again. So I'm going to close my Chromium instance, and then I'm going to run my tests again, and we're just going to make sure that it works as we would expect. Okay, so it looks like I've got a little bit of an issue here. I neglected to mark that before each statement as being asynchronous. So I'm going to go back over. I'm going to find that arrow function. I'm going to make sure I mark it as being async, like so. Let's try running our tests again. and now this time I successfully get my browser appearing here. It navigates to localhost 3000, and my tests all pass. Very good. Okay, so this looks pretty good. Now the last thing I want to take advantage of, or the last thing I want to fix up very quickly, and we'll tackle this in the next video, I want to make sure that after my test suite runs, I automatically close any running browser instances. Because I don't know about you, but I definitely don't want to have to automatically close Chromium every single time we run our test suite. So let's pause right here and take care of that inside the next video. Before we start writing any other tests, there's one last quick fix I want to take care of. After our test suite is completed running, we should automatically close any running Chromium instances that are still open. This is going to be a pretty quick fix, so let's get back to our test file and just put it in here right away. Underneath the before each statement, I'm going to define an after each. Now this function is very similar to the before each statement that we just put together. The only difference, as you might imagine, is that it is executed after each test runs. So inside of here, we can do a little bit of cleanup to make sure that we close any running browser instances. To close a running browser, we can write await browser.close, like so. So this line of code right here is going to make sure that this Chromium instance that we just launched gets completely nuked and thrown away. Now notice that I'm using the await keyword right here, so let's not forget to also mark this thing as async. Okay, so hopefully this will be the last time we have to manually close Chromium. So I'm going to quit, and then I'm going to run my test suite one more time. So now we should see our test run, and then after we successfully pass that test, the browser instantly closes and we get a report about what just happened. Cool, so that definitely looks good, and now we don't have to worry about manually closing Chromium all the time. So let's continue in the next video, and we are going to continue by writing a couple more tests around our header. So quick break, and I'll see you in just a minute. We've now got a pretty solid test suite put together. Let's now continue by writing another test around our header. So I'm going to go back over to my browser and take a look at my application. We've currently got a test asserting that the logo appears right here, and then the only other thing that really seems relevant about the header is the link at the right-hand side. I think that for our next test, we should try programmatically clicking on this link right here, and then asserting that this somehow kicks us into our OAuth flow. So we're going to have to take a look at some documentation to figure out how to do this, but let's put together kind of the start of our test, and then figure out what to do from there. I'm going to go back over to my test file. Now before we add on the next test statement, I do want to go back to the test we just wrote and update the description on it, because it's not really correct anymore. This is really not making sure we can launch a browser. This is making sure that the header has the correct text. So I'm going to change the description to the header has the correct text, like so. Cool. So now we're going to add on another test statement to assert that if we click on that button on the right-hand side, it kicks us into the OAuth flow. So I'm going to write out a new test statement. I'm going to say clicking login starts OAuth flow. And then I'll mark this function as async, like so. All right, so that looks good. So just as usual, this is the same thing. Like I said, we're going to do the same thing over and over again. We've launched Chromium by this time. We've navigated to our app. Remember, both these steps right here occur in our before each statement right now, so we don't have to manually do these anymore. So now we have to just click on something on the screen, then we're going to try to pull something out of our page and write an assertion about it. So we need to somehow click on an element that is located inside of our page. Rather than me just telling you what function we're going to use here, I think we should probably go take a look at the Puppeteer documentation so that you could get an idea of how to look at some of the different functions that are tied to that page object. So I'm going to pull up the documentation for Puppeteer inside of a new browser tab. I'm at the Puppeteer documentation, or I should say the Puppeteer repo on github.com. If I scroll down a little bit, you'll see a link to the API right here. So I'm going to click on this link, and that takes me to the documentation around the Puppeteer interface. So if you scroll down a little bit, you'll see class Puppeteer. So that's the actual library that we imported into our test file. You'll see the class browser. So that's the browser object that we've been working with. And then page. So the page is what you and I are going to be working with for the vast majority of the time. So if we scroll down a little bit, you'll see the eval method that we used just a little bit ago right here. And then if you scroll down a little bit more, you'll see page.click So this is the function that we're going to use to somehow manipulate content displayed on the screen. In particular, we are going to want to attempt to click the Login with Google button that is located inside the header. So to use page.click, we call the function and pass in the selector of the element that we want to click. And then notice that there's a couple of options here that we could pass in if we want to, but none of these options are actually useful for us. All we really care about is clicking the element. So let's first start off by figuring out a selector that will target that Login with Google button. I'm going to go back over to my application. I'm going to do an inspect element on that button. And then I'm going to take a look at the element we're dealing with here. So you'll notice that it is again an anchor tag. This time it does not actually have a class associated with it. But if you notice, the UL that is nested above it, or its parent UL, does have a class of write. So I think we could select a class of write and then the anchor tag inside that to get access to this link right here. So let's test that out. I'm going to do .write a, like so. Cool, so that definitely gives me the link. So we can pass in this string right here to that page.click function, and that will cause this link right here to be clicked. So let's go back over to our test suite. I'm going to do await page.click .write anchor, like so. Now don't forget, we have to have the await statement on here because it takes some amount of time to turn this stuff into text, communicate it over to Chromium, execute the command, and then get a response back. All right, so once that kicks us over to Google, so let's click the button inside of our browser just to see what happens. So once that kicks us over, we start going into the OAuth flow at Google. Now we never quite know what list of emails are going to appear on the screen here, and we also don't necessarily know that this thing is always going to say choose an account or anything like that. But there is one element of this page that I think will always be consistent, and that is the URL. Not the whole URL, so if you look at the whole URL, you'll notice that there's a couple of IDs and whatnot inside of it, but at the very start, you'll notice that the domain here is accounts.google.com. So I think that one way that we could assert that we properly have been kicked into our OAuth flow is by looking at the URL and writing an assertion that says that, yep, accounts.google.com is present inside the URL. We're going to take this approach so that we don't ever have to worry about Google changing the text or anything like that on their OAuth flow. Because if they ever change the text here, that would suddenly break our test suite, which we definitely would not want to have happen. All right, so let's look at our documentation again, and we're going to figure out how to get the URL of the current page that Chromium is currently looking at. So let's look at our page documentation again. So here's class page. And if I scroll down a little bit, you'll find a function called URL. Here it is right here. So this command doesn't really give you a lot of documentation about what's going on. It doesn't very clearly say what's happening here. There is a link to this other function that this function is essentially a proxy for. So if we go to the documentation for that, it says return the frame's URL. In this case, you can think of frame as more or less being like our page. So if we call page.url, that should return the current address that our Chromium browser is looking at. So let's give this a shot. Back inside of my code editor, I'm going to do const URL is await page.url, like so. For right now, let's just do a simple console log to make sure that we're extracting the URL properly. So I'm going to go back over to my terminal. I'm going to run my test suite, and we're just going to make sure that that console log appears as we would expect. And any second now, there we go. All right, so it looks like we do get our URL successfully. So again, a lot of this query string that you see on here might change over time. So we don't want to try to compare the entire query string. We just want to make sure that we are on the correct domain. That's all. Let's take a break. We'll continue in the next section, and we'll figure out how to use Jest to write a matcher that will assert that accounts.google.com is in the URL that we just retrieved. In the last section, we successfully clicked on an element on the page and then retrieved the URL from the page itself. The last thing we have to do is to write an assertion that confirms that this URL variable contains the string accounts.google.com. The entire purpose of this test is just to say that by clicking on that button, we are correctly kicked into our OAuth flow. To figure out a way to correctly write this matcher, let's take a look at the Jest documentation and figure out if there's some way to easily check to see if this URL thing right here has some particular string inside of it. Now, I've already pulled up the Jest documentation right here. You can access this by doing a Google search for simply Jest documentation. That's pretty much it. You can go to the API section, and then on the left-hand side, we'll scroll down a little bit and find the documentation for expect. This is a list of all the different matchers that we can get access to make actual assertions about values that we extract from our Chromium instance. We're going to look for a very particular function, one that is called, let's see if I can find it here, down the list, here we are, toMatch. So using toMatch is used any time that we want to check that a string contains some particular value. In particular, it's going to test some regular expression that we pass in as well. So you can see some examples of how we might use that right here. So we're essentially going to fall directly into this first case right here, where we use a simple regex just to check to see if one word, or in our case, 3 words, are present in the URL. I'm going to go back over to my test file, and I'm going to replace the console log with expect URL toMatch, and then we're going to pass in a regular expression that's going to look for the text accounts.google.com. So I'll say accounts.google.com. And notice that I've escaped the periods inside of here so that I don't try to use the period in the actual regex itself to match some other characters that I might not be expecting. All right, I'm going to save this document, and then we're going to run this inside of our terminal again and just make sure that test is passing. So back over at the terminal, I'll do an npm run test. We'll wait for our browser to kick up. There's the first test, and then notice how the browser is going to be closed here. Yeah, it just got closed and then reopened, and that's the second test that's running. And ta-da! So it looks like that worked as we expected. Okay, so this works pretty well. Now, at this point, we're just kind of testing that we get kicked into the OAuth flow, but we're not actually making any assertions about whether or not we are successfully going through it or logging in or anything like that. So let's continue in the next video. We're going to start to have a deeper discussion about how to really test authentication inside of our application. So I'll see you in just a minute. In the last section, we put together a test to make sure that clicking on the Login with Google button kicks off the OAuth flow. I now want to take this one step further. Let's try logging in really quickly here. Once I go through the OAuth flow, you'll notice that the content inside of that header starts to change. So once I'm signed in, I see 2 buttons here, one that says My Blogs and one that says Log Out. I would definitely think that we should write some type of test here that makes sure that once we are signed in, these 2 buttons appear and that Login with Google button goes away entirely. This is going to be a pretty straightforward test, just to make sure to say, hey, once you're signed in, the content in the header changes. When we start thinking about authentication to our application, you start to also realize that wide varieties of other tests that we might want to write all depend upon us being logged into the application. So right now, you are not allowed to create a new blog post if you are not signed in. You can't see any blog posts at all if you're not signed in. And you can't go look at a particular post if you're not signed in. So the vast majority of functionality in our app is kind of tied to this idea that you first have to log into our application. Now that is absolutely no different when we're running our application inside of Chromium. So when we are testing our application, we're going to have to figure out some way to log ourselves in and then try to create a blog post, and then try to look at the blog post, and then look at the list of all of our posts here. So it's starting to become very clear that we have to have a really good idea of how to sign ourselves in before we are able to write any of those other tests inside of our app. Now that might sound like it's challenging. Well, yes and no. So here's kind of 2 sides of looking at this. We've already seen an example of where we can automatically click on elements that are located on the page. We did that by clicking on this Login with Google button right here. Now if we think about our OAuth flow, when we click on that button, we come to this screen right here. This presents me with 4 other buttons because I've got a couple other accounts here. So in theory, I could write another line of code that says, find the line that says email dev right here, and then click on this element, and then wait to sign in, and eventually get kicked back over to our application. So we absolutely could write some code that goes through the entire OAuth flow for us. There's absolutely nothing to say that we cannot write automation code that runs on a web page that is maintained by Google. We absolutely can do it. However, there's one little gotcha here, one little gotcha. If we wrote some code like that and then ran it on our local machine, we'd probably be okay. Like, we'd probably be just fine. We could probably automate the entire OAuth process when it's running on our own local machine. However, later on in this course, we're going to take this entire testing setup and push it onto a continuous integration server. The purpose of this is to run our tests automatically in some isolated environment off of our local machine. The problem with that is that as soon as Google starts to detect you logging into an account from a machine that it has never seen you log in before, Google's authentication service starts to get a little suspicious. So there's two big problems with logging into our application from a CI server. The first is the fact that we are going to try to be logging into a Google account from a machine that we've never logged into before. The second is the fact that these automated Chromium instances that you and I are going to be running are going to be hammering Google's auth service. Like, many different instances are going to be trying to log in at the same time. And as soon as Google detects this suspicious behavior, it starts to get a little bit curious. And eventually, they're going to start showing us CAPTCHAs. A CAPTCHA right here is these very familiar screens that you might have seen before. So this is a screenshot right here. You might have seen this in the past. You start getting these UI pop-ups where to prove that you are a human, you have to like click on some images on here or type some text in, or like this right here, like read the numbers and then type the text in and then click verify. Now, I don't know about you, but I definitely do not know how to somehow write or get our Puppeteer add-on to do image recognition better than Google can. So what I'm trying to say here is that although we could probably automate our authentication flow on our local machines, we very likely will not be able to as soon as we start pushing our test setup off to run on some continuous integration server. So this entire idea of automating the flow is not going to work out in the long run. So you and I are going to have to think of some alternate method of somehow logging ourselves in without going through this OAuth flow on Google servers. So let's take a pause right here. We're going to come back in the next video and we're going to start to brainstorm on a couple of different ways to get ourselves logged into our application without having to go through our Google OAuth flow. So quick break and I'll see you in just a minute. In the last video, we spoke about how we're going to eventually run into some issues when we're running our automated tests and try to sign a user into our application. So the whole problem is that as soon as we start running a lot of tests at the same time, Google is going to lock us out of their OAuth system entirely and require us to solve some CAPTCHA or some image clicking thing or something like that. And there's absolutely, positively no way that you and I can easily automate that process. So in this video, we're going to explore a couple of different options to solve this big issue around authentication. So I took a couple of ideas and put them onto this chart right here. So we're going to walk through each of these possible solutions and talk about which one is probably going to be most appropriate for what we're trying to do. So the first idea you might have around solving this authentication issue is to maybe create a new secret route on our API server, like inside the Express application. And maybe we will say that if you ever call that route will automatically, without any Google OAuth or anything like that, it will automatically log you into the application. And the whole idea here is that as soon as we start up our test suite, we could have the Chromium browser access that route, log ourselves in, and then continue on with all of our other tests. But you know what? I'm going to say that this is probably not the best way to go. In general, I very strongly believe that changing your code base just to suit your tests is a very poor approach, and it's something we want to avoid. In addition, I bet you can imagine the security holes that could possibly arise by having some secret route that log you into your application. Now, of course, in a production environment, we could disable that route entirely, but you know what? Who knows? Maybe one day we accidentally leave that route in and then deployed to production, and now anyone can magically log into our application. Overall, just leaving in security holes in your app, just not a good idea, period. So the next idea I had was to say that whenever our tests are running, maybe we could figure out some way to keep our server from requiring authentication in any way, shape, or form. So maybe when the tests are running, we could say, allow any user to create a blog post, or to view any blog post, or to get a list of blog posts. In other words, just disable authentication temporarily. Well, the issue with that approach is that our server is completely separate from the test suite that we're running right now. They are kind of the same code base, right? They live in the same folder, but they're two completely separate running processes. And we do not start up or restart or do anything like that to the server whenever our tests run. So it would be kind of challenging to kind of change the configuration of our server on the fly just because our test suite starts up. In addition, this kind of falls into the same thought that we had on this last suggestion up here as well. We would be changing our server-side code base just to suit our tests a little bit better. And again, not really the best approach. So instead, you and I are going to take this third approach down here. We're going to figure out some way to somehow convince our server that our Chromium browser actually is signed into our application. We're going to figure out some way to like fake out or kind of fabricate a session out of nothingness, set it on our Chromium instance, and then use that to convince our application that we are in fact signed in. That's going to make sure that we're able to test all the usual authentication processes, make sure that we are only able to create a blog post if we're signed in and all that kind of good stuff without having to actually kind of, manipulate any of our server-side code or anything like that. Now, one other thing that I want to mention, because if you do your own Google search on this topic, you might come across some documentation from Google saying like, oh, well, if you're trying to test automation of the OAuth flow or something like that, you can make a service account or do this or do that. So maybe there is some way that with Google specifically, we could kind of fake out this OAuth flow and still go through the normal process. But you know what? That's a solution that only works for Google. And I want to give you a solution that's going to work for any OAuth provider out there. So just one little thing I want to throw out there. I'm going to give you here a solution that's going to work for any OAuth provider, not just Google. Okay, so this is the way we're going to go. So I have not given you a lot of detail here on exactly how we're going to somehow fake a session with our server. So let's continue in the next video where we're going to do a deep dive on how authentication in our current app works. In the last section, we spoke about a couple different approaches for solving this whole authentication issue on our automated test setup. In this section, we're going to do a quick review of how authentication is set up inside of our application as it stands right now. Now I'm going to show you a diagram that shows the entire process, but before I do, I want to point out a couple of files inside of our codebase just so you know where this code lives. So back inside my code editor, I'm going to first open up the root index.js file. Inside of here, I'm going to scroll down just a little bit and then find where I declare the Express application right here. Right underneath that, you're going to see a couple of lines of code where we set up two different pieces of middleware. The first one is cookie session, and then the other one is Passport right here. So we're using Passport to handle authentication inside of our app. The Passport in particular is responsible for handling the entire Google OAuth process. Cookie session, on the other hand, is responsible for maintaining a session on incoming requests. So anytime a user is authenticated inside of our app, some identifying information about them is stored on the user's cookie. Cookie session is what manages the data inside that cookie. The other thing I want to show you inside this project is inside the services passport.js file. So inside of here, you'll find some code related to setting up and configuring Passport inside of our application. If you've ever worked with Passport before, the serialize user and deserialize user functions are going to look pretty familiar. And then underneath that, you can find where the Google strategy is configured. So we provide some options for the strategy and then a callback function that's executed after a user comes back to our application from the Google OAuth flow. So now that we've got some idea of where this code sits inside of our project, we're going to take a look at a diagram that's going to walk through the entire flow of authentication inside of our app. All right, so back over here, here we go. This diagram shows three different entities that are worked with inside of our authentication process. On the left-hand side, we have a green line that represents the user. The red line in the middle represents our running server. And then the blue line on the far right-hand side represents the Google Authentication service. So that's pretty much their servers. So let's walk through this flow very quickly. The first part of this flow, or the first couple steps, are not actually super relevant for what we are trying to do here. What's much more relevant are the last couple steps that occur. So the first thing that happens is a user navigates their browser to the auth/Google route that's running on our Express server. And you can verify that by going back over to our application. I'm going to log out. And then if I hover over the Login with Google button right here, you can see that link appear on the bottom left-hand side of my browser. So that's a link that goes directly to auth/Google. Whenever a user visits that route, our server automatically forwards that request onto Google servers. On the Google server, the user is presented with some account selection dialog, or maybe they are asked to enter their account details or whatever it is. The user then selects the account that they want to use to log in with, and then they get automatically redirected back to our server, specifically on the route auth/Google/callback. When they come back over to our server, Google automatically includes a query parameter inside the URL, and this query parameter is called code. That code is a random series of numbers and letters. Our server takes that code and makes a follow-up request directly back over to Google's server. We attach the code to that request, and we ask Google to give us some identifying information about that user. In particular, we ask about their Google user ID, we ask for their username and their email, and a couple of other details as well. Google then sends that user's profile back over to our application, and we use that information to create a new profile or a new user inside of our MongoDB database that represents that particular user. Now here's the part that's really relevant for you and me. When we get that information back from Google, we create a brand new user inside of our database, and then to identify that user for follow-up requests, we set some information on the user's cookie. So our server puts some information on the user's cookie, and that information identifies this person. That goes back over to the user's browser. The browser automatically stores that cookie and then automatically attaches that data to any follow-up request that is executed inside of our application. So whenever the user's browser makes, say, an AJAX request or tries to load up our application or whatever it might be, the browser makes that request to our server and tacks on all the information inside the cookie. Our server takes that cookie, it looks at the information inside of it, and it says, oh, this is the same person who just logged in a couple minutes ago. Sure, I know who this is. I'm going to respond with the correct information that corresponds to that particular user. So when we take this entire flow right here, and we think about all the different steps that are occurring, there's only a couple of steps that are really relevant to us for trying to kind of like fake log into our application. So I'm going to highlight the steps that are actually relevant for what you and I are going to try to do. Once we understand which steps we need to kind of emulate to simulate or kind of fake logging into our application, we can then dive into those steps, get a better idea of how they work, and then use them to actually fake log in. So here's the part that we care about. All the yellow stuff over here, this is not relevant for the flow that you and I are about to put together for our testing suite. You and I are not going to touch Google servers at all with our automated test browser. We're not going to touch it one bit. We don't care about any of this Google stuff. All you and I are going to do is take some information and attempt to set it on the user's cookie. And when I say user's cookie, I'm talking about our Chromium instance. You and I are going to fabricate some information that kind of fakes a session and then set it inside of our Chromium browser. So then anytime our browser makes a request to the server is going to think that that browser is in fact logged in, even though they did not go through this entire flow right here. So that's the idea. You and I are going to do a very deep dive on these two steps right here and really figure out what's going on with those steps. And once we have a better idea of what's occurring during these two steps right here, we'll be able to kind of simulate or fake out that process with our Chromium browser. So let's pause right now. We're going to come back to the next video and we're going to get a better idea of how our server stores some information inside the user's cookie and exactly what information is actually stored. So quick break, and I'll see you in just a minute. In the last section, we spoke about how we need to get some better detail on what's going on with these last two steps down here. So in this video, we're going to walk through the authentication process inside of our browser. We're going to highlight a couple of different steps that occurred during that process, And then we're going to take a look at a diagram that's going to give you a better idea of exactly what Passport and cookie session are doing for us behind the scenes. So I'm going to flip back over to my application inside the browser, and you'll notice that I am not currently signed in. So make sure if you're following along, make sure you sign out at this point. I'm going to then open up my Chrome console, and I'm going to go to the Network tab here on the right-hand side. I'm going to make sure that I'm sorting by all requests, or I'm not doing any filtering at all right now. And then I'm going to go through my authentication process. So I'm going to click on Login with Google. Now we are asked to provide, or to select, an account on this list right here. So I'm just going to pick an account. It doesn't really matter which one. And then we automatically get redirected back over to our application. Now it seems to me like, hey, everything occurred as usual. But let's take a look at some of the requests that occurred during this process and get a better idea of what's going on. So I'm going to expand this a little bit, and we're going to take a look at some of the different requests that occurred. Now the very top request that you'll see on this list right here is a request that came from Google servers back over to our application. And if you hover over this link or this request right here, you'll see the full URL appear. So you can notice that that's localhost 3000 auth/google/callback. And then inside the query string is that code thing that I told you about. So that code is what our server takes and exchanges with Google servers for some more information about the person who just tried to sign in. So that matches up perfectly with the flow that we just saw over here. So that's where our server asked for more details about that user. Google responded with a user profile to our server, and then our server set some cookie on the user's browser. Let's see if we can't figure out where that cookie is set and kind of read some information from it to figure out exactly what's going on with the cookie itself. So if I click on this request right here and then go to headers and scroll down a little bit, you're going to see underneath the response header section right here. Make sure you're looking at response, not request. On response headers, there are two headers that were included when we made that request. So these are headers that are provided from our server down to our browser, or you can imagine like essentially to our user. There's one header right here called set cookie, and then another one right underneath it that says set cookie as well. These two set cookie headers are setting the value of session and session.sig. These two cookies right here, these two values that are stored inside the cookie, I should say, are what actually identify our browser to our server on follow-up requests that we make. So these two values right here, this session equals blah, 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 and session.sig equals blah, 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 are what identify us to our server when we make follow-up requests in the future. Our browser is going to automatically tack this data onto any request that is issued to our server. Now, what we have to do is figure out exactly what information is being stored inside this session thing right here. Because if we could figure out somehow what data is being stored inside that, then we can kind of copy that object or copy that data and then make use of it inside of our automated test suite. We can automatically set some cookie data on our Chromium instance, and that is what is going to convince our server that we are in fact logged in. So we need to get a better idea of what this long series of letters and numbers are right here. I'm going to highlight everything after session equals all the way up to the semicolon, like so. Okay, so I'm highlighting just that series of characters and numbers. I'm not highlighting the semicolon here or the path thing or anything else. And then I'm going to copy this value. We're now going to flip over to our terminal, and we're going to play around with this value a little bit. And I'm going to show you how you can figure out exactly what information is being stored inside your cookie. All right, so I'm going to go back over to my terminal. Now I'm inside of my project directory. You'll notice that I'm inside of a different terminal, so I still have my server running over here. And inside my project directory, I'm going to start up my node REPL again by writing out node. I'm then going to take that long series of numbers and letters that we just copied and assign it to a variable that I'm going to call session. Oops, I copied something else. That whenever I highlight something inside my terminal, it automatically copies it, and I always forget about that. Okay, there we go. So here's that long series of numbers and letters, and I'm going to assign it to the variable session. I'm now going to require in a module. This module is included with our package setup, so this is a dependency that you already installed when you install dependencies much earlier inside this course. So I'm going to say const buffer, like so, is require safe-buffer.buffer. And then I'm going to use this library, this module right here that we just required in, to kind of play around with this string a little bit. We're going to try to turn it into an actual JavaScript object so we can figure out what information is stored inside of our cookie. So I'm going to say buffer.from session, and then as a second argument, I'm going to pass in a string of base64, and then I'll say toString UTF-8, like so. This session variable that you see right here is actually a base64 string. So even though it looks like some complicated, crazy value, it's actually a value that you and I can easily turn back into a human readable object of sorts and figure out what actually exists inside of it. And that's exactly what this line of code right here is doing. So if I run that line of code, it turns it back into the object that is stored. So you'll see that our actual object, or our actual session, like the thing that identifies us to our server, is this object right here. It's an object that has a key of passport and then a value of another object inside of it. It says user and then another long string of numbers and letters right here. Now you'll notice that this long string of numbers and letters is like 5A85. This right here is our user ID, or the ID of our currently signed in user as stored inside of MongoDB. So I'm going to show you really quick. I'm going to flip back over to my browser, and I've already pulled up my imlab console right here. So here's our MongoDB database. I'm going to look at my users collection, and then inside of here, you'll see that I have one user inside my collection right now, and this user has an ID of, let me zoom in so you can see it very easily, 5A85, and then ending in F63C. Well, if I go back over, you'll notice that's the exact same ID right here. So the data that is actually stored inside of our cookie after we sign in is nothing more than a reference to some user stored inside of our database. So whenever a request comes into our application, there is a distinct series of steps that somehow parse this cookie and then make use of it inside of our app. So one last thing we're going to do in this video, and then we'll take a break. We're going to take a look at a diagram very quickly to figure out how this value right here is actually consumed by our application. All right, so here's our diagram. All right, so we can imagine that this diagram right here shows the series of operations that occur after someone signs into our app. Whenever our browser, like the user's browser, makes a request to our application, a cookie is automatically sent along that contains those two properties that we just saw inside of our request log. The first one is session, and the second one is session.sig. We'll talk about what this session.sig thing right here is in just a minute, but for right now, let's just focus on session. Well, okay, the first step of the diagram talks about it. Basically, session.sig, we will go into greater detail on it, but essentially that's a kind of signing thing that makes sure that you and I, or our users, I should say, to make sure that our users have not maliciously tampered with the session that has been sent down to them. Anyways, once this session property from the cookie comes into our server, the cookie session library automatically parses that property. It parses this thing right here, and it turns it back into a JavaScript object. And then it assigns that JavaScript object onto the request.session property. So I'm talking specifically about, like, if you think of any of our route handlers inside of our application, you know, like here's one right here. Here's a route handler. There's the rec object. So cookie session parses that session property and assigns it to rec.session. So rec.session would be equal to, like, you know, passport user is 5A85 and whatever else. So cookie session parses the cookie and places the value of it on the rec property. The request then gets forwarded on to Passport. Passport looks at that rec.session property. It sees that there is a user ID inside of it, and it tries to look up that user ID inside of our Mongo database. And then at that point in time, if Mongo is able to find a user inside of our database that matches that user ID, then Passport says, oh, okay, that request belongs to this user right here. the person who was just pulled out of MongoDB. However, if MongoDB does not, or excuse me, if Passport does not find a user who matches that ID, then it says, well, something's probably wrong here. The user is not signed in. But for the vast majority of the time, we're going to fall into this like positive flow right here, where we take some information out of the session and then Passport uses that to actually identify someone inside of our app. Okay, so this has been some pretty heavy stuff, but my intent here is to give you a better idea of how we take information out of that cookie by Passport to identify someone inside of our Mongo database. And then all the logic, all the business logic inside of our server then runs after that and says, okay, yeah, here's like the current user. Let's do something with them, get their blog posts or whatever else it might be. So the real takeaway here that I want you to understand right now is that the entire idea of authentication side of our application is tied to that session value that is stored inside the cookie. So what that means is that if you and I can somehow figure out a way to create a value, like that same kind of long string right here, if we could figure out how to create this value right here and have it match up to some user who exists inside of our database, then we could take this string that you and I will make, assign it to our cookie inside of our Chromium instance, and then our application is just going to magically believe that we are signed in. All right, so that's the final flow. That's what we're going to actually do here. It took a little bit of explaining to get to this point, but that's what we're going to try to do. So let's continue in the next video. We're going to do a little bit more deeper dive into figuring out how this session string right here is created and how we can actually place it on our cookie inside of our application. So quick break, and I'll see you in just a minute. In the last section, we had a discussion about how authentication and sessions work inside of our application. Now this stuff is pretty tricky. So in this video, rather than just steamrolling forward into the actual implementation of it, we're going to do a review of all the authentication stuff and all the session stuff. So I'm going to present all the same stuff to you one more time, but with a different set of diagrams. So I'm going to give you kind of an alternate way of understanding and learning this. If you already feel like you understand this authentication and session stuff already, that's totally fine. Just pause the video right now and continue on to the next section. Otherwise, stick around, and again, we're going to talk about the same stuff one more time, but we're going to use a different set of diagrams, just to make it a little bit more clear. Okay, so let's first begin by walking through the flow that occurs anytime a request comes into our application right now. So we're going to talk about how Passport and how the cookie session middleware work together to somehow authenticate a user when a request comes into our app from the browser. All right. So again, this is stuff we've already discussed, just a different set of diagrams to help you understand it. So on the left-hand side here, we've got our incoming request that flows into our browser, into the server, my mistake. So this is the request that comes into our server. When the request comes in, it is passed off to a series of different middlewares that have been wired up inside of our server. We saw these two middlewares, cookie session and Passport, inside of that index.js file. These two middlewares do some operation on that incoming request to modify it or basically just do something with it. So let's walk through the flow that occurs whenever cookie session runs. So the request goes to cookie session first. Cookie session is going to go through this series of 4 steps right here. Firstly, it's going to pull off the properties session and session.sig directly off of that cookie. Remember, we saw session and session.sig being set inside of our browser request log just a second ago. So here's where our application got where our browser got redirected back to our app. And you can see inside of here, session and session.sig were set. So now this information is going to be tacked on to every follow-up request to our server. After cookie session pulls those two properties off, it's going to use that session.sig property to make sure that the session itself was not somehow manipulated. So just a second ago, we took that session property, like that series of numbers and letters, and we put it into our REPL over here. And without any encryption keys or anything like that, you and I very easily decoded this into a plain, legible JavaScript object. So you might be thinking, well, where's the security here? Like, where's that security coming from? The security around our application to make sure that this session is not somehow maliciously manipulated by a hacker is that session.sig property. So session.sig is short for session signature, and that's what makes sure that someone has not somehow messed around with that value. We're going to dive deeper into that session.sig in just a moment in the next video, so let's again just hold off on that for a second. After cookie session verifies that the session has not been modified or tampered with in any way, it then decodes it into a plain JavaScript object with some code that is very similar to what you and I just wrote in the terminal. So like this line of code right here. So the session is decoded into a JavaScript object, and then the object is placed on the rec.session property of our request. And that's all cookie session does. Cookie session does nothing else. The request then flows from cookie session onto the next middleware, which in this case is Passport. Now internally, Passport looks at that rec.session property. So it looks at that object that was just placed on the request by the cookie session middleware. And it looks specifically for rec.session.passport.user. So in other words, it looks specifically for this ID right here. Passport takes that ID and then it passes it off to the function deserializeUser, which is defined inside of our passport.js file. Let me show you that function really quickly. So back over inside my code editor, I'm going to go to the services directory and then find the passport.js file. Inside of here, you'll find passport.serializeUser. And if you've ever worked with Passport before, chances are you've defined this function in the past. So the argument, the first argument to the inner function here is the ID. So this ID right here is coming directly off of that cookie session object. So we get that ID, and then it's up to our function, this code right here, to somehow take that ID and turn it into an actual user record. So we look inside of our Mongo database, we try to find a user with that particular ID, and then we call this callback right here with the user that we just found. So after deserializeUser is executed, you and I run our deserialize, or I shouldn't say that you and I run it, but Passport runs the deserialize function that you and I defined. It then takes the user that you and I return, and it assigns that user to the rec.user property. So then in all of our request handlers moving forward, you and I can get access to the current user by referencing rec.user. So after Passport has done that, the request then goes on to whatever particular request handler is being executed inside of our application. Okay, so that's the flow of cookie session in Passport. Again, my goal right now is to just give you all this information again from a slightly different angle, just to make sure you really understand what's happening here. Now there's a couple other things I want to talk about during this process and kind of talk a little bit how you and I are going to trick all this cookie session and Passport stuff into thinking that our Chromium instance is logged in. So here's what we're going to do. Actually, not this diagram yet. Let's look at the next one. Here we go. This is what we're going to do. So inside of our test suite, these are the steps that we're going to use to trick cookie session and Passport. You and I are going to create a new page instance. And remember that page thing is what represents a browser tab inside of our running Chromium browser. You and I are then going to take an existing user ID, and we're going to use that ID to generate a fake session object with it. So you and I are going to take some existing user ID, we're going to stick it into an object that looks like this, and then we're going to turn this object into a long string of numbers and letters like the one that you saw previously tied to our session. So you and I are going to essentially work in reverse here. We're going to take some known object and some known user and turn it back into our actual session. Once we turn it back into that session string, we're going to do this little signing part, which again is related to that session.sig property that we're going to talk about in just a moment. And then you and I are going to take that session and that signature, and we're going to forcibly set it on our page instance as a cookie. So then we can use that page to make a request to our application. The cookie will be sent along, and our server is going to think that our page instance actually is signed in, when in fact it is not. So again, that's the entire flow from start to finish. That's what we're going to try to do. So hopefully this alternate explanation has kind of answered any lingering questions that you might have. So let's take a pause right now. we're going to come back in the next video. We're going to finally do that discussion about that session.sig thing right here. We're going to talk about how that signature is generated and all that stuff, and then we'll actually implement this inside of our testing suite. So quick break, and I'll see you in just a minute. Before we start to implement all this authentication logic, there's just one last topic we have to cover, and that is this signature thing that I've mentioned a couple times but haven't really gone into great detail about. Session.sig is another property that is set on our cookie after we sign into our application. And as a matter of fact, when we used our request log to look at the request that actually signed us in right here, we saw that we not only got that session property set, but also the session signature right here as well. So let's take a second to talk about the signature and discuss exactly what it does. In the last two videos, we learned that that very long session property we've been working with was a base64 string, and that string represented our session. The session itself is an object that has a property passport with a nested object inside of it that tells passport exactly what our user ID is. So here's the thing. If someone was a malicious user inside of our application, they could take that session, the one that we just saw that's printed out very easily inside of Chrome. So without a doubt, it's very easy for people to somehow take that session property and get a handle on that string. You and I then took that string and wrote a tiny bit of JavaScript code to turn it into an actual object. So without a doubt, there was no encryption in that process. There was no password. There was nothing. Essentially, it's very easy to take that session string and then turn it into an object. Now that's not a one-way operation. We could just as easily take this session object right here and turn it back into an actual string as well, like this base64 encrypted string. So what that means is that if someone was using our application who is a malicious user, they could find their session object, they could then change their user ID to be someone else's, turn that back into a session string, and then set that on their browser instance. And then poof, they can magically log in and impersonate someone else inside of our application. Now obviously that is not at all ideal. So that's where this session signature comes into play. The session signature is our way to figure out whether or not someone has tampered with their session string. Let's take a look at a diagram that's going to help us understand how that happens. Okay, so this is a little equation right here. On the left-hand side, we have our session string. We then add it together with something called our cookie signing key. These two things put together and then ran through a cryptographic function result in our session signature. This cookie signing key right here is a secret string that we do not share with anyone outside of our application. So you and I, as developers, define a cookie signing key inside of our application, and we make sure that never gets leaked to the public. When we use the cookie signing key to kind of mutate this session right here and produce the session signature, it gives us a unique signature that cannot be kind of like reverse engineered without knowing the actual cookie signing key right here. Now the reason that the session signature is so important is that once our session comes into our application, we can kind of reverse this equation. So if someone sends in some cookie session to us along with a session signature, we can take the signature, combine it together, oops, don't want that, combine it together with the cookie signing key, and the result should allow us to verify that the session has not been tampered with. We'll see an actual example of this in code in just a second. So once we actually write out some code, it'll make a little bit more sense. Now before we write out the actual code to kind of test this, I want to show you where our cookie signing key is defined inside of our application right now. So if I open up my editor and then find the config directory and open up the dev.js file, inside of here you'll find where we define our cookie key. So again, this is a secret string right here, which should be unique for your application and never shared with anyone else. In the dev environment, which is where we're running our code right now, it's totally fine if someone else gets a handle on the cookie key because, hey, it's the dev environment, and we generally replace these secrets when we start to develop or when we start to deploy our application to a production environment. So for example, if you open up the prod.js file, which is where all of our environment variables sit for production environments, you'll notice that now the value is going to come from some environment variable. So when we actually move our application to production, we don't really have to worry quite so much about someone getting a handle on our cookie key. Okay, so now last thing I want to do is show you an example of this cookie signing key and the actual signature in action. So to actually kind of write some code that's going to generate this session signature right here, we have to understand the underlying libraries that are actually being used to generate the session signature. All right, so we're going to take a look at a diagram here. On the left-hand side are some of the middlewares that are being used inside of our application right now. We have a request coming into our app that then gets handled by the cookie session library. Now this is an NPM module that we installed into our project. This module has dependencies of its own. So another module that was installed into our project automatically when we installed cookie session was this cookies library right here. So this is also an NPM module. In turn, the cookies module has its own dependency called keygrip. So once again, this is also an NPM module. Keygrip is what is actually used inside of our application for generating and verifying that session signature. So in just a second, we're going to use this keygrip module to take our session string and sign it cryptographically. Before we do that, I want to show you the documentation for keygrip very quickly. I'm at npmjs.com and I did a search for keygrip. So this is the actual documentation for it. To use keygrip, we import the module, and then we call new keygrip, and we pass in a list of all the different cookie keys that we want to use. So that would be the cookie key that we just saw inside of our dev.js file. Once we generate that new instance of the keys object, we can then use it to sign our cookie, or we can use it to verify a cookie. So let's flip on over to our node REPL right now, and we're going to test out this entire process and see it occur in action. Okay, so I'm going to go back over to my terminal. I'm going to enter the node REPL by running the command node. And then the first thing I'm going to do is go and grab my session string one more time out of Chrome. So back at my request log, after logging in, here's my callback request right here. I'm going to find my response headers, and here's my session string. So again, I'm going to copy just that string of characters and numbers and nothing else. I'm then going to assign that to a new variable called session back inside my terminal, like so. Next, I'm going to require in the keygrip library. So I'll say const keygrip is require keygrip, like so. We'll then use our cookie key to create a new instance of keygrip. So I'll say const keygrip, and notice this time we are using a lowercase k here, equals new keygrip, and notice this is a capital K. And then we're going to pass in an array that contains only our cookie key. So at this point, I'm going to go back over to my config dev.js file, and I'm going to retrieve my cookie key, which is 123, 123, 123. So I'm going to paste that as a string inside of that array, like so. So now we can use this keygrip right here to not only generate our session signature, but also verify that the session string has not been tampered with in any way. So for example, I could write out keygrip.sign, and we will attempt to sign this session signature right here. So I'm going to pass in a string, and for just a second here, we're going to pass in a string that looks just a little bit strange, so bear with me for just 1 second. We're going to pass in a string that says session equals, and then we're going to join onto that string the session variable we just created. So a string that says session equals plus the session itself. When we do that, we get back our session signature right here. So taking notice of this actual session signature, mine starts with B31N. And if I go back over to Chrome and look at my original session signature right here, you'll notice that it matches up perfectly. Now, if I start to change my original session in any way, like let's say I do a keygrip.sign, and then instead do like this plus session, so I've got some distinctly different input inside of here now. When I sign that, it's a completely different result, like so. So whenever our session string changes, the resulting signature changes as well. Once we generate the actual signature, we can then again use keygrip to actually verify the session itself. So we can do keygrip.verify. We'll again pass in session equals plus session. And then as a second argument, we're going to pass in our actual session signature that we just generated right here. So make note that you actually want to grab the legitimate signature, not the one that like I just did as an example to show you how, hey, it just changed. So I'm going to get my real signature, and I'll pass it in as the second argument. Oops, did not mean to do that. Let's try it. Nope. Like I said, whenever I copy or highlight stuff inside my terminal, it automatically attempts to copy it. So sometimes that gets me into a little bit of trouble. Anyways, here's my session signature as the second argument. And then I get back true to mean, yes, this in fact is a legitimate signature. If I enter that again, but then change the signature, I get back false to say, hey, you know what? The signature and the actual data that you're trying to sign here, or that was signed, does not add up. So if we ever call keygrip.verify and we get back false, that means that our session must have been tampered with in some way. Okay, so again, this is what is happening behind the scenes whenever we sign into our application using cookie session and passport. So we now have a better idea of what both these libraries are doing, which means we can actually start to write some code that kind of copies or kind of fakes out this entire process. So you and I are going to take, again, let's go through that flow one more time. We are going to take, where is it? Right here. We're going to take our page instance. We're going to take an existing user ID. We're going to generate our session string with it. We're then going to use keygrip to actually sign that session string and generate a session signature. And then we're going to take both that session and the signature, and we're going to set them on our page instance. So that's the whole shebang. And hopefully it makes a little bit more sense at this point. So let's continue in the next section, and we're going to start walking through this entire flow. So quick break, and I'll see you in just a minute. We've now got a much better idea of the theory behind authentication inside of our application. So let's now take advantage of all this new knowledge and use it to somehow fake sign in through our automated test suite. Again, we're going to follow this flow right here. We've already taken care of step one, which is to create a page instance. That's taken care of inside of our before each statement. So we're going to go directly to the second step here, where we're going to take an existing user ID and generate a fake session out of it. Let's first go back over to our test suite, specifically our header.test.js file, and we're going to write out a new test inside of here. This new test is eventually going to contain all of our code to actually sign into our application. So I'm going to scroll on down to towards the bottom of the file, and I'm going to add a new test case inside of here. I'm going to give it the description of when signed in shows logout button. And then I'll define my async function as a second argument. So based on the description of this test right here, I think you get an idea of what we're going to go for. We're going to say that we're going to attempt to sign into our application inside of our test suite, and then all we have to do is verify that a logout button appears inside the header. I'm specifically talking about this logout button right here inside of our application. This logout button will only appear if we are truly signed into the app. Okay, so let's get to it. We need to now somehow take a user ID and generate a fake session object with it. The first thing we have to do is actually get that existing user ID. I'm going to open up my imlab console. Remember, that's where our MongoDB database is hosted. We're going to open up the console, and we're going to take our user ID directly out of there. Okay, so I'm back inside of imlab right now, and I've found my blog_dev database. I'm then going to scroll down a little bit and find my collection of users. So these are all the users who have signed up to our application through our OAuth flow. So I'm going to open up that collection. I'm going to find the only user that I've ever signed in as before, and I'm going to copy the ID of that user. Do triple check that you're getting the ID of the user and not the Google ID. The Google ID is this person's ID according to Google, and this is not relevant for us. This is solely a Google identifier. So I'm going to get the MongoDB ID, and then I'm going to copy it. I'm going to go back over to my test file, and I'm going to define a new variable called ID and assign that ID to it as a string, like so. Okay, so that looks good. Now the next thing we have to do, let's go back over to our diagram, is generate a fake session object out of that. So we're going to take that user ID and we're going to put it into a session object and then turn that session object into an actual string. Just like the one that we saw a little bit ago inside of our request log, when we actually, well, I lost the request log, but you'll recall the actual cookie session thing that we were looking at just a moment ago. So back inside my test suite, I'm going to first require in a library or two, and then we'll use those to actually generate the session string. So I'll say const buffer equals require safe buffer dot buffer. We'll then form up our session object, and remember the sort of syntax this thing had. The syntax here was an object with a key of passport that had another object inside of it that had a user property, and the actual value of that was the ID, or the user ID. So that's the ID that we just pasted in right here. Now the next thing we have to do is use this buffer library to turn the session object into a string. So underneath the session object declaration, I'm going to say const session string is buffer.from. We're going to pass in a JSON representation of the session object. So I'll say json.stringify session object, and then I'm going to chain onto this thing .toString base 64. I'm going to save my file here. That's going to cause my code to reformat itself. Now that's still kind of hard to read, so I'm going to do a new line in here just to make it a little bit more legible. And let's do a little bit cleanup. All right, that's much better. So again, we take that session object we just created, we turn it into a string with JSON stringify, we feed it into this buffer thing, and then call toString base 64, which actually turns it all into a base 64 string. So now session string right here, in theory, would be the exact same session string that we were looking at earlier. So now that we've got our session string, we need to use keygrip to generate the signature for this. Remember, the entire idea of using keygrip here is that we have to provide both our session string and the signature, otherwise our application is going to think that this is an invalid session and keep us from actually logging in. So I'm next going to require in keygrip. So I'll say const keygrip is require keygrip. I'm then going to also require in my keys file. Remember that keys file, or the dev.js file inside of our config directory, is where we housed our cookie key. So I'm going to require in keys, and that's what I'm going to call this kind of like keys thing we're going to require in. And I'll say require, and I'm going to go up one directory into the config folder, and then rather than requiring in the dev.js file directly, I'm going to instead require in this keys.js file. The purpose of the keys.js file, just as a very quick aside here, is to correctly require in a different key file depending on which environment we are in. So in practice, we require in the keys.js file rather than the dev or prod.js files. So I'm going to require in config/keys, like so. Now we can use keygrip and the keys that we just required in to generate a new keygrip instance. So I'll say const keygrip is new keygrip, and then I'll pass in as an array keys.cookieKey, like so. Then the last thing we're going to do, at least for right now, is to take our session string and the keygrip library and sign the actual session to generate our signature. I'm going to abbreviate this thing as simply sig, short for signature, like so. Then this is going to come from keygrip.sign, and again we're going to pass in that slightly different thing like session equals plus session string, like so. As a quick aside, we are using the session equals thing, session equals plus session string, just because that is internally how the cookies library does this. There's really no great reason for adding on session equals right here. It's just what the library chooses to do. So there's not necessarily a technical reason for this. You could go read the source code of the library if you want to, and you're going to see that they just kind of arbitrarily also pass in this session equals part in here. Okay, so that should generate our session string and our signature. Now before we actually try to do anything else here, I think we should probably try to console log out these two values and just make sure that we generated the correct values. So at the bottom here, I'm going to console log out session string and sig, like so. So let's now run our test suite. We're going to look at these two values and just verify that they look correct. And by look correct, I do mean that they should actually match the exact strings that we saw inside of our browser a little bit ago. So I'm going to flip back over to my terminal, and and I'm going to run npm run test again. Now we'll wait for our test to actually execute, and like I said before, it usually takes me just a minute because I'm running a screen recorder. So there's browser 1, browser 2, and I think we will get a third browser for our last test as well. And then we should see, yeah, there we go. All right, so I see my session string right here, and then the signature right after it. And just by eyeballing it, I can definitely remember the original session string I had. This is definitely identical to the one I had before. So I definitely have generated the correct session string and the correct signature as well. So now the last thing we have to do is take the session and the signature and set them on our actual Chromium instance as cookies. And then once we do that, we can use that Chromium instance to attempt to sign in to our actual application. So let's take a quick break and tackle that last step in the next video. In the last section, we verified our session string and the signature. All we have to do now is take these two pieces of information and set them on an actual cookie on our Chromium instance. Now that might sound like something that's a little bit challenging, but in fact, this is actually going to be the easiest part, believe me. So let's take a quick glance at our Puppeteer documentation to figure out how we manipulate cookies on a running browser instance. So I still have my Puppeteer documentation open right here. You don't have to pull this up unless you want to. I'm just going to point out one particular function that is available to us. So if I scroll down a little bit, I can find class page right here. So remember, a page object represents a tab inside of our browser. I'll then scroll down a little bit and find the function called setCookie right here. Okay, so here's cookie. So with setCookie, we can pass in an object that has properties name and value. And that's pretty much it. That's how we set a cookie on a page instance. After we set these cookies, we can then refresh the page, and that page instance will then be treated as though it's signed in to our application. Now, the last thing I want to mention here is that if we do not attempt to set the domain when we set the cookie, we have to first navigate to our actual application and then attempt to set the cookie. That's something that we are already doing inside of our application most of the time, and like in a lot of our tests, but I just wanted to point it out. So when we launch the Chromium instance, we have to navigate to our application and then set the cookie. That's how we associate a given cookie with a specific domain. Okay, so let's go back over to our test file. Here's the console log that we were using just a second ago. So I'm going to remove this. I'm then going to make sure that we first navigate to our application. So I'm going to say await page.go2 localhost 3000. And you know what? I think that we're actually already doing this inside of our before each statement. Let's go check that really quick. So if I scroll up, okay, here's the before each, and yeah, actually, you know what? We are correctly already navigating to our application. So we don't have to go there again. So I'm actually going to remove that line of code I just added. Okay, so now that we are definitely at localhost 3000, we can use that setCookie function to set a new cookie on our page. So I'll say await page.setCookie, and then we have to pass in a name property. So this is going to be the name of the cookie and the value for it as well. Now we haven't spoken a lot about the cookie names here. Just a real quick aside is that whenever we define a value inside of a cookie, we are defining a key value pair. So I have to actually specify the name of the cookie that I want to use here. If you don't recall exactly what we're supposed to use, we can actually go reference the cookie that we already have inside of our browser right now for the actual legitimate login that we did previously. So right now I'm logged into my application. If I open up my Chrome console, I can then go up to this application tab that should be inside the console header. I can then go to the cookies section on the left-hand side and then localhost 3000. Now you might have a bunch of cookies inside of here. Okay, you might have a lot of other values stored, but that's totally fine. That just means that you've ran other applications in the past that attempted to set cookies on your localhost 3000 domain. I very purposefully deleted all my other values inside of here, except the one you see right here, ahead of time. So all I have to do is make sure that the values we're actually looking for here, the name is session for the session string, and then session.sig for the session signature. Those are the two names of the cookies that we're going to try to set. Okay, so back over here with our set cookie, we're going to say name of session, and then a value, and that's going to be my session string. And then we're going to repeat that same process with a signature as well. So await page.setCookie. We're going to give it a name of session.sig. Again, that's coming directly from session.sig right here. This is what is expected the name to be. And then we're going to use a value of sig, like so. Okay, now before we do anything else, after we set these cookies, we are going to refresh the page. So we're going to refresh the page so that it kind of simulates us actually logging into the application. If we just set the cookies, it's not going to actually change any of the content on the screen. We have to actually refresh the page. That's going to cause the entire app to re-render, and then we should see an updated header appear. So I'm going to say await page.goto localhost 3000, like so. And then for this time, we're just going to wait right here. Let's not try to do any assertion or anything like that. Let's try testing this out, just verifying that everything works as we expect, and then we will worry about writing an actual test that verifies that the logout button actually appears. So let's try running our test suite now and seeing what happens. Before we run our test though, we only really want to run this test. We don't really care about the other two inside this file. To make sure that we only run this test right here, we can say test.only, like so. And that means that inside this file, only this test right here is going to be executed and the other two will be ignored. So that's just going to save us a little bit of time. Now the other thing I want to do very quickly before we run this is I want to go back up to our after each statement right here where we were previously closing the browser, and I'm going to comment this out because I want to be able to look at our Chromium interface and I want to actually be able to say yes, we are in fact logged in. So I'm going to comment out that line, I'll save this file, and then we're going to go and run our tests again. Okay, back at the terminal, npm run test. We're going to wait for our browser to appear any minute now. There we go. And now you're going to see it go to localhost 3000 one time, and then it's going to very quickly flash again. So what just happened there was we went to localhost, we saw the login with Google button appear, we set our cookies on the Chromium instance, and then we re-navigated or kind of refreshed the page at localhost 3000. And when we did so, you'll notice that we now see the header content of my blogs and logout. See what that means? Well, that means we just faked our server out, and we have now successfully logged into our application without having to go through that entire OAuth flow. And more importantly, we also did not have to put in any backdoor for our authentication stuff. Our server is 100% secure. The only kind of weakness to this approach is the fact that that cookie key is being consumed both from inside of our application and also the test suite. But in reality, that's not a bad thing. Our test suite is tightly coupled with our server codebase. So if we have some cookie key that has to be shared between those two sides of the project, that is completely a-okay. And the other thing to keep in mind is that cookie key is a secret that is always going to change when we actually deploy our application to production. So it really doesn't matter that we're using that cookie key in development mode at all. That cookie key could go out in the wild, someone else could get a copy of it, and that only means that they could sign in to our development environment, which of course is running on our local laptop. So no one else is going to be connecting to that server. Okay, so we did a lot of content here in the last couple of videos, and I think we've now got a far better understanding of how authentication works between cookie session and passport inside of a typical application. So now that we are able to actually log into our app successfully, let's take a quick break. We're going to come back to the next video and continue working on our test setup. We are now considered to be truly signed in to our application. Before we move on, we need to finish up the test that we were just working on. So remember, the purpose of the test that we are writing right now is to verify that when we are signed into the application, we in fact see a logout button inside the header. So we need to do the same thing that we're going to do with just about every test that we're going to write. We're going to get a DOM selector that tries to find this button right here. We're going to pull some text out of it, and then we're going to write an assertion about the value of that text. Let's first start off by writing a selector to get this element right here. So I'm going to right click on it. I'll do an inspect, and then I'm going to zoom in on this just a little bit so you can see it easily as well. Come on. Yeah, there we go. Okay. So if we look at the element that we just selected right here, we've got the anchor tag. So we need to somehow get a selector for it. I see the right class right above it, but if we just try to do like .right with a child of anchor, it's actually going to attempt to select this my blogs link instead. So we can actually write a selector that tries to get an element based on properties that it has been assigned. So I think that we can actually attempt to select this anchor tag right here based on its href property. So let me show you an example of that. We can do something like anchor, and you can see my autocomplete here is actually kind of telling us what we're going to do. So we're going to do anchor and then a square bracket. Let me go a little bit larger so you can see it more easily. A square bracket, and then we're going to look for the href property. We're going to say href equal to, and then the actual link that we want to find. And then we'll close off that square bracket like so. And then I'll close off the overall string selector and the parentheses as well. Now, one thing to keep in mind here is that I'm using single quotes for the entire selector and double quotes for the inside path right here. If I used single quotes in all these locations, then this would be interpreted as an unclosed or unterminated string right here. So that's why I'm using the two different sets of quotes like so. All right, so if we run this, we will see, in fact, yep, we get our anchor tag appearing on the screen. Very good. So let's now go back over to our test. We're going to write out a little bit of code to select this element and pull some text out of it. Okay, so I'm back inside my test file. I'm going to go down to the bottom of the file here, and I'm going to write out some code that's going to attempt to get that element. So I'll do await page.$eval. So remember, this is the same function call that we did much earlier, the same one right here. So we have a first element or first argument of our selector, and then a second argument of the function to run once that element has been found. So our selector in this case is going to be an anchor tag with an href property of auth logout, like so. And again, please triple check to make sure that you're using two different kinds of quotes here. So we're going to get this element, we're going to select it, and then as a second argument, we'll pass in a function that's going to pull off the inner HTML property. So I'll do L, which is short for element, and I'm going to return L.innerHTML, like so. And then finally, I'm going to assign the result of this entire line to a variable that I'm going to call text, like so. Okay, so that looks good. Now the last thing we have to do is write out our actual expectation. So I'm going to say expect text to equal logout, like so. All right, I like it. So let's try running our test now, and we're just going to see what happens. Before I actually run them, I'm going to make sure that I kill the running Chromium instance. So I'll do another quit on Chromium. I'll then go back over to my terminal, and I'm going to run my tests again with npm run test. Now, when we run these tests, I'm going to tell you right now, we are going to see the test fail. Okay, I'm just telling you that right now so that you don't see your test fail and then pause the video. Okay, so as you see right here, it says when signed in shows logout button. However, you and I just saw 2 seconds ago that the authentication stuff was working correctly. And if we even open up the Chromium instance that just got launched for us, you'll see that the logout button is in fact visible. And heck, if we rerun that same selector that we used just a second ago, like let's do it again. I'll do anchor tag href auth logout, like so. Yep, element is definitely there. So what the heck is going on here? Well, here's the issue. And this is a little bit of a gotcha. This is a tough one to troubleshoot, believe me. The problem here is that all the code that we are writing inside of our test file is being executed as fast as it possibly can. So when we call setCookie right here, and then the next setCookie, and then the page.goTo, and then the eval, all these operations are being launched and executed as fast as the browser can possibly do it. So when we run this eval function right here and attempt to find this element, the page has not even been finished loading on the screen yet. So our application can't even render fast enough to satisfy Chromium. This line of code right here is rendered before our React application even has a chance to fetch the current user and decide what set of buttons to show up inside the header. So in other words, we need to somehow kind of slow this entire process down just a little bit. Now we could put in some code here that introduces some arbitrary like pause. We could say, hey, just wait for like 1 second. We definitely could do that. But fortunately, Puppeteer has a slightly more convenient function that's going to make this kind of waiting process a little bit more clear and a little bit more efficient. So I'm going to go back over to the Puppeteer documentation one more time. So here's our documentation. I'm going to find the page class one more time. Here it is right here. And I'm going to look for a function called WaitFor. So right here. Now you'll notice that there are actually a whole set of different WaitFor functions. So we're going to use one of the more basic WaitFor functions. When we call WaitFor, we pass in a selector for some element. Puppeteer will then wait until it is able to see that element on the screen. And then once it is actually visible, it will then resume execution of all of the other steps that we have laid out for it. So in other words, right above where we tried to do this eval statement right here, we can add in a WaitFor statement that says, just hold up for a second, wait for this element, like this anchor tag that we're looking for to be visible, and then actually run this eval statement. So right above that line, I'm going to add in a await page.waitFor, and then we're going to pass in the element that we are attempting to wait for. So I'll do anchor tag, href, auth, logout, like so. Now one thing that's kind of interesting to notice here, I don't want to call this like a flaw in our testing logic per se, but it's kind of just something that leads to not the most clear or obvious test in the world. The issue here is that if this anchor tag never actually appears, like if our application truly is broken, then the test is going to fail on this line right here, because we're just going to be always waiting for some logout button to appear, and it's never going to appear. So if this test ever fails, it's actually going to fail on this line right here, and it's probably not going to get to the actual expectation down here. Again, this is just kind of like a trivial little thing. The test is still going to behave the way we expect, but I don't know, it just feels a little bit strange. Anyways, I just wanted to mention that. Okay, so let's try running this again. So I'm going to save this file. I'm going to, for the millionth time, close Chromium manually, and then I'm going to go back over to the terminal and run npm test again. All right, so we only have to worry about that one test running, so it should only take a second here. There's our Chromium instance, and now you see that the test actually passes. So if we open up the browser, absolutely nothing has changed over here. All we did was introduce some tiny little pause to allow the React application to finish rendering everything on the screen. Okay, so that's pretty much it. We have ridden this test through all the way to completion. So we now have the ability to somehow sign into our application, wait for some content to be displayed, and now we can start to write entire other sets of tests, like tests that make sure that we can, say, create a blog post, or see a blog post, or whatever else we want to do. So let's take a pause right now. We're going to come back in the next video and continue working on our test setup. In the last section, we got our first test around authentication working. That's great, but we still have a lot of work to do. We're going to first continue by doing a little bit of cleanup inside of our test file. So I'm going to close my Chromium instance, and I'll go back to my header test.js file. Inside of here, I'm going to find the test.only statement that we had, and I'm going to clean that thing up, because we definitely want to have all of our tests run all the time. I'm then going to go back up to the after each statement, and I'm going to uncomment the browser.close statement here as well. Cool. So now we're back to working order. Now I want to look at the test that we were working on just a moment ago. So this is the one where we are attempting to sign into our application. Right now, we've got a whole bunch of code inside of here that has the sole purpose or the sole job of trying to just authenticate ourselves in our application. We had said previously that there's probably a lot of tests that we're going to eventually want to write that require an authenticated user, or kind of like an authenticated instance of Chromium. So I can very easily imagine that we're going to eventually want to run all this authentication logic right here again and again and again for a bunch of different tests. Now I don't know about you, but I definitely don't want to copy paste this into every test. You might be thinking, okay, that's fine, like let's put this into a before each statement. Well, remember, whenever we use a before each statement, that only works for the file that it is written in. So even if we use a before each, we would still have to duplicate all this code to every different file inside of our test suite. Now, all those approaches don't sound very good. So I think that we need to take all this authentication logic right here and move it to some other file. And I think it needs to be centralized in one location. If this sounds at all like the caching stuff, the caching refactor we did earlier in this course, yeah, it's pretty much the same thing. Basically, we just need to clean up this code base. Now, we're going to move all this authentication logic into what is called a factory function. So let's take just a moment to explain exactly what a factory function is. All right, so the idea of a factory is a function that is used to generate some test data. When I use the term factory, this is not something that is associated with Jest or Puppeteer or Cookie Session or Passport or anything else. This is just a name for a type of function we might make. And we call it a factory just because whenever we call it, it automatically assembles some data and returns it immediately. So we can reuse these factory functions that we might make throughout our entire testing suite to very easily create a lot of data without having to always rewrite all the code or logic to create that data inside of every test file that we create. I think that we are going to eventually end up with 2 factory functions inside of our test suite. I think we should make one factory function called the session factory. And we'll say that the job of this function is to create a new session, like I'm talking about the actual session string right here, and the actual signature right here as well. So we'll say that the session factory is going to create a session string and a signature and return it. And it's not going to do anything else. The session factory is not going to attempt to manipulate our page object or anything like that. The only job of that factory function is to make the session string, signature, and return it. That's all. I think we should probably also do something very similar for our users that we might need to create as well. At present, we have a hard-coded user ID inside of this test right here. So if we ran our tests 100 times, we would always be attempting to log in as this same exact user every single time. Now this is kind of a faux pas of sorts in the testing world. We really do not want to use the same object or same record inside of our database in this case over and over and over with every test run that we do. It's way too easy to accidentally have some data from some test that we ran previously leak into another one, and that's definitely something we want to avoid. So ideally, we would create a brand new user for every test that we run. We would create a new user, save it to MongoDB, and then log in as that user. So in summary, I think we need to create a new session factory to make a session and a new user factory to make a new user and save it to MongoDB and then use with the actual session factory as well. So let's take a pause right now. We're going to come back in the next video and we're going to make these 2 factories and then do a little bit of a refactor to our current code base, or at least the test file right here, just to be clear. So quick break and I'll see you in just a minute. In the last section, we spoke about how we were going to create 2 new factory functions inside of our test suite. One is going to create a new session, the other is going to create a new user. So let's get started right away. We're going to first begin by creating a session factory. We're going to do this refactor incrementally. So in other words, we're going to create that session factory, and then we're going to put that back into this test file right here in place of all this logic. And we'll just make sure that everything still works, and then we'll come back and do the user factory as well. So 2 separate stages. Inside my test directory, I'm going to make a new folder called factories. So eventually this folder right here might contain a bunch of different folders, or a bunch of different files, each of which contain one factory inside them. And remember, a factory is a function that creates and returns some common resource that we might want to use throughout our test suite. Inside the factories directory, I'm going to make a new file, and I'm going to call it session factory.js. Then inside of this file, I'm going to create and export a new function. So I'll say module.exports is an arrow function, like so. So this is the function that we're going to call whenever we want to create a new session. I'm then going to go back over to my header test.js file. Here's the authentication test we were just working on. I'm going to copy a lot of the code that we just wrote in here because we don't really have to rewrite it all again. So we're going to copy and cut it all over to that session factory.js file. I'm going to highlight everything from the buffer line right here all the way down to where we create the signature right here. So about these 12 lines or so, however many that is, 13. So I'm going to cut that section right there. I'm left with just this code inside the test file. I'm then going to go over to my session factory and I'm going to paste it inside of here. Now we're going to do a little bit of a refactor to this code inside of here. At present, whenever we call this function, we would be requiring in the key grip library again and the keys file and all that other stuff. And we definitely don't need to require those every time we call this function. Instead, we're going to move all these require statements up to the top of this file so that we only have to require them in one time. All right, so I'm going to first start off by moving the buffer statement up to the very top outside of our function. I'll then grab the key grip, keys. Actually, I think, yeah, these 3 lines right here. So I want key grip, keys, and the key grip instance as well. I'll cut all of those and I'll put them up at the top as well, like so. Next, I'm going to do a little bit of cleanup inside the function body itself, just to remove some white space, like so. And then finally, I'm going to make sure that we take the session string right here and the signature and return them from this function. Remember, that's the entire idea of this factory function, just to create a resource and return it. The function is not going to attempt to actually set the session on the page instance. We're going to do that somewhere else. So after we create both the session string and the signature, we'll then create an object that contains both the session string and the signature and return them both. So I'll say session is session string and sig, which we'll use as an abbreviation for signature, is sig, like so. Now to be clear, this does not have to be an object. We could just as easily return like an array that contains both the session string and the signature, but I think an object makes a lot more sense. The other thing I want to point out here is that we've got session referencing session string. I think that session string is probably a poor label for this variable at this point. I think we could just call this thing session, just by itself, just the word session. So I'm going to find all the locations where we use the term session string. So here's one, and here's one, and I'll refactor all those to be simply session instead. After I do that refactor, you'll now notice that the key and value for both of these key value pairs are identical. So we can use a little bit of ES 2015 syntax to condense this down to just session and sig, like so. Okay, so this looks a lot better. Let's do a quick check of all the variable names we have inside of here. So we've got session object, that looks good. Session, key grip is defined up here. Sig, that looks good as well. One other quick thing I want to take care of before we leave this file, we just created a new nested file inside the factories directory. So the keys require statement that we have right here doesn't quite work anymore. We've only got the single ... right here, which means only go up one directory. Before, this require statement was inside the test directory, so the require worked out just fine. But now that we're nested inside of factories, we need to add in one additional ... like so. Okay, I think the session factory looks pretty good. The last thing I want to mention about this, and I swear this is the last thing, notice that whenever we create the session object right here, we are referencing a variable ID, but ID is not defined anywhere inside this file. So we need to assume that from this point on, at some point in time, we are going to pass in a user ID or an actual user model into this factory. So if we pass in a user model here, it should then return a session that corresponds to the user that we pass in. So what you and I are going to eventually do, once we create this user factory as well, anytime we need to log into our application, we will first call the user factory to make a new user. We'll take that user and then pass it to the session factory, which will make a new session that represents that user. So I think you can kind of get the idea of how once we have a lot of these different factories, we can kind of chain them together to kind of emulate a broad sequence of events occurring inside of our application. So that's what we're going to eventually do. For right now, let's just assume that we're going to pass in a newly created user model, like a Mongoose model, into this function. So we will accept that as an argument called user. And then rather than referencing ID right here, we will pull the ID off of this user model and use that as the person that we're going to log in as. So I'm going to replace ID with user._ID like so. Now this code right here, there's a little bug with it, and this is a super big gotcha. Okay, this is something that I really would not expect you to ever catch on your own. When I wrote this code right here originally, I definitely didn't catch it, and I had to do a little bit of debugging to figure out exactly what was going on. When we are working with Mongoose models, and that's what we are going to assume user is right here, they always have this ID property, and that is the user's ID. But here's the gotcha. The user model, or excuse me, the Mongoose model ID property is not actually a string. It's actually a JavaScript object that contains the user's ID. So if we take this session object as we have formed it up right now, and then turn it into, or try to stringify it with json.stringify right here, it would also try to stringify the object that contains the user's ID right here. So user._ID is actually a JavaScript object. So before we try to turn this thing into JSON, we have to turn that object into a string. When we call toString on it, it takes the string out of the object and it just prints that string by itself. Again, this is a super big gotcha and really not something I would expect anyone to catch the first time around. Just a little thing that you have to know, or a piece of trivia about the Mongoose library. Okay, so I think that's it for our session factory file. This looks pretty fantastic to me. So we now have a single function that we can call with a user and get back a session and a signature for. So let's take a pause right now. We're going to come back to the next video and we're going to wire this factory up to our header test file. So I'll see you in just a minute. In the last section, we put together our session factory.js file. Let's now go back over to our header test file and start to wire this thing up. So here's my header test file. This is the remainder of all the test logic we have inside of here. I'm going to require in that session factory at the top of this file, and then we're going to call it and get back our session string and our signature, which we're going to use on these two set cookie lines right here. So I'm going to go up to the top of the file, and I'll add in a require statement for the session factory. We're going to go in the factories directory file and get session factory, like so. So now I'm going to go back down to the test at the bottom, and I'm going to add in a call to session factory. Remember that session factory returns an object that contains a session property and a sig property. So I'm going to immediately destructure those out by saying session and sig, like so. And we'll call session factory. Now here's the only problem. We can't quite run this code right now because the session factory requires a user to be passed in to correctly generate the session and the signature. So we're going to create that user factory here in just a second. Once we do, we'll create that new user on like this line right here, and then pass that user into the session factory directly. So again, we can't run this code just yet, but we will be able to in just a minute. Before we move on, I'm going to clean up the ID declaration right here, because we don't want to use this fixed ID. Instead, we're going to want to use that user factory to make a new user for us. So I'm going to clean that thing up. Now, one other thing we can take care of right now, notice how we have the property called session and sig right here, but our setCookie function is referencing session string. So this variable does not exist anymore. We're now calling it simply session. So I'm going to replace session string with session. Cool. I know a lot of this refactor stuff that we're doing right now is just a little bit tedious, but trust me, we just have to get through a little bit more refactor, and at the end, we're going to have a really neat test setup. I would love to just jump to the very end and say like, okay, here's what our test setup looks like, here's all this code, but if I just show you the completed product, or if we just write that completed product out from the get-go, believe me, it will not make a lot of sense. So unfortunately, we have to start with the kind of like very straightforward kind of imperative approach where we write out every line of code directly. but once we start to do the refactor and we get that completed product, it's going to make a lot more sense at the end. So let's continue in the next section. We're going to start putting together that user factory, and then we'll be able to rerun our test suite and make sure that these factory things are working the way we expect. So quick break, and I'll see you in just a minute. In this section, we are going to start working on our user factory. Remember, the purpose of this factory thing is to just create a new user, save it to MongoDB, and return it. We'll then be able to use that in conjunction with our session factory to automatically log in as a brand new user every time we start our test suite, and for every test inside of it. Inside my factories directory, I'm going to make a new file called userfactory.js. Inside of here, we're going to start off by requiring in the Mongoose library. We'll then get access to the user model and use that to create and save a new user. So I'll say const mongoose equals require mongoose. I'll then make a function that's going to serve as the actual factory function. So we'll say module.exports, like so. I'll then pull off the user model from mongoose, and let's do that outside the function. So we'll say const user is mongoose.model user, like so. And then we can use the model class right here that we just pulled off to create and save a new user. So inside the function, I'll say return new user. I'll pass in an empty object for right now, and then I'll call .save on it, like so. We haven't looked closely at the user model before, so very quickly, inside of my models directory, I'm going to find the user.js file. So here's the schema for a user model that gets saved to MongoDB. You'll notice that it has a Google ID property and a display name. Both these properties right here are retrieved from Google's OAuth flow. I'm going to tell you that right now there's nothing inside of our application that actually makes use of that user ID, of that display name, or the Google ID. In theory, if we were making use of them, we would want to somehow generate like a random Google ID right here and a random display name. And we could pass those in as properties to this user before we attempt to save it. But again, our application is not actually making use of that data right now, so I'm not going to attempt to fill those properties in here. But this would be a perfect location to do so, and that's really the purpose of a factory file or a factory function like this right here, to automatically generate some data for us, save it, and then return that as a resource. All right, so that's pretty much it for the user factory file. So this one is definitely far more straightforward than the previous factory file that we put together. However, there is kind of a little bit of hidden complexity here. There's something that you might not quite anticipate. So I would tell you that if we ran this file right now inside of our test suite, we would actually get a pretty nasty error message. And that error message would say something like, Mongoose has no idea what model user is. It would say, hey, I'm Mongoose. I don't know what model user is. What are you talking about? Even though you and I just looked at a file a second ago that very clearly defined model user right here. So why would we see that error message? You know, we could definitely go run our test suite, but we might have another error or two to have to worry about as well. So let me be a little bit more direct and tell you exactly what's going on here. You see, whenever we run Jest, it starts up a new node environment executed from our command line. Jest then looks for all the different files inside of our project that end with the extension .test.js. And we discussed that quite a number of videos ago, right? Jest then loads up that file, like any file that has specifically that extension, and it executes that file alone. What that means is that right now, we can kind of consider our project looking like this right here. We've got our project directory. Inside there, we have our test folder with some test-related code. And then outside that, we have all of our server-related code. Because Jest only executes our test file and nothing else inside of our project directory, none of our server code is executed in the same environment as our test code. Now that's not being super clear, so let me get a little bit more clear. What I'm trying to get at here is that if we try to get access to anything related to Mongoose or anything related to anything inside of our server, we're going to get an error message unless we very explicitly require it into somewhere inside of our test file. So for example, for the initial configuration of Mongoose, like to tell Mongoose to actually connect to our MongoDB instance, we are doing that inside of our index.js file right now. So here's the index.js file, and around line 13 or 14, you'll see where we actually issue that connect statement right here. When we run our test suite, the index.js file is not executed. It doesn't get executed by Jest. So if we ran our test suite and then required in Mongoose and tried to do something with Mongoose, this line of code never got ran in the context of our test suite. So Mongoose would not be connected to our database and we would get that nasty error message. And the same thing goes for our user model file as well. This user file is not required or executed by our test suite. And so that means that if we tried to get access to this user model from inside the user factory, we would see an error message that says, hey, I don't know what the user model is. And that's because this file was never executed. So we have to make sure that any time that we want to use some code that we are kind of like assuming has been executed by our server project, we have to actually require that into our test suite at some location. So let's take a break right now. We're going to come back in the next video and we're going to make sure that we not only somehow require in the user model file so that Mongoose knows what a user is, but we're also going to make sure that we have some distinct location where we tell Mongoose to actually connect to our running MongoDB process. So we're going to take care of both those steps in the next video. In the last section, we spoke about how code is not automatically shared between all of our test files inside the test directory and anything else inside of our actual project. Remember, when Jest runs our code base, it finds just our test files and executes these files. So unless this file actually tries to require in, say like the user file right here, this thing will never actually be automatically executed by Jest. And so Mongoose will have no idea about the user that was created inside of here, or the user schema that was created inside there. So in this section, we're going to fix that. Now, like I said, we could just directly require this thing in, but then the question becomes, well, where are we going to require the user file in? And where are we going to write the logic to tell Mongoose to connect to our MongoDB database? To have one central location to do all this kind of like common setup stuff, we're going to make a global setup file. This is going to be a file that it gets executed one time by Jest whenever it first starts up. So we can use this one file to do some common setup that needs to occur for every test inside of our test suite. To make this file, I'm going to create a new file inside my test directory, and I'm going to call it simply setup.js. Then inside of here, we're going to do some common setup that we need for every test inside of our test suite. Right now, the two requirements we have are to require in that user model so that Mongoose knows that the user collection exists. Let's do that right away. So I'll require in up1 directory into the models folder, user, like so. So now just by requiring this file in, it will execute the contents of that file when Jest starts up, and so Mongoose will know what a user model is. Then underneath that, we're going to require in Mongoose and make sure that it gets connected to our actual MongoDB database. As a reminder, our Mongo database URL, or URI, is listed inside the dev.js file. So here's our Mongo URI. So we have to require this thing in and feed the Mongo URI into Mongoose. One other quick thing, just as a very quick aside here, remember that this project has the convention of requiring in the keys.js file, because the keys.js file will decide upon which of those other key files to require in based on the current environment. That doesn't really matter for right now, but later on when we start pushing our project to a continuous integration server, it will make a difference. So we're going to require in the keys.js file rather than the dev.js one directly. All right, so back inside of setup.js, I'm going to require in Mongoose. I'm going to require in our key file. We're going to go up1 directory, config, keys, and then we're going to tell Mongoose to connect to the Mongoose URI that is defined on this keys object right here. So I'll say mongoose.connect keys.URI. Mongo URI. And notice these are all capitals right here, and this is an I, not an L. We're going to also do a little bit of other Mongoose record keeping. So these are just some other tasks that we have to do just to configure Mongoose properly. So I'm going to pass in a second object here, or second argument. It's going to have a property use Mongo client true. We're adding this thing on right here just to avoid a deprecation warning. That's really annoying. The other thing we're going to do on the line right above this is mongoose.promise, and notice how promise has a capital P. We're going to set that equal to global.promise. So by default, Mongoose does not want to use its built-in promise implementation, and it wants you to tell it what implementation of promises we should use. So right here, we're telling Mongoose to make use of the node.js global promise object. So again, just a little bit of record keeping or administrative work with Mongoose. Okay, so you might think that's it. Well, unfortunately not quite just yet. You see, we call this file right here setup.js. Jest does not automatically look for this file called setup.js right here. So I just called this file setup because I thought it made sense. But Jest does not automatically look for some global setup file to execute. We actually have to tell Jest very forcibly and very directly, hey, before you start to run our test suite, try to load up this file and execute all the setup code inside of it. Trust me, last step, almost done here. Let's do this one last thing. To tell Jest to run the setup.js file, we're going to add an option object to our package.json file. So inside of package.json, anywhere inside of here, but outside of a nested object, so for me, I'm just going to put it directly above the script section, we're going to define a new key value pair. So I'm going to say Jest is an object like so. I'm going to make sure I get my comma in right there. And then we're going to pass this thing an object that's going to tell Jest to try to execute our setup.js file whenever it first starts up. Now the option name here is kind of long, so bear with me. It is setup test framework script file, like so. Yeah, that's a long one. Do triple check the capital letters that are inside of here. So we got a capital T, capital F, capital S, and a capital F. I personally always accidentally put a capital W here, but there's definitely not one. Okay, so this is the option name, and then we have to give it the path to the test setup file that we want it to execute. So we're going to pass in the path to tests setup.js. So we're going to do /tests setup.js, like so. Okay, so that's pretty much it. So now, whenever Jest starts up, it's going to try to load this file. And then inside that file, we've got some common logic that needs to be executed for every test that is ran inside of our test suite. We should now be able to require Mongoose into any of our test files and freely make use of it to access our database. So I think that we're just about set here. I think the last thing we have to do is go back to our header test file and require in our user factory to this thing and actually make use of it inside of our authentication test at the bottom. So let's take a quick break and take care of that in the next video. Our user factory is now all put together along with our session factory. So let's require our user factory into our header.test.js file, and we're going to wire up that user factory to our authentication test. At the top of this file, right underneath our require statement for session factory, I'm going to also require in user factory, like so. So factories, user factory. There we go. Now I'm going to go down to our authentication test. Here it is right here. Remember that we have to create a user and pass it into the session factory. That is going to be the user that we attempt to kind of fake log into inside of our application. So right above that line, I'm going to say const user is user factory, like so. Now one quick thing, remember that when we call user factory, it returns the result of new user.save. This is an asynchronous operation right here. It takes some amount of time for Mongoose to reach out to our MongoDB instance and save a user and then get confirmation that it was successfully saved. So this line of code right here returns a promise. And we have a return statement right here to return that promise from this function. So in order to wait for that promise to be resolved and then run all the other code inside of here, we're going to put the await keyword right in front of it like so. So again, user factory is returning a promise. So we have await right here to make sure that we wait for the user to be saved and then take the result of that and assign it to the user variable. So now we can take this user and pass it off to the session factory. For probably the third or fourth time, I know I've repeated this many times now, you're probably tired of me saying it, the session factory expects to be passed a user, and that's going to be the user that we sign into our application as. So I'm going to take this user and I'm going to pass it off to session factory. Okay, so at this point we've got a pretty good refactor. Now we haven't really accomplished that original goal that we had of take all the logic inside of here and put it into some other more reusable location inside of our code base, or at least the testing suite, but we've at least dramatically simplified down at least this block right here. So we're going to run our test suite right now. We're going to make sure that at least this stuff works, and then we're going to figure out a better solution, like the final goal here, the target of what we really want to do for really refactoring this code right here into a truly reusable location. So this is kind of like a stop-off point, just to make sure that our factories are working the way we expect. So I'm going to go over to my terminal and I'm going to run my test suite just to make sure this stuff works. So we'll do our npm run test. We will wait for browsers to pop open. Okay, there's one, there's two, and then here's our authentication test coming up. Hopefully this one works. Let's see what happens. All right, hot dog, it worked. So here's our test right here. It says when we signed in, it showed us the logout button. Perfect. So it looks like our refactor is working a-okay. So now we're going to have a lot of fun for this next step. Well, depending on what you call fun, I guess. But we're now going to take this code right here that we said we really want to kind of like generalize and make much more usable. And we're going to start to think about some location inside of our test suite where we could put this stuff and very easily call it many times from all of our different test files that we're going to end up with. So let's take a quick break and we'll tackle that in the next video. In this section, we're going to start to think about some different ways that we can take all this authentication logic and put it into a more reusable location into our test suite. I'm going to make one suggestion in this video. We're going to kind of walk through this first possible way of doing the refactor, and then we're going to end up going with a slightly different path. Okay, so I'm going to make one suggestion, we're going to talk about some issues with it, and then we're going to go with a slightly different direction. So the first suggestion that I'm going to have here, the first suggestion I'm going to make for refactoring this code right here, would be to somehow attach a new function to our page instance that would be responsible for running all of this login logic right here. Let's take a look at the logic itself. We create a new user using that factory, we call the other factory, but then everything else that we do to sign ourselves in is related to the page instance. So it kind of seems like this is a job for the page variable right here. So one way we could approach this would be to maybe add on a new function to that page instance. We could do something like a new function called login, like so. So maybe we would attach this function to the page class, and whenever we call login right here, it would run all that authentication code that we just had on the screen just a moment ago. Adding on a function like this would be extremely clear for future engineers walking onto our project. I think anyone could reasonably look at this line of code right here and understand, oh, okay, if I call the login function, that's going to log me into the application. So I think that this would be one approach that we could definitely take. Now this approach is very similar to what we did in the last section when we were working with caching. You'll recall that we took that query class provided by Mongoose and we kind of injected and then later added in new functions to that class. So I'm basically making the exact same suggestion here. I'm saying let's take that page instance or that page class and add in a new login function to it. Just to kind of see what that might look like in practice, let's go look at the Puppeteer source code repository and get a better sense of how we might add in a new function. Okay, so I'm going to go back over to my browser. I've again got my Puppeteer GitHub repo right here. And I'm going to find the source code for the page class. So inside the lib directory, which is where all the Puppeteer code actually lives, I'm going to open that thing up, and then inside of here, I'm going to find the page.js file right here. So here's page.js. Inside of here, you can scroll down a little bit, and around line 32 or so, you'll see very plainly that, yep, there is a thing called the page class. And then down at the very bottom of this file, that page class gets exported for use by other pieces of code inside this library. So it would be absolutely trivial for us to add in a new function to this class right here. Let me show you an example of how we might write this code. So I'm going to go over to an empty page very quickly here. So we might try to require in the page class directly by writing out something like Puppeteer, lib, page. And I think they actually use capital P page. So this right here would be the page class. We could then add in a new method to that by writing out something like page.prototype.login is a function. And then we would put all of our authentication logic directly inside of here. So in practice, it might look like, I don't know, that pretty much. Not too bad. Now we're using the await keyword inside of here, so I would mark this function as async. And then the only other thing we would have to fix is to make sure that we are not referencing a page variable anymore. These are all functions that are available on the page instance itself. So we would now update all these page things to be this, like so. So that would be pretty much it. This is a very straightforward approach right here. However, you know what? We did this before, right? We did this over in the caching section. We already figured out how to take a library and kind of add in new functions or override existing ones. So even though this right here would be absolutely an A-OK approach, I feel like, hey, you know what? This is a course, right? This is an advanced course. Let's try figuring out something a little bit more clever and maybe something a little bit more fun that can help us learn a little bit more about JavaScript. So let's take a pause right here. We're not going to take this type of approach, and instead we're going to use a new feature of JavaScript included with ES 2015 to come up with a slightly more clever solution for creating this kind of like login function right here without having to kind of monkey patch or reach directly in to an existing library. So a quick break, and we're going to figure out this alternate approach in the next video. In the last section, we spoke about how we would take a different approach than monkey patching than to somehow extract out all this custom logic right here that we need to repeat for many different tests inside of our testing suite. So in this section, we're going to flip on over to a code editor that allows us to just very quickly write out some test code, and we're going to start to kind of explore a couple of different ideas. So I definitely have a target in mind of how I want to abstract this logic out, and we're going to start to play around with this idea. All right, so I'm going to go over to a CodePen that I've already set up. So this is a CodePen right here. It's basically a REPL of sorts. If you want to follow along, you can go to codepen.io and create a pen of your own. On the left-hand side, I've got a JavaScript code editor, and then on the right-hand side is a console. So anything we console log from this code over here will appear in the console. So we can do like console log hi. Yeah, obvious enough. Now, one thing I'm going to put in here right away at the very top, and this is just to make this console behave nicely, is console.clear, like so. Console.clear is going to clear out any existing records inside the console, and that's just to make sure that repetitive console logs don't just keep stacking up over and over on each other. Okay, so that looks good. Now, I want to kind of play around with some code in here just a little bit. We're going to define our kind of an imaginary page class, very similar to the one that we just saw inside of the Puppeteer actual library itself. So I'm going to start off by making this kind of imaginary page class that you and I are going to want to somehow extend or add functionality to without trying to like overwrite methods on it. So I'm going to write out class page. I'm going to give it a method of, how about goTo? Whenever someone calls this, we're not going to actually do anything per se. We're just going to console log out, I'm going to another page, like so. And then maybe we will give this one other function as well. How about set cookie? And whenever someone calls that, we'll do I'm setting a cookie, like so. Again, my goal right now is just to get some kind of analog or analogy to that class that we just saw in the actual library code itself a moment ago. So this is the class right here that we want to somehow add functionality to without actually reaching into it and manipulating how it's set up. So you might be thinking, all right, Stephen, you know what? That sounds like a classic case of where we might want to use the extends keyword that comes along with ES 2015 classes. Well, that's definitely one good take. So we could do something like class custom page extends page, like so. And then we could add a function to this thing called login. And inside of here, we could do all of our login logic. This is textbook subclassing right here, or extending some base class. When we extend page, we borrow all the methods, all the functionality set up inside that parent class, but then we also add our own custom methods in as well. So this might seem like a very clear and simple solution to what we're trying to do, to somehow extend or give this page thing right here some login function. There's just one problem with this. Yes, we absolutely can set up a subclass like so, but the problem is that you and I cannot easily instruct Puppeteer to use this custom class. We cannot easily tell Puppeteer that whenever we use a browser object to launch a new page, we can't easily say, hey, when you launch that new page, don't use the page class and instead use this fancy class that you and I just came up with. That's the problem. This would be a very elegant and very clear solution right here, but we unfortunately cannot tell Puppeteer very easily to use this extended class. So unfortunately, this is not quite going to be a solution here. Using the extends word is not going to be a good way out. So I'm going to take that off. Okay, so clearly that doesn't work. So I'm going to take out that login function for just a second here. And then just to clear things up, because I'm going to write a little bit more code here in just a second, I'm going to put these two functions on a single line, just so we can see everything without having to scroll all over the place. Okay, so that looks good. So we still have class page right here. And I don't know, I still kind of feel like making the second class of some custom functionality that you and I want to implement might be like a reasonable idea. So here's my second thought. If you and I cannot extend the page class, maybe we could somehow wrap it with the custom page right here instead. Let me show you an example of what I'm thinking of. So maybe we could do something like whenever a new instance of custom page is created, our constructor function gets called, and maybe we will say that you have to call this thing with an instance of page. So we'll take this page right here, we'll kind of assign it to some interior or internal variable like this.page equals page, and then we could set up all of our login functionality. So we could say call login, and inside there we could say this.page.goto, maybe we go to localhost 3000 or whatever, and we can do this.page.set cookie, and set whatever other cookies we want to set as well. So this approach right here would definitely, has some merit. This might work out. Let's try writing a little bit of pseudocode of sorts right underneath this to kind of figure out what this might really feel like when we start working with it. So now maybe we would say something like const page equals new page. And you and I very well know that this line of code in reality would look something like browser or const page equals browser.launch. We've written that line of code at least once so far. So we actually use the browser to create a new page, but in this case, let's imagine that we're doing it this alternative fashion instead. So then we can use this page instance right here to create a new instance of custom page, and we'll pass the page in when it's created. So we could say const custom page is new custom page, and we'll pass in our page instance like so. So now we could very easily call custom page.login, or we could do something like, and you'll see like, cool, it's actually using those internal functions on the page instance to manipulate it in some fashion. But the downside to this approach is that if we still want to interact with the underlying page, we would have to do something like custom page.page.goto. And that would get us to actually call that goto method. Now, I don't know about you, but I definitely don't want to be saying like custom page.page all the time. We're only trying to really add in like one function right now. And besides this one function, we're really going to always be working with that underlying page object all the time. So I want to make sure that it's really easy for us to access that underlying page without having to write out .page over and over and over again. So this approach definitely feels like there's some merit to it, but it feels like there's something just kind of off here because we have this kind of namespace variable inside of here. So let's take a quick pause right now, and we're going to do a little bit of brainstorming to see if there's not some way that we can fix this issue where we have to always be referencing .page, .page, .page to access that underlying page variable. So quick break, and we are going to do some further investigation in the next section. In the last section, we wrote out a little bit of example code to kind of experiment a little bit and figure out how we might take that base class of page that is defined inside the Puppeteer library and somehow extend it with some additional behavior. We came up with the idea of creating a second class. The second class would be called with an instance of page, and it would save a reference to it. This custom class right here could then implement all of its own methods, making use of the underlying page object as well. This pattern right here definitely works. It definitely works out just fine. And we could definitely take this pattern and totally run with it and build out the login function and be totally happy. However, as we start to write our tests, we would have to be creating this custom page thing. And then whenever we want to access a function that is assigned to that underlying page, we would have to write out something like custom page.page.goto. Now again, this is totally fine. We could take this solution and say, we're going to say custom page.page.goto or custom page.setCookie.goto or excuse me, page.setCookie, let's be clear, or whatever else. So these are totally fine solutions as it stands right now. But here's the thing. I'm really lazy. I don't want to have to be writing out .page over and over again. I want to just call custom page.login, .goto, .setCookie, and have this custom page thing always do the right thing. So I want custom page to somehow figure out whether or not to use a method defined on itself, or instead take this function call and somehow use that underlying page object instead. So I want custom page to figure this stuff out for me, and I don't want to have to figure this stuff out for it. Now you might be thinking, okay, well, Steven, that seems like a real pain, but let's give it a shot. Maybe we could do something like define every method that exists on that underlying page. And so we might do something on here on the custom page of goto, and whenever you call goto, you would say something like this.page.goto. And we could rewrite, or we could write functions like this for every function that exists on the underlying page. But you know what? That's also way too much work. Not going that far. I don't want to have to write out every function that exists on the underlying page and somehow set up this intermediate function on my custom page either. That's also way too much work. Now that's a very long segue into this section. In this video, we're going to talk about some tool in the JavaScript language that we can use to somehow teach custom page to decide whether to call a function on itself or the underlying page object that we had assigned in the constructor. So starting from right now, we're going to do a little bit of a detour, and we're going to learn about something else, some advanced feature inside of JavaScript, and how we can take that feature and apply it back to solve the issue that we're running into right now. So right now, detour begin. Let's talk about this other topic. All right, I'm going to pull up a diagram here. So this is a totally unrelated thing. It's going to seem completely unrelated right now, but as soon as we have a better idea of how this other thing that we're going to discuss works, we're going to pull it back to that page stuff and make it all work very nicely. So here's the detour. Let's imagine for a second that you and I are working on some project where we are bringing in a library that has a greeting class. This greeting class might have two functions assigned to it, a function called English and a function called Spanish. Each of these functions can be called to return a string that represents basically hello in the given language. So in other words, if we call English right here, it would return the string hello, and if we called English, it would return the string hola, which is Spanish for hello. We're going to place a constraint on this class though. We're going to say that this is a class implemented by some library that we installed into our project. And you and I do not, under any circumstance, want to ever try to modify this class. We don't want to modify it no matter what. So in case you can't quite tell just yet, we're kind of imagining this thing eventually is going to be like the page class. But let's just kind of leave it as greeting class for right now. Okay, so with that in mind, we've got this class right here. Let's now take this example one step further. Let's say that we are working on our project and we are using the greeting class to translate from English to Spanish or generate the correct greeting, whatever it might be for. But we eventually realize that we need to also have greetings for German and French as well. So we did say that we cannot change the underlying class right here, but we do want to have these other types of greetings as well. So maybe you and I create a second class called more greetings. More greetings might have a function called German that returns the string hallo, which is German for hello, and a function called French, which returns the string bonjour, which is French for hello. So now you and I have two classes, one that returns greetings for English and Spanish and one for German and French. Now, I don't know about you, but I don't really want to have to write a whole bunch of code that somehow determines whether or not I need to access the greetings class or the more greetings class. I would love to just have one single object that I can always get access to, that I can always rely upon giving me some particular greeting. In other words, if I need a greeting in English, I don't want to have to write some code that decides to call this function or call this object or this object. I want to just say, give me a greeting with English. Boom, there it is. I'm done. So we're going to investigate some tool that we can use to kind of intermediate or broker or kind of manage access to both of these classes at the same time. So this is where something called a proxy is going to come into play. Proxies are a feature of JavaScript that were introduced with ES 2015. Proxies allow us to manage access to some target object or multiple target objects. We could wire up a proxy that manages access to both the greetings class and more greetings class. Then anytime that we would want to access some given greeting function, rather than calling greetings class directly or more greetings directly, we could instead access this proxy object right here. And the proxy object would essentially decide what to do for us. The proxy object would either access greetings or more greetings, depending on what function we are actually trying to execute. So this proxy thing right here is going to solve this greetings problem. And as you might imagine, it's also going to solve that page stuff that we were just running into as well, because we could eventually set up a proxy that decides whether to access the page class or custom page. But we'll get back to that in just a little bit. Let's take a pause right here. We're going to come back in the next video and we're going to write out a little bit of sample code to get a better idea of how proxies behave. So quick break, and I'll see you in the next video. In the last section, we went off on a little bit of a detour to talk about ES 2015 proxies. We've now seen a little bit of a couple diagrams about them. We're now going to flip over to a code editor and write out a little bit of code to simulate this greetings and more greetings stuff. So I'm going to go over to CodePen. I've got another pen here open. Here's the original one. I just went ahead and opened up a second one. Inside of here, we're going to write out a little bit of code to simulate that greetings and more greetings class. At the top, I'm going to first start off with another console.clear, like so, just to manage the console and keep it nice and clean. Then inside of here, I'm going to write out a very simple implementation for that class greetings. So we'll say this is a function English that will return the string hello. We will also do Spanish that will return a string hola. And then I'm also going to put together an implementation for more greetings as well. So class more greetings. This is going to have German, which will return the string hello. And we'll also have French, which will return bonjour, like so. Now, after these two class declarations, I'm going to create a new instance of greetings and more greetings. So I'll say const greetings is new greetings, and then const more greetings is new more greetings. So now we can very easily do a console log and do something like greetings.english, right? There we go, and we get our string hello. No surprise there. So far, this definitely all looks like normal, traditional JavaScript. However, like we've been mentioning all along, we have these two separate objects that more or less had the same set of responsibility. The only reason that we did not combine them into one single object was that we said that we did not want to somehow mess with class greetings at all, because presumably this is being provided by some third-party library. And wherever possible, we try to avoid reaching into third-party libraries and messing with their internals. So now we have these two separate objects and we want to somehow combine access to them. So we're going to create, right after these two declarations, a new proxy. We can create a proxy by writing out new proxy like so. Hey, that was easy, right? Proxy is a new function constructor, or a constructor function, that is included with ES 2015. This is a global function, so it's not something that we have to require in, or import, or install as a module, or anything like that. We can just freely access new proxy like so. This constructor function takes two separate arguments. The first argument is what we refer to as the target. The target is the object that we want to broker access to, or we want to manage access to. So I've said several times now that we can use a proxy to manage multiple objects, and we'll talk about how we work in multiple objects in just a second, but for right now, as the first argument, we're going to pass in a single object, and that's going to be the more greetings instance. So I'm going to say more greetings like so. Then as a second argument, we're going to pass in something called the handler. The handler is an object that contains a set of functions. And these functions are executed anytime we try to get access to that underlying target object right here of more greetings. The handler object is going to have a single key assigned to it called get. And then that's going to have a value that's a function. This function right here takes two separate arguments. The first one we referred to as target. Now just a second ago, I also said that this first argument right here was referred to as target as well. So in truth, this first argument of target is a little bit unnecessary. Like they just threw it in for fun almost. So this argument target right here is identical to this thing right here. So really all it's doing is taking this first argument that we passed into new proxy and throwing it into this function for us. We can almost just completely ignore this argument target for right now. And I almost recommend you do. Just kind of forget it exists for just a little bit. Now the second argument here is far, far more interesting. It's an argument called property, like so. Now without saying anything about what property is, I'm going to write out console.log property, like so. Now I want to use this proxy, so whenever we call new proxy, it actually returns a new object that represents the proxy that was just created. So I'm going to take the proxy that was just made and I'm going to assign it to a new variable that I'm going to call all greetings, like so. Now underneath all this, I'm going to reference all greetings dot French, like so. And I'm not going to put any set of parentheses on there. I'm just going to say all greetings dot French. And when I do, you'll notice that I get a console log over here of French. I didn't get bonjour, as you might expect. I got simply the string French. So the console log that we see over here is coming from this console log inside of the get function. This get function, or the get keyword over here, takes whatever property we are trying to access on the proxy itself, and it calls the function that is assigned to that get key. The first argument is the target, and then the property is the actual string name of the property that we are trying to access. So in this case, you and I are trying to access the property French right here. So this, as a string, is passed in as the second argument because we are trying to get that property. So whenever we try to get a property, this function gets called rather than the actual function that you might expect to be called or referenced. Now we're not limited to only trying to access or reference properties that actually exist on the underlying target. We can try to access any property we want. So even properties that don't exist. And now you'll see the console log has updated to even properties that don't exist. So once again, we tried to access a property on the proxy. Because we are accessing it or trying to read it, that is referred to as a get operation. So this get function right here intercepts that call and it runs this function right here instead. It provides the property name of what we're trying to access as the second argument, and then inside the function itself, you and I console log that property. Now we can easily kind of return this to the behavior that you might expect for a normal object. So given that this target right here is more greetings, and the property is the function that we're trying to access, we could do something like return target at property, like so. So now if we did all greetings dot German, that would return a reference to this actual German function right here. Or at least it should. I think I have a typo in here. Let's do a quick check. What do I have? Nope, nothing right there. Let's change target right here. Let's do just more greetings and be a little bit more direct. Oh, it's because I'm not actually console logging anything. That's my mistake. I'm sorry. So down here, I want to do console log. Totally my mistake. I apologize. Okay, that's much better. So now, whenever we reference all greetings.German, this get function is called. The target is the instance of more greetings that we passed in as the first argument right here. So target is more greetings, and then we are trying to look up the property called German on that. So if we reference target.German, that returns to us the German function that is actually defined inside the class. So we just console logged out the entire function itself, and we could actually invoke that function by adding on a set of parentheses like so. And now it turns into the original allo. Okay, so we've said all this stuff about proxies is kind of about like intermediating access to multiple objects. But right here, you clearly see that we are only trying to moderate or manage access to one object, the more greetings object right here. But we can very easily modify the contents of this function right here to instead include references to multiple different objects. So let's say that we try to access some property on the proxy itself called English. Well, English is not defined on the target of more greetings right here. It doesn't exist. More greetings only has German and French. However, we can modify the get function right here to not only look at more greetings, but we can say if this property is not found on the target of more greetings, then you know what? Also try and look at that greetings object and look up this property on greetings as well. So I can say greetings with property. So now, anytime I look up English on more greetings, that doesn't exist. That returns undefined. So the OR statement right here goes on to the second case where we look at the greetings object and we try to look at the English property on there. Again, you can imagine property right here as being like the string English because we're trying to reference the property English. So because the greetings object does have a English function, that gets returned instead. So all greetings.English returns the function that was defined up here, and then our set of parentheses right here actually invokes that function. We could just as easily remove these parentheses, and it would instead just print out the English function itself. But we usually don't want to just reference a function. Usually we want to actually invoke it. So of course we put it on our parentheses like so. Okay, so this has been a pretty crazy little introduction to ES 2015 proxies. And I'm sure it's still very confusing, but at the end of the day, I think that what you can agree with me about is that we can use a proxy, we could set up a target with it, and then anytime we try to access a property on that proxy, we can redirect that access to other sets of variables or objects inside of our application. So to give you a little bit of a preview of what we're going to eventually do, you can kind of imagine that we are going to create a proxy that is governing access to both our page and custom page classes. And then anytime we try to access any property off of either of those, we're going to first look at, say, the page. And then if that has no actual variable available to it, or if that function isn't defined that we're looking for on page, we'll look at our custom page instead. So between one of these two variables, they've got to have the property we're actually looking for. And rather than having to reference both page and custom page, we can use just this one proxy and have it govern access to both those objects. So let's take a quick break right now. We're going to come back to the next section, and we're going to use a proxy to intercept calls to both our page and custom page. So quick break, and I'll see you in just a minute. In the last section, we got a lightning quick introduction to ES 2015 proxies. We're now going to take that knowledge, and we're going to go back to our page and custom page example and figure out some way to encapsulate all the behavior of our page right here inside the custom page and still not have to make all these repetitive accesses to .page. I'm going to first start off by cleaning up a little bit of code here. So I'm just going to take out the custom page references and that browser.launch thing, and I'm just going to leave behind page and custom page like so. I'm now going to create a proxy that's going to intercept any access to custom page right here, and then inside the get handler of that proxy, we're going to decide whether we want to reference page or custom page. So I'm going to say const super page. Let's call it super page to say like this is the final version of the page, really. And we'll do new proxy. We'll pass in our custom page as the target, and then as the second argument, it's going to be our handler object with the get function on it. That get function has arguments target and property. Then inside of here, we're going to take that property that we're trying to access, and we're going to first look it up on our custom page. And if that property doesn't exist on the custom page, then we're going to try to reference the property on page instead. And heck, you know what? Now that I'm thinking about it, we don't even really have to look at page directly. We could look at the page that is referenced by custom page, but really they're the same thing. So let's just write our code. We're going to do return target at property, like so. So remember, target is the custom page. And then if that thing does not exist, we'll do or page property, like so. So now we can use this super page that combines both the behavior of page and custom page. So now down here we can call superpage.goto, superpage.setCookie, or superpage.login, like so. And then after I get that quick refresh, you'll see all the appropriate console logs appear. So the first console log is the goto, the second one is the login statement, or excuse me, the setCookie statement, and then the login generates both these two right here. Okay, so we've now successfully combined both our page and custom page by using this proxy thing right here, and we don't have to worry about referencing that like underlying page manually or anything like that. So this is definitely pretty useful at this point, but we now have to take this knowledge and somehow think about how we're going to easily reproduce it inside of our project. So we very likely want to always be creating a new page and custom page for every single test that we run. You know, that's definitely what we're doing right now. At present, in our before each statement, we're using that browser to always make a brand new page. So I'm going to clean up these super page calls right here. And I think that you could kind of imagine that maybe we take this logic right here to make a page and custom page, and we could wrap it all up inside of a function called build page, like so. So now anytime that we want to create a new page, we could call build page. That will create the underlying page. It'll create our customized one. It'll combine them together into the super page. And then down at the bottom here we will return super page. Oops, just like so. So now we could call build page inside of all of our before each statements and get this combined custom object that combines the two together. Now this definitely works right here, but as soon as you start seeing something called like build page like this, there's usually a slightly better pattern that we can follow. You see, the custom page is really the thing that is getting involved with all this proxy stuff. In other words, if we did not have custom page, we wouldn't be using a proxy or defining build page or anything like that whatsoever. So one thing we might do to put this function right here into a slightly better location inside of our code base is to define a static function on the custom page class. That custom, or that function, that static function, we could call something like build, and we could use that to actually define the new page, the custom page, combine them together in the proxy, and then return the result. Now this is probably another part where you're probably saying like, what the heck are you talking about here, Stephen? I know this stuff is getting really deep. I know it's super hard, but just one last little change I want to make here. So I'm going to take all this logic right here, everything out of build page. I'm going to cut it. I'm going to delete all that. We're left with just our two classes right here. And I'm going to define a static function on custom page. So I'm going to say static build. And I'm going to put all the stuff that I just copied directly in here. Now, if you've never worked with a static function before, static functions can be called without actually creating an instance of the underlying of the class itself. So now we could directly call custom page with capital C, because now we're working directly with the class, .build, like so. And that will create a new super page for us and return it. So I could say const superpage and then superpage.login or superpage.goto or whatever else. And now all that logic to build the page, the custom page, and the proxy are all encapsulated directly within the custom page class itself. Okay, so this has been one crazy little whirlwind right here, and you're probably thinking, how in the world did we get here from talking about testing? This is so far not related to testing at all. You can't believe it, right? I know this is very like off the rails at this point. We've done quite a detour. But honestly, this was the original goal of this course. The course was not quite just to show you how to do testing and how to do caching and stuff like that. You can figure that stuff out by grabbing some library and use it inside your project. And the real goal of this course is to show you some really advanced stuff like this. You know, how many other times have you found some somewhat legitimate use of proxies in a project? You know, hopefully you can take this knowledge now and use it inside of your own projects to kind of take multiple different objects or things and combine them together into one common thing. All right, but that's enough of my soapbox. We now got a better idea of how to build some custom class like this right here that wraps up page but does not actually modify it in any fashion. We can still add on our own custom functions that work with that other class, and we don't have to really worry from anything that's using our custom page right now. We don't have to worry about whether we are working directly with the custom page or with the underlying page itself. So all we really have to worry about is calling custom page.build, and that's it. We then use that thing that gets created all over our project, and we can freely add functions to it without having to worry about modifying the underlying page class. So this is enough of proxies for right now. Let's continue in the next section. We're going to start putting together this actual custom page class inside of our project. We're going to build in that static function thing, and we're going to build in all this proxy stuff to it as well. Again, I know this is some pretty crazy stuff right now, but as soon as you see the final product, I am absolutely convinced you will agree with me that this is a pretty sweet testing setup, and it's going to look really, really nice. So let's take a quick break. We're going to come back to the next video and start this actual implementation. In the last section, we finished up a long discussion on proxies and static methods and all that kind of stuff. We're now going to take all that knowledge back to our testing setup and start to create this new custom page class that's going to broker access to all of our Puppeteer logic. It's going to combine all of our Puppeteer stuff into one single class, and it's going to end up being a very elegant interface for accessing all the browser automation aspects of our test suite. So hopefully I've sold you on this at this point, so let's start getting to the actual implementation. Inside of my test directory, I'm going to make a new folder, and I'm going to call it helpers. So this is going to be a directory that's going to contain a bunch of different tools that we might need in many locations inside of our test suite. I'm going to create a new file inside of here, and I'm going to call it simply page.js. Then inside of here, I'm going to start off by requiring in Puppeteer. Like so. Then underneath that, I'm going to create my custom page class. and we're going to start to set up a static method, some login function, and all the other stuff we've been discussing. So I'll say class custom page, like so. Now just so you know, the name custom page right here, I'm putting in just for your own personal clarity. Personally, if I were building this myself, I would call this thing simply page. But since Puppeteer also has a class page, in the context of a course, it would probably get really confusing really quick. Because I would say class page, and you would say, what, the one we're making or the one from Puppeteer? So I would personally call this thing page, but we are going to call it custom page instead, just for clarity's sake. And really to drive that point home, we even called this file right here page rather than custom page. But I think you get the idea. Okay, so now inside of here, I'm going to define a static function called build. This build function right here is going to generate a new Puppeteer page. It's then going to create a new instance of custom page, and then it's going to combine the two together with a proxy object, and then return that. So eventually, we are going to require in custom page to some other file. We'll make a new instance of custom page by calling custom page.build. And then we can, do the login function or whatever else we want. Now there's one little issue that we haven't quite discussed. We've been saying that, oh yeah, we're going to use this thing to just make a new page. We're going to say new page coming from Puppeteer. We've been saying that over and over again. But as you and I very well know at this point, we create new instances of pages by using that browser object. So we have to create a browser in order to create a page. Well, that definitely makes life a little bit more confusing. But you know what? Actually, at the end of the day, the fact that we have to create a browser to make the page is part of what is going to make this entire proxy thing work so darn well. So watch this. Now that we've got some understanding of how this proxy stuff works, I'm just going to let the code fly. We're going to write this stuff out, and we'll talk about exactly what's happening and how we're going to use it inside of our actual test suite. So inside of this build function, we're going to start off by first launching a new browser instance. So I'm going to say const browser equals await puppeteer.launch. We're going to pass in, for right now, our headless false option, because we do want this thing to appear as the actual UI. We're going to eventually come back and customize whether or not this is always false on the fly, but for right now, we'll just always leave it as false. Now we've used the await keyword in here. So we have to also mark this function as being async. We can very easily mark a function as being both static and async. There's no issue with that whatsoever. Now, after we create the browser, we can use that to create an actual page instance. So this is going to be the actual Puppeteer page, like the thing that we're trying to manage access to. So I'll say const page is await browser dot, new page, like so. We've now got our browser and our page. So now we're going to create our instance of custom page and then combine them together with a proxy. So I'm now going to say const custom page, is new custom page. And then I'm going to pass in to this constructor function right here, both a reference to the browser and the page. You know what, actually, I think do we need the browser? I think we only actually need the page in this case. No, we need both. Nope, just the page. So we're going to pass in only the page, like so. So let's quickly define that constructor method and make sure that we save a reference to page. So I'm going to say constructor this dot page equals page, and that's coming from the page argument like so. So now whenever we create a new instance of custom page, we're going to save a reference to it on this dot page. And then finally, at the very end here, we're going to create our proxy and return it. So this is what's going to actually combine access to our custom page, our page, and in this case, we're actually going to include browser into this proxy as well. And you'll see why in just a second. So we're going to say return new proxy. We're going to use a target of the custom page. We're then going to define the handler object. We're going to do our get function that takes the target and the property. And then whenever someone tries to get access to this proxy, and for the given property name right here, we're going to first look at the custom page to see if that function has been defined or that property has been defined on it. Then we'll look at the page, and then we'll look at the browser. So I'm going to say return custom page property or page property or browser property, like so. So now with this one proxy, we are combining access to 3 different objects that have been created. So what this means is we can add functions to custom property and call them. We can also directly access the page, and we can also directly access the browser as well. You might be a little bit curious, why do we throw the browser on here as well? Well, in reality, when you think about our test suite right now, you and I do not care about the fact that the browser and the page are separate objects. Let's go back over to our header test file really quick. So back over here, we create the browser, and then we use the browser to make the page. So what is the point of the browser object? All we ever use the browser object for is to make a new page and then eventually close that browser. We use the browser for nothing else inside of our test suite. So by including the browser into that proxy, we never have to worry about working with the browser directly ever again. We can just use all the functions on the proxy itself to manage access to the browser and close it or do whatever else we need to do with it. So that's why we are including it on the proxy. Okay, now we are combining access to all 3 into this proxy, and then we return it. Now the last thing we need to do is make sure that we actually export this custom page at the very bottom of this file. So down here, I'm going to say module.exports equals custom page. All right, so we've made a lot of progress in this section by actually doing the real implementation here, but we still have a little bit to do. So we need to actually figure out how we actually use this custom page thing inside of our test file. So let's take a quick pause right now. We're going to come back to the next video, and we're going to update our header test file to make use of that new custom page thing. And when we do that, it's going to dramatically simplify all the logic inside this file right here. So quick break, and I'll see you in just a minute. In the last section, we finished up our custom page implementation. This is now the section where everything is going to come together, and hopefully you're going to see the real reason that we went through all of this ridiculous trouble. Again, I know this has been some pretty ridiculous stuff, but I would have not included it in this course if I didn't think that you would actually benefit from it. Trust me, we could have just as easily said down here, where we put together the authentication stuff, we could have just said, oh yeah, we have to do this every time we need to log in, and we could have just left it right there. So I very purposefully put in all this proxy stuff because I really thought you would get some gain out of it. All right, so let's get back to it. I'm inside of the header test file. At the very top, I'm going to require in the custom page thing that we just created. And remember, we called that thing simply page. So I'm going to say const page is require, let's see, up one directory, nope, same directory, helpers, page, like so. So outside of that actual page.js file, we're not going to use the terminology custom page anymore because no one really needs to know this is a custom page. We could just as well call this custom page, but we don't have to. We're just going to call it page. Now, the page thing that we just required in wraps up everything that we have to do with Puppeteer. So we no longer have to require Puppeteer into this file. So I'm going to remove that. We also no longer have a standalone browser that we are going to get access to because our custom page wraps up the browser as well. So I'm going to remove let browser. Then inside the before each, we don't have to create the separate browser anymore because we wrap that up inside of our page class. So we get to delete that. We also don't have to call browser.newPage because that's also wrapped up in this thing. So I'm going to remove that as well. So now all we have to do is create our new page by calling page equals, and then we're going to call that static function build that we defined on our custom page class. So I'll say await, because remember that is an async static function, page.build, like so. So that's going to give us back our page instance, and then we can use it throughout this entire test file, and everything should just work the way we expect. Now the other thing we can clean up is the await browser.close. So there's no more browser variable here, it's simply page. So page.close. Now I'm going to tell you right now, we are going to run into a little bit of an issue around this page.close statement right here. I kind of left this problem in on purpose just to give us a little bit of challenge. But as soon as we run our test suite, we'll see what goes wrong with this. But we'll get to that in just a moment. Okay, so is there any other refactor we have to do here? I don't think so. I think that we're ready to actually run our test suite. So for this first go through, we're just going to run our test suite and make sure that everything works. And then once we can confirm that it works correctly, we'll then go back and define our login method and finally get rid of all this authentication logic from this thing right here. So let's run our test suite. I'm going to go back over to my terminal. Here we go. And I'm going to run npm run test. And oh man, I'm just crossing my fingers hoping that this thing actually works. Believe me. All right, so we are launching our browser any second here. Oh, thank goodness. It actually worked. So there's our Chromium instance. It goes to localhost 3000. It actually worked. All right, now here's the problem that we're going to run into in action here. You'll see that it's actually bringing up multiple instances of Chromium. Okay, so check that out. The tests actually worked. We combined everything together into one single class. We wrapped up the custom page, the page instance, and the browser, and it really truly worked. So that's totally amazing. I'm very happy it worked, but clearly there's still a little bit of an issue here. It looks like our browsers are not correctly being closed anymore. So let's take a quick pause. We're going to come back in the next video and solve this issue. In the last section, our custom page class worked correctly, and believe me, I'm just like absolutely ecstatic right now that it actually worked out the way we expected. The only issue is that we've got 3 separate Chromium instances that are still running here. So we probably don't want that. I'm going to manually close each of these Chromium instances really quick, and we're going to go back over to our custom page class right here and figure out exactly what's going wrong. So inside of here, whenever we try to interact with the proxy that gets returned from the build method right here, we're going to first look at our custom page instance. So that's this thing right here, and see if the given function that we're trying to access exists on that custom page. If it doesn't, we then go on to page, and if it doesn't exist there, we then go on to the browser. So again, we're kind of combining these 3 different objects together, because in truth, they're all really doing the same thing for us. The only problem here is the order in which we are trying to access each of these objects. So I'm going to pull a API documentation page on the screen here really quickly. So this, if you recall, is our Puppeteer API. Right now, inside of our actual test file, we are trying to call the close function that exists on our browser instance. However, if you go down to page, you'll notice that page also has a close function defined. So the issue right now is that we are first looking up to see if a function exists on page, and if it does, we run that function rather than going over to the browser. So right now, whenever we call page.close inside of our after each statement, it's calling this actual, like the page close. I know I'm saying page so much here, but you get the idea. We're calling the Puppeteer page class close, as opposed to trying to close the entire browser itself. So there's 2 easy fixes we could do here, 2 different ways of approaching this. The first thing we could possibly do is pass in the browser to our custom page constructor right here. We could then save a reference to that on the instance. So something like this .browser equals browser. And then on our custom page, we could define a new function called close. And inside of here, we could call this .browser.close like so. So all we're really doing here is kind of moving up the priority to custom page. So custom page now has a function called close, and when you call it, it will work with the browser directly. So all we're really doing is saying, hey, you know what? Now this thing really does have a close function, so you don't have to go to the page copy of close anymore. So that's one possible way of doing it, but I think that's, I don't know, probably a little bit overkill for what we're doing right now. So I'm going to undo those changes I just made, and I'm going to show you the alternate method, and this way is far easier. Basically, we're now saying that the browser object right here should probably have greater priority whenever we are trying to look up a function than the page. So whenever we call close, first look at this browser thing and see if that close function exists. If it does, use that function rather than going on to the page. So I'm just going to swap the order here by cutting this. I'm going to put it in front of the page, put the or in, and I'm going to make sure I clean up the old or statement right there. So now our order is to look to see if a function exists on custom page, then the browser, and then the page. So let's now save this, and we're going to run our test suite one more time. I'm going to stop the running test suite by hitting Control-C, and then I'll run my tests again with npm run test. All right, so how are we doing now? Let's wait for these browsers to appear, and this time we're going to expect them to appear and then close one at a time. Yeah, there we go, much better. So there's another close, and then the third one, and that gets closed as well. Perfect. Cool, so this looks good. We've got a pretty solid test setup here. So let's continue in the next section, and we're going to finally get around to abstracting all of this authentication logic into our custom page implementation. So quick break, and we'll take care of that in the next video. After a ton of effort, we are finally able to really see this new page thing in action. So in the last section, we did a little bit of a refactor of our before each and the after each. And now, ready to go down to our authentication test, where we are going to finally extract all this logic right here and move it into our custom page implementation. Remember, that was the entire idea with all this all along. We wanted to find a better location to put all this very repetitive logic right here. So I'm going to find all this logic, everything from const user all the way down to the WaitFor statement right here, and I'm going to cut all of it out. We're then going to go over to our custom page file, and we're going to add it into a new function inside of that custom page class. So inside the helpers page.js file, here's my custom page. I'm going to go down to the bottom, and I'm going to add on a new function called login. This function is definitely going to contain some asynchronous code, so I'm going to mark it as async like so. Then in the function body itself, I'll paste all the stuff that we just cut out, like so. We do have to repair a couple of references here. So now, we don't have access to a page variable directly inside of the login function. The page that we're trying to actually work with is assigned to this.page. So I'm going to update all four of these references right here to this.page, and this.page, like so. The other thing to be aware of is that we are making use of both the user factory and the session factory inside this file. So let's make sure that we move over those require statements as well. Back inside of my header test file, I'm going to go back up to the top. Here's where we require in the two factories. I'm going to cut both those out. I'm going to go back over to that page file. I'm going to go up to the top of the file, and then I'm going to paste in those two factories. Now notice that we are now inside the helpers folder right here, so we do have to repair the two require statements. We have to make sure that we go up one directory and then into factories. So it should be ... factories and ... factories, like so. Okay, so let's do a quick review of what's going to happen now. Inside of our header test file, we create a new instance of our custom page thing. Over here, we are calling it page just because it really doesn't make any sense over here to be calling it like, custom page all over the place. So I know that kind of relabeling of variables is a little bit confusing, but I think you'll agree with me that calling it custom page would not make a lot of sense. So we make our new page right here. And this variable right here is actually our proxy, which is governing access to the custom page, the Puppeteer page, and the Puppeteer browser. Then, down inside of our authentication test, right before we actually do this stuff to make sure that some logout button is appearing on the screen, we need to make sure that we attempt to log in using that new page login function that we just created. So right above this thing, right above where we tried to extract the text, we're going to make sure that we attempt to log into our page instance by writing out await page.login, like so. And we're putting the await keyword right here because login is an async function that's going to take some amount of time to actually execute. All right, so I think that's just about it. Is there anything else we have to do? I think we're ready to actually run this code. Yep, here's our session factory, our user factory. I just want to do a quick check here. We've got everything else over here as well. Yeah, I think we're ready to test this out. So let's go over to our terminal, and this is going to be the real moment of truth. Hopefully everything works the way we expect. So I'm going to run npm run test, and we should see all 3 tests working. I'm just totally crossing my fingers right now. There's one browser. There's the second browser. And then the third browser. So this is the actual authentication test. Oh yes, it worked. It totally worked. Oh, that's so awesome. So now, rather than putting all this authentication logic stuff, inside of, right now it's inside the custom page, rather than copy pasting all this login stuff all over our test suite over and over again, we can so easily, incredibly easy, log into our application simply by calling page.login like so. So now the entire subject, or like the pinnacle, the focus of every test that we write is going to be this singular page object. And we don't have to worry about working with the browser object or Puppeteer or anything else. All we have to worry about is this page thing. And we're going to associate a ton of helper functions with this page object. It's just to make running our tests a lot more straightforward. So let's come back to the next video, and we're going to immediately see a good example of how we can now leverage this custom page class to dramatically simplify a lot of the code that ends up being written inside of our tests. So quick break, and we're going to take care of that in the next video. Now that we've finished up this entire page abstraction thing, we now have a single place to write a ton of reusable logic inside of our test suite. The first thing I wanted to do to give you a better example of how we can leverage this page object to dramatically simplify how we write our tests is to try to get a better interface for pulling content out of our page. So right here, where we make sure that the header has the correct text in that logo, we're referencing our page variable. Page is our proxy. When we call $eval, or when we reference that property, the proxy goes and finds the Puppeteer page instance and returns that thing's $eval function. We then invoke it with a set of parentheses right here. Now, when we originally wrote this code, we spoke about how weird this function signature right here was. For example, why the $? Why eval? Why this inner function right here? And why couldn't we just say something much more plain like, go get me the content from this selector right here? And there actually are some very valid reasons for why this has a kind of weird function signature to it. But I think that now that we have the ability to add functions on the fly very easily to our page thing right here, maybe you and I can kind of redesign this function. Let me show you how we would do that. Okay, so I want to make a way better way, or a way more clear function for getting the content out of some specific selector inside the page. So we're going to go over to our page.js file. Here's our custom page. I'm now going to go down to the bottom of the file underneath our login function. And we are going to make a new function whose sole purpose is going to be to make that eval function way more clear than it is right now. So I'm going to say async get contents of. And we're going to call this thing with a selector. So the idea here is that rather than calling $eval or any of that other nasty stuff, we're going to just have to call this get contents of function that you and I just defined. And we're going to pass in only the selector. And then inside this function, we'll take care of all that kind of nasty looking stuff related to Puppeteer, like the $eval and the inner HTML stuff. And for all of the tests that you and I write, rather than having to write out $eval and the l.inner HTML stuff, we can simply call get contents of, pass in the selector, and then poof, this function is going to take care of all that stuff for us. So inside of here, we're going to write out return this dot page. So this is our Puppeteer page right here. Dot eval. As a first argument, we're going to pass in our selector, And then as a second argument, we're going to take l.innerHTML, like so. So now everywhere inside of our test suite, when we want to get some content of an element, we can call getContentsOf and pass in the selector, and that's it. We don't have to worry about $eval or this arrow function right here. So let's save this, and now we're going to go back over to our header test file and refactor everything to use getContentsOf instead. So now back inside of header test, I'm going to replace this long annoying statement right here. Actually, I'm not going to delete it just yet because I do want that selector. I'm just going to rewrite it underneath. It's short enough. So we'll do const text is await page dot get contents of a dot brand logo, like so. And now we don't need any of that nasty stuff up here. So I'm going to take it all out. Now that might be a very small change, but I don't know about you, but I would way rather use some very clear function name like this right here than $eval. And I'm way happier not having to write out that arrow function at the end as well, whose purpose is like kind of mysterious and requires you to understand exactly what Puppeteer is actually doing behind the scenes. So that's pretty much it. We should now be able to run our tests and still see this test right here pass. So let's do that right now. I'm going to go back over. We're going to run npm run test again. We're going to wait for this thing to run. I know it takes just forever. I do get some consolation knowing that your tests probably run more quickly on your machine. Okay, so there's Chromium window. This is the OAuth flow right here. And then we do, oh, that's it. Okay, and now you see that all of our tests are still passing, exactly as we would expect. So now that we have this page abstraction right here, we can build a ton of helper functions just like this to make working with Puppeteer much more easy and straightforward. So we can really customize its API to our own whims. And we did all this without having to monkey patch or inject any code directly into Puppeteer itself. So overall, I think this is a huge win. I think we've done a fantastic job. But we've also spent a pretty good amount of time talking about all this custom page stuff. So let's continue the next video, and we're going to get way back to actually writing some meaningful tests inside of our test suite. So quick break, and I'll see you in just a minute. We're finally all done with that page setup stuff, which means we can get back over to writing some actual tests inside of our test suite. So in this video, we're going to get back to writing tests by writing a couple tests that make sure that blog creation inside of our application actually works the way we expect. So back inside my browser, I'm going to very quickly go through the flow of creating a blog again. I'm at localhost 3000. I'm going to first sign into my application through the OAuth flow. So I'll select my account, whichever one I want to use, it doesn't really matter. When I go through that OAuth flow, I then get automatically redirected back to the /blogs route inside the application, and then I see my list of blogs appear on the screen. What's really relevant for you and me, however, is that we have to click this red button down here, and when we do, we get taken to the new blog creation form. So this might sound like a very simple test, but I think that we should write out a single test that kind of walks through the flow that we just did right there. We should log into the application. We should make sure that we end up on that /blogs route. We should then click on that red button on the bottom right, and then write an assertion to make sure that we see a blog creation form appear on the screen. This is a very straightforward and simple test, but it's going to make sure that we never ever accidentally break that flow of logging in and then simply creating a new blog post, or at least getting to the form to create a new one, I should say. So let's give this a shot. Now, as a reminder, since it's been a little bit of time since we've written an actual test, we're going to always go through the exact same flow whenever we are making use of Puppeteer. So we're going to create a new page instance. We're going to navigate to our app. We're going to try to click some stuff on the screen, write a selector to pull out some content, and then write an actual assertion. Now, to actually customize that flow right there for the test that you and I are about to write, you and I need to launch Chromium, navigate to the app, and attempt to log into it. We're then going to make sure that we end up at that blogs route. So only on that /blogs route do we see that big red button on the bottom right. So we're going to go to that route and then attempt to click on that big red plus. We should then see that form appear on the screen. So we're going to then write a selector that somehow makes sure that we're getting some content on the screen that represents that form that we should be seeing. And then finally, we'll write the actual assertion to make sure that, yeah, that form in fact did just appear. So let's give it a shot. Now the first thing I want to point out here is that we're now writing some tests around our actual blog post creation, which is not really tied to that header.test.js file logic at all. Remember, the header test file is about testing specifically the header. So I think we need to first create a new test file that's going to house all the tests that we write related to creating and editing and viewing blog posts. So inside my test directory, I'm going to make a new file called blogs.test.js, like so. So again, this is going to house all of the different tests related to creating, viewing, whatever, blog posts. We're going to go through some initial setup at the top of this file that's going to be very similar to what we just did inside of our header test. So we need to first require in that page helper. We'll then put together a before each statement that automatically creates a new page instance for us. So at the top we'll do const page is require helpers/page, like so. We'll then declare a local variable called page that will be scoped to the entire file. We can then do our before each statement, which will initialize a new page. And don't forget to get our async keyword on here. Inside the before each, we'll do page equals await page.build. So this line right here is what actually creates a new browser window and a new page or tab inside that window for us. And then after that, we're going to navigate over to our application and get it ready to actually log in or do whatever else we want to do. So I'll do await page.goto localhost 3000, like so. And then one last piece of setup, don't forget, we always want to have that after each statement as well to make sure that we automatically close that browser window. So after each async, and then we'll do await page.close. And that's going to clean up our browser window after every single test that we execute. Okay, so this is a good place to get started. Let's pause right here. We're going to come back in the next video and start writing out the actual test to make sure that that form appears on the screen. In the last section, we started putting together a new test file to make sure that we are able to create blog posts inside of our project. We've got down our before each and our after each. So now after the after each statement, we can start writing out the first test. So I'll say test, and I'm going to give this thing a description that just kind of tells us what the purpose of this test is. So in this case, we are trying to log into the application and then get to that new form creation page. So I'm going to say, when logged in, can see blog create form, like so. I think that's fairly descriptive. I'll then mark this as async, as usual, and put down my arrow function. So as the test description right here seems to imply, we want to make sure that we actually log into the application before we attempt to do any of this login or any of the blog creation stuff. So the very first line of code we're going to write here is that login helper function. So we'll say await page.login, like so. Now there's one real big gotcha here, one big gotcha about this login function and the way that we wrote it. If you remember just a moment ago when we tested the login flow manually inside the browser, let's go through that again very quickly. I'm going to click log out and then I'm going to log into the application again. So notice that right now I'm on localhost 3000. When I click on login and then go through the OAuth flow with Google, so let's do my account selection. When I get kicked back over to the application, you'll notice that we end up on a route of /blogs right here. And it's only on /blogs that I expect to see this red button appear down here. If I go back to just localhost 3000 manually, like so, I'm still considered to be logged into the application, and you can notice that by looking at the header up here. But when I'm at localhost 3000, I do not see that red button appear at the bottom right-hand side of the screen. Now this is pretty much expected behavior. Only when I'm on the blogs list right here, I should see the red button. The reason I'm mentioning this is that the login flow that you and I put together on that page object automatically leaves the user or leaves our browser instance at localhost 3000 after it does that fake login process. So for our actual real application, you only get redirected over to the blogs route, like right here, this blogs route right here, after going through the real OAuth flow. That's like the very last action of the real OAuth flow. So when you and I are cheating, or kind of like faking that auth process, we do not get that automatic blogs redirection there. So all I'm trying to say here is that whenever we use this .login helper right here, we need to make sure that we eventually get over to that /blogs route before we actually try to do anything on that page. Now there's two ways that we can handle this. We can either say, okay, anytime that we try to log into the application and this login function right here just leaves us on localhost 3000, we could go and modify this function to make sure that after we log in, we automatically navigate over to the /blogs route. That's one way of handling this. The other way of handling it is to say that whenever we log in, we're always going to write a line of code right after it that tries to go to localhost 3000, like so. So it's really up to you. We can either put this line of code right here inside the login function itself, or we can say that we're going to rewrite it every time. Now, in the interest of having much more dry or don't repeat yourself style code, I think that we should go back to that login function and add in this /blogs navigation line to the actual login function right there. That's going to make sure that we only have to ever say .login, and then poof, we should automatically be on the login, or excuse me, the /blogs route, which is pretty much how we would probably expect this to behave. So I'm going to open up my helpers page.js file again. Inside of here, I'm going to find that login function that we were just working on. And then after, well, actually, you know what? A better way of handling this might be to say, rather than after we do the set cookie stuff, rather than going back to localhost 3000, let's just try to actually go back to /blogs. So this is going to have the same effect as before of trying to essentially refresh the page and get our application to restart in the authenticated or logged in mode, but it's going to make sure that we land on a much more usable page than we were landing on before. So before, when we were just going to localhost 3000, that was just a very plain landing page, and that's not really very useful to you and I. So let's just say, you know what, after we log in or do this set cookie stuff, we're going to end up on that blogs page. Okay, so I think that looks good. So now we can go back over to our blog test file, and we do not need this additional goto statement right here. All right, so that looks good. So let's go back over to our flow very quickly. So we've now logged in and we are at our blogs route. So now we need to somehow click on that plus button on the bottom right-hand side of the screen. So that's the big red button down here. So let's take a quick pause. We're going to come back to the next video and make sure that we actually click on this element. We now need to make sure that we click on the red button down here at the bottom right-hand side of the screen to actually go over to that new blog creation form. We've done automated clicks once before. So remember, all we have to do is get a DOM selector for this button right here, and then we can write out page.click and pass in the selector. So let's do an inspect element on that red button. So I'm going to right click it and do inspect. You'll notice that when we inspect the element, you might get this eye right here. The eye is the actual icon that exists inside the button. That's not actually what we want to click. What we really want to click is the anchor tag that is wrapping the entire red button thing itself. So we need to write a selector that's going to find this anchor tag on the screen. We can probably do a selector of something like A for anchor tag, and then try to select the class btn-floating, because I don't think that any other element is going to have this class right here. So let's try that out. I'll do a.btn-floating, like so. And it definitely looks like that correctly selects the anchor tag. So let's go back over to our test, and we're going to make sure that we try to click an element on the screen that has this selector right here. So back inside my code editor, I'll do await page.click a.btn-floating, like so. So that's going to take us to the new blog creation form right here. And then as we had said, all we really want to do right now is somehow make sure that the correct form is appearing on the screen. So I want to make sure that form is actually appearing. So again, this is where we're going to do another DOM selector to find some element that will kind of allow us to reasonably say, yeah, I think the form is correctly showing up. You might be thinking, all right, let's just do a form selector. Just try to grab the entire form and make sure that a form exists. That's definitely one valid approach. However, keep in mind that we might eventually kind of evolve our application so that different forms are available on the screen at different times. For example, we might eventually decide to add in some kind of footer down here. And maybe the footer would have some form that allows the user to very easily leave feedback with us or get in touch with us in some fashion. So we might eventually end up with multiple default form elements on the screen. So I think that we need to write something a little bit more, something more precise. Something to say the form that's being displayed is one that allows us to create an actual blog post. So I think that maybe one thing we could do is try to pull off this little label right here, like this little label, and make sure that this label has the text blog title. If we could do that, well then I would feel really comfortable saying, yeah, we definitely are showing the correct form on the screen. So let's try to pull out this element right here and get our text from this and make sure that the text is blog title. I'm going to right click on that label and I'll do inspect again. So that is a label that has the correct text. So we want to write a selector that finds this form, finds the first label inside of it, and then gets the text out of it. So I think maybe we could do a selector of something like form space label, like so. Yeah, that looks reasonable. So let's go back over to our editor. We're going to get that content out of that label by using the getContentsOf function that we just added to our page class a little bit ago. So I'm going to say const label is await page.getContentsOf, and then I'll pass in the selector that we just came up with, which was form space label, like so. And then finally we can write out our actual assertion. So I'm going to expect label to equal blog title, like so. All right, I think we're all ready to test this out at our terminal. So let's run our test suite. I'll go back over to my command line and I'll do npm run test. At this point, we have just added in a separate test file to our project. Now, when we run this command right here, you're going to notice some very interesting behavior. So I'm going to run this command. And then as soon as my browsers start popping up down in my terminal down here, or excuse me, down in my dock, you're going to notice something that did not previously occur. So take a look at that. We now get two separate Chromium instances running at the same time. So this right here is exactly why we are using Jest inside of our project. We're using Jest because it allows us to automatically execute multiple different copies of our test suite at the same time. So we can run all of our tests much more quickly than with a more traditional test suite like Mocha, which tries to run all of our tests one at a time all in a row. Now, unfortunately, you will notice that our test right here failed, even though it really seems like we were doing the right thing. Now I'm going to rerun the test suite just again one more time because I was talking during that, and let's just kind of observe the behavior that occurs. Now when it's running, I'm going to open up one of these things, and I'm just going to make sure that it appears to be doing the right thing on the screen. So yeah, there's localhost 3000, there's blogs, and then, I definitely saw there for the briefest instant the correct content appear on the screen, but you'll notice that my test appears to actually be failing. So it sure seems to me like this right stuff was happening, but it really doesn't look like the test is actually passing. And in fact, you'll notice that we have an actual error message here that says async callback was not invoked within the 5,000 millisecond timeout. So let's take a pause right here and we'll investigate this little error message and figure out exactly why our test is failing. In the last section, it appeared that my test is failing, even though I actually saw the correct content appear on the screen for just the briefest of a second. So we're going to figure out what's going wrong here. Now, one thing I want to mention very quickly, if you are seeing your test pass right now, that's totally fine. So if you are seeing your test correctly pass, totally fine. Let me explain what's going on here, and then it might make a little bit more sense why I'm seeing my test fail, but maybe yours is passing. If we look at the actual error message that's being thrown right here, it's saying async callback was not invoked within 5,000 millisecond timeout. So essentially, whenever a Jest test runs, by default, it has 5 seconds to actually either pass or fail. Right now, the entire process of launching Chromium and then logging in and then going to that blog creation form is taking slightly longer than the 5 seconds that we have available to us. So even though it appears that our test is actually working correctly, Jest thinks that something is not quite working the way it expects because it's taking too long to complete. At present, that entire flow of like logging into the application and going to this form is like the barest, smallest little thread of what you can do inside of our application. So this is something that I expect to be like a test that is not going to be the longest inside of our app. Just think about it. Eventually, we're going to want to come to this form, type in a title and a content, and then click on next, and then confirm the post, and then make sure the post was actually created. So eventually, we're going to end up with tests that take many, many, many seconds to actually execute. So definitely that 5 seconds that we have available to us by default through Jest is probably not long enough to really accommodate some of the tests that we're going to write later on. So we're going to adjust the default settings of Jest and make sure that it gives us some more time to actually complete all the tests that we're running. To do so, we're going to go back to that setup.js file that we had created inside of our test directory. So here it is right here. And then at the very top of this file, we're going to add on a single function call to configure Jest. We're going to say jest.set timeout to be 30,000, like so. So notice there is 30,000. This right here is a duration in milliseconds, and it tells Jest how long it should wait before automatically failing a test. So in this case, we're saying wait 30 seconds before ending any test. Now this value right here is totally up to you. You can modify it as much as you wish. Maybe you want to go down to like 10 seconds, or maybe you want to take it all the way up to 1 minute. So 60 seconds, like so. It really comes down to the performance of the machine that you are working on right now. Whenever I run this video recording software that I'm using to, show you my screen, my test suite runs awfully slow. So I think that 30 seconds for me would probably be appropriate. But if I was just running this test suite and nothing else, I could probably get away with the original default 5 seconds. So again, it's totally up to you, and it's really up to you to kind of play with this value right here to make sure that your tests have enough time to actually run, but aren't dawdling so long after they actually do fail. Because remember, if you have something that is like trying to wait on an element to be visible and it never actually ends up being visible, well, maybe you don't want to have to wait around for those 30 seconds. So again, I leave it up to you to kind of fiddle with this value right here and decide what's right for you. So now that we've updated the timeout, let's try running our tests again. Now, like I said, your test suite might already be working. I'm going to rerun mine right now just to make sure that 30-second timeout actually solved the issue. So I'm going to run the test suite again. There's my Chromium instances. And I'm going to look at that second one to make sure it's actually doing everything I expect. Okay, so there's the blog test one just passed. And then the other one should also be passing. There we go. So that one is passing as well. Now notice how after running the tests, it'll actually print out the duration right here. So my blog test was taking about 10 seconds or so, way longer than the expected 5-second timeout that we had previously. So I think in this case, the 30-second timeout is totally fine. The other thing I want to mention here is that the duration right here is the sum of all the tests that are written inside that file. So every test now gets allowed 30 seconds to execute. This is saying that the entire test suite took 14.9 seconds. So there's still a tremendous amount of leeway here. Like, we're not looking for this value to be greater than 30 seconds. We're looking for any single test to be longer than 30 seconds. So 30 seconds definitely gives us a tremendous amount of time to play around and click around in the application and eventually try to make an assertion. But anyways, it looks like our test suite is actually passing now. So we have a working test to make sure that we are actually able to see that blog creation form. Now there's still a lot of other stuff that we want to do around that form. So let's take a quick pause right now, come back to the next section and write out a couple other tests. In the last section, we wrote out our first test just to make sure that the blog post form is actually visible on the screen. We now need to start thinking about the next set of tests we're going to write. Well, we could definitely do something like maybe make sure that if you click on the next button right here, like so, we get some validation error on the screen. I think that would definitely be worth testing. We might also want to make sure that if you enter in some value to each input, and then click on Next, you go to the confirmation screen. I think that would probably be worth testing too. And then maybe we would also want to make sure that if you get this far and then click on Save Blog, you eventually get redirected back over to the blog list and you see your new blog post appear on the actual screen as well. So it definitely seems like there's kind of like a web or a tree of sorts of different tests that we might want to write that kind of depend on each other in some fashion. So I took a couple of different test cases that we might want to write around all this blog post creation stuff, and I put them onto a single diagram. So let's take a look really quick. All right, so this is kind of a confusing diagram, but it lists out all the different possibilities of that blog creation form. So at the very top, we start off with blog tests. That's what we're trying to test here. We're trying to test creating blog posts. When it comes to blog posts, there's really two top level states that we have to consider. We have to consider the case in which you are trying to work with the blog post feature when you are logged in or when you are not logged in. So if you try to access any of this blog post creation stuff when you are not logged in, we probably want to make sure that if you try to create a post, an error occurs. So if you're not logged in, you do not get to create a post. And likewise, if you are not logged in, we probably want to show an error message if you try to get access to an individual blog post. So whenever we do this integration testing stuff, we need to make sure that not only the kind of like happy path is well tested, but we need to make sure that some level of security exists around our application as well. So we need to make sure that if a user does something that we don't want them to do, they end up seeing some type of message on the screen. Likewise, when a user is logged in, there's kind of a similar set of conditions that we want to test as well. So when a user is logged in, we want to make sure that they can see the form. And that's a test that you and I just wrote. And then if a user puts in some valid form inputs onto that actual form, they actually type in a title and some content, and then click on that button to submit that form, we want to make sure they're taken to a review screen. And then taking that one step further, if they then click on that save button, we want to make sure they get redirected and see that new blog post appear as well. And then on this other branch that is totally counter to this one right here, we want to make sure that if a user enters in invalid inputs, then they should see some type of error message appear. So there's kind of a running theme in this diagram right here. Really, there's two types of boxes that you're seeing being presented. I'm going to color code all these boxes into one of two categories. Okay, so take a look at this. Notice how all the blue boxes start off with the word when. So all the blue boxes right here are kind of putting out some initial condition, something to say, hey, we're about to make an assertion or trying to make a test about some specific path of interaction inside the app. And that's what the blue boxes here are describing. Likewise, all the green boxes are talking about an actual specific assertion that we might want to make. And notice that sometimes there might be multiple green boxes that are tied to one single blue box. So it definitely seems to me like both these tests right here are going to have some initial setup that is very common. So for example, making sure that a user sees a review screen and making sure that a user sees their blog post added to that blog index page, both depend on some very common setup. So both these tests right here need to first log into the application and then attempt to put in some valid form inputs into the form itself. So chances are we don't want to have to rewrite all this common setup right here between both these tests. So I think that we need to figure out some way of saying for this common set of tests right here, let's not try to rewrite all the same setup code over and over. Let's figure out some clever way to do some initial test setup that is very common to both these tests. Let's take a quick pause right here. We're going to come back to the next video and we're going to talk about a feature in Jest that allows us to do some setup that you see that is common to all these blue boxes right here, and only have to write that setup one time for each of these groups of tests. So quick break and we'll start writing some code in the next video. In the last section, we took a set of different tests we might want to write and broke it down into a single tree diagram. We then said that everything inside these blue blocks right here are describing some common test setup that needs to be executed before any of these green boxes that represent actual assertions can be ran. So let's now take this diagram right here, and we're going to apply some additional terminology to it to kind of take this back over to the actual code writing world. And then we'll start writing some code inside of our editor to get a better idea of how this stuff all comes together. Okay, so I took that same diagram, but I added on a couple of extra parts. Let's first start off with a part here that's going to be very familiar. So over here is a test that says we want to make sure we can see the form. This is a green box. These green boxes represent actual test statements, like the same kind that we've already been writing inside of all of our test files. We're going to introduce a new element here as well. And this is another test element that is very similar to these test statements that we've been writing. We refer to it as the describe statement. A describe statement is used to group together sets of very common tests that all share some similar testing setup logic. So we're going to refactor our form, our blog post form test right now. We're going to start to introduce these describe statements. A describe statement can contain either other test statements or other describe statements as well as children inside them. A describe statement can also have a before each or an after each statement. These before each and after each statements are used to set up these kind of very common conditions that are shared for all the tests that exist inside of it. So for example, if we have a top level describe that says when you are logged in, then inside there we will probably also write a before each statement that attempts to log the user in, so that every test inside there will start off with an initially logged in page instance. We're going to repeat that same process for all the other describe blocks as well. So we're going to write out a describe block and then put in some before each statement that tries to customize or do some initial setup for all the tests inside of it. Just to be clear, all this stuff we're talking about right now is all in the vein of having very reusable tests and making sure that we're not repeating the same test logic over and over and over again. It also allows us to get a better idea for other engineers who are working on the project of what initial conditions need to be met for some action to actually occur. So for example, if you're some engineer who's walking onto this project, you could read through a given test file and say, okay, so when I'm logged in and I have valid form inputs, I am then allowed to actually create a new blog post. This kind of nested describe makes these initial conditions a lot more clear for teaching other people about how your app actually works. So let's now flip back over to our code editor, and we're going to start adding in our describe and nested before each statements. Okay, so back inside my code editor, underneath the existing test, we're going to write out that first describe statement. So I'm going to say describe while logged in. Actually, let's be consistent. We'll say when logged in. This has the same function signature as the test function we saw a moment ago. So it takes a second argument of an async function, like so. Now, one thing to be aware of here is that describe is a global function that is provided by Jest. So just the same way with this test function up here, we don't have to require this in or import it or anything like that. Now that we've defined this describe statement, we can set up a before each inside of it that attempts to do some common setup for all the tests that are going to be nested inside. So I'll declare a before each, I'll pass in my async function, and then we're going to do our common setup that needs to be executed for every test that is going to be placed inside this function. So I'll say await page.login. And even though it's not like specifically mentioned here, chances are we also want to go over to that blog creation form as well. So I'm also going to try to do a click on that button floating link. So we'll do await page.click a.btn-floating. So now we can nest other tests inside of here, like starting right here, and they will all be executed with having this already kind of customized setup logic occur. One thing to be aware of is that describe statements kind of constrict the availability of before each. So this before each statement right here is only going to be executed for more tests that are written inside this describe statement. All right, so let's now take our existing test, the one we just wrote a little bit ago, and we're going to move it into this describe statement. So I'm going to select that entire test. I'm going to cut it, and then I'll move it underneath that before each, like so. So now whenever we run this test right here, this before each will have already executed. So inside this before each, we have already logged in and we've already clicked on that button. So now we do not have to repeat those same 2 steps inside of this test as well. So we can just delete those two steps. And then we can also clean up the actual test description because it's kind of already implied that we are already logged in. So the test description does not have to say that we are logged in here. We can simply say can see blog create form. So now we can read this as saying something like, when we are logged in, we can see the blog create form. Okay, so let's save this, and we're going to run this at our terminal again, just to make sure that everything still works. So back at my terminal, I'll do my npm run test, and then we'll wait those 10 or 15 seconds for our test to actually be executed. Again, you're going to see both the Chromium instances pop up. They're both going to run their set of tests. And only another 2 seconds or so. Yeah, there we go. Now just one more. And we end up with a passing header as well. Very good. Okay, so these describe statements that you see right here allow us to nest different tests to describe different branches of behavior inside of our application. So let's take a break. We're going to come back in the next video and we're going to start to implement the other 2 cases here as well. So the case in which we start to enter in valid input and the case in which we enter in invalid input into the actual form. So quick break, and I'll see you in just a minute. In the last section, we set up a describe statement for grouping a whole big set of tests. This describe statement had an initial prescription of saying that when we are logged in, all these sets of actions are allowed to occur. We're now going to go back and add in 2 nested describe statements that describe when we start to enter in valid input and invalid input into the actual form. Let's first take care of this invalid input right here because it's going to be a little bit more direct and easy to write test. So I'm going to go back over to my code editor. I'm going to find the existing describe that we just put together. And then after our test statement, I'm going to add in another describe. And notice that this one is going to be nested. So it's nested inside of the when logged in one. So I'm going to give this a description of when logged in and using invalid inputs. Oops, cursor's jumping everywhere. We'll put down our arrow function like so. And then inside this thing, we'll write out the actual thing that we're trying to test. The form shows an error message. So again, we can now start to read all these nested descriptions as they stack up. So we first start at the top level describe, and we would read this as when logged in, and then we would jump down to the next describe, and using invalid inputs, the test form shows an error message. So that's how we start to kind of stack these things up and read a full sentence out of each of them. Now just to be clear, this before each statement right here will be executed for all of the tests inside this describe block as well. So by the time we get into this describe, we already have an instance of page that is correctly logged in and looking at the actual form. So inside of this describe, we might put another before each statement that tries to do basically whatever this thing right here says. So in this case, we want to attempt to submit the form when using invalid inputs. So inside this describe, we'll place another before each. And we're going to write some code that tries to make this description right here a reality. In this case, invalid inputs are having no input whatsoever. So if we try to submit the form with no text inside of it, well, that is an invalid input. So really, inside the before each, all we really want to do is attempt to submit the form. So let's get a selector for the submit button, and then we'll try to figure out how we can click on that thing and then write an assertion to say that 2 error messages actually appear. So I'm going to go back over to my code editor, or to my browser. We'll look at the blog creation form. Now I'm going to clear out the text inside of here. And then what we really want to do is kind of simulate a click on this button right here. So I'm going to get a selector for that button. All right, so it looks like we have form, and then there's a button right here. Notice how the other button on the screen, the cancel one over here, is not actually a button, it's actually an anchor tag. So I think that we could probably do something like, I don't know, let's try just simply button. Well, when we do that, yeah, we definitely get the right one. Now, again, we might have multiple forms or multiple buttons on the screen. So let's be a little bit more specific. We'll just do like form space button. So now if we have multiple buttons, like say one in the header, at least we'll get one that's nested inside this form. Okay, so we're going to now try to click on this element, and when we do, we should then be able to write an assertion that says that we see these error messages appear. So inside this before each, we'll say await page.click form button. So now after we do this line of code right here, we should then see those two error messages appear. So now inside of our actual test, we need to make sure that we try to pull the text out of both those little error messages that just appeared, and we will make an assertion to say that they do in fact have the correct error messages. So let's get a selector for both of those. So I'm going to do an inspect element on the first one. Now you'll notice that we have a div here that contains the actual error message. And then above that is a div that has class title. Class title right here is talking about the actual title property of a blog post we're about to write. And then the element underneath it, or that form field underneath it, has a class of content. So I think that we could probably do a selector of something like class title in class red text to get this first one. And then we can do class content and class red text to get the second one. So let's try that out. We'll do .title .red text. Okay, that definitely gave us the right one. And then for the second one, we want content and red text. And that gave us the correct one as well. So let's do these two selectors right here. We're going to pull the text out of them. We're going to make sure that they both are displaying an error message. So back inside my test, we'll do const title error is await page.get contents of, and we want .title. Let me shrink my text here just so you can see everything on the screen. So we'll do .title with .red text, and content error is await get contents of content and red text. And then finally, we can write assertions about both these values right here. So I'll do expect title error to equal, and the actual error message we see is you must provide a value. So you must provide a value. And expect content error to equal you must provide a value. Cool, so that looks good. So now once again, we can walk through the entire description of what's occurring here before that assertion is actually made. We're saying when we're logged in and we're using invalid inputs, the form should show an error message. And at every step along the way, we have an accompanying before each statement that sets up this kind of initial condition. So let's now save this file. We're going to try to run these tests at the terminal again. So we're now starting to kind of stack up on different tests here. And every time we start to add in more tests, we're going to see this test file or this test execution start to take a little bit more and more time. So last time for me it was 17 seconds. Before that it was 15 seconds. This time it might get all the way up to like 20 or 22 seconds. Remember that the test timeout that we put together was talking about running for individual tests, not an individual test file. So eventually these might be longer than 30 seconds, and that's still going to be fine. Now it looks like our tests around that blog post creation are working out just fine, which means that the actual validation of those inputs is working out the way we expect. Cool, so that looks good. So let's take a break. We're going to come back to the next section, and we're going to do another describe block that handles the case in which we have actual valid form inputs. So quick break, and we'll take care of this describe in just a minute. In the last section, we handled the case where we have invalid text inputs in our form. We're now going to go back and handle the case in which we have valid inputs. So let's go back over to our test file. I'm going to find the describe statement where we said that we have invalid inputs. And then we can either add right above it or right after it the case for handling where we have valid inputs. It doesn't matter what order we put the describes on. All that matters is whether or not we are nesting them inside of other describes. So I'm going to say right above this thing, because usually I put the positive case above personally. I'll say describe and using valid inputs. And then inside this, we'll list out the two different cases that we want to test. So we want to test to make sure that this actually takes us to the review screen. And we also want to make sure that when we go to that review screen and then click save, it eventually takes us to the blog index page. Now, one thing I want to mention here is that technically we might want to actually do a second describe in between these, because you'll notice that there's actually common interaction between both of them. This one right here takes the user to the review screen. This one takes the user to the review screen and then does something else in addition to that. So technically we might want to use another layer of describe blocks here, but just for the sake of showing you two like sibling tests, we're going to do these at the same level rather than doing an extra describe. Okay, so back inside of the describe we just added, we'll add on both the cases that we just looked at. So we'll say test submitting takes user to review screen. And then we will also handle the other case as well. Submitting, then saving adds blog to index page. And index page here is talking about that route / blogs, the listing of all the different posts that we have. Now inside this describe, we're going to place a before each where we do our common setup for both these tests right here. So inside this before each, we have already been logged in. Let's review. Right here, we've already logged in and we are seeing that actual form appear on the screen because we clicked on that big red plus button. So inside this before each, we want to attempt to actually type in some valid input, and then we want to attempt to actually click the submit button as well. So the first thing we need to do is figure out how we actually type something into our browser. Now I think, no, I don't. I thought I did. I had the documentation for Puppeteer open. Honestly, it's a really easy function to remember. All we have to do is call await page.type. And the first argument here is a selector to the input that we want to type something into. And then the second argument is the text we actually want to type. So let's first get a selector for the input of the title. So like this input right here, this title input, and we'll get a selector for the content one as well. So I'll do another inspect element for that one. So very similar to the red text one we just did, I think we can do a div with class title and then look for an input inside that. So we can do something like dot title input, and that gives us our input. And we can do the same thing with dot content and input. Cool. All right, so here's our page.type inside of our before each statement for using valid inputs. So we'll say dot title input, and then as a second argument, we put in the actual text that we want to type in. So I'll put in a string of something like my title. And then we're going to do the same thing for dot content input as well. And this one will be my content. And then finally, this describe right here is talking about not only like using valid inputs, but also submitting the form as well. So we need to make sure that we also try to click the button to submit the form. So I'll do await page.click, and we got a selector for this thing just a second ago, right down here. Remember, we clicked on form button, and that's what actually tries to submit the form. So we'll do form button. Cool. So this is going to attempt to enter in our text and then click on the thing to submit it. So let's kind of emulate that inside of our actual browser over here just to kind of follow along. Actually, let's be more precise. My title and my content. So now over here, we want to make sure that we are presented with our kind of entries right here to confirm them. That's the purpose of the test that we're trying to make right here. So we want to make sure that we are taken to a review screen. And we can easily check to make sure that we are taken to this review screen by just either looking at the actual values right here. We can make sure that we are just presented with something that says my title and my content. Alternatively, another way to approach this that's a little bit more straightforward would be to simply say we see something on the screen that says please confirm your entries. If we make sure that we see this text right here, I think that it would be very clear or very easy to say, yeah, we were taken to a confirmation page. So let's try taking that route. Let's get a selector for this element. So we're looking for an H5. That's a pretty easy one. We can do simply H5 like so, and then pull out the text and make sure it says, please confirm your entries. So inside of our test, I'll do const text is await page get contents of H5, and then we will expect text to equal please confirm your entries, like so. All right, I think this one right here looks good. Now, rather than making you wait 15 seconds to actually run this test, I'm going to start my test, and then we'll pause the video right now and come back and make sure this thing actually passed. So I'll see you in just a minute. In the last section, we wrote out a test to make sure that the actual form confirmation page was just being displayed. I just ran my tests, and it looks like they all successfully passed. And I'm now up to 7 tests total. All right, so now we get to go back, and we're going to do the big omega final test here that makes sure that when we actually click that save button, we get redirected back over and see our brand new list of posts appear on the screen. So I'm going to give myself a little bit of space here. And then back inside my browser, let's first start off by getting a selector for this element right here, because obviously we need to actually click this thing. So I'm going to do an inspect element on that button. I think that we could very easily do something like button with class of green. I think that would be very straightforward. So we could do button.green. Okay, that definitely works. So now I will do await page.click button.green. When we do that, we should then be taken back over to the blog list. So let's actually click this thing and see what happens. Okay, so we click it and ta-da, we're taken over, and we should see that new blog post appear somewhere on the page. So we now need to write a selector that somehow tries to make sure that, yeah, we actually see this content appear. Now you might be thinking that we need to actually find this text out of this big list of cards. But one thing to keep in mind here is that whenever we run this test, we are creating a brand new user, a user who has no blog posts associated with them whatsoever. So we don't have to worry about trying to search this list right here of blog posts because there will only be one blog post. So instead, we can just try to write a selector that looks for the very first card on the screen and then pulls the title and the content out of it. So let's do an inspect element on this big card thing. And again, we want to try to get the title out of here. So notice how the title has a class of card title. That's pretty easy. We could do a selector of card-title. And notice how this is a class here, so we got the period. And then for the actual content, it looks like it's all nested inside a paragraph tag. So that's an easy one as well. We can do simply paragraph, and that gets me that paragraph tag. Now there's just one other quick thing I want you to be aware of here, and this is a real gotcha. This is something where we could write the tests and I could let you run into this error yourself, but essentially after we click on this button right here to actually save the blog post, it takes some amount of time to automatically navigate over to that other page and see that new blog post appear on the screen. It's some amount of time that by default, Puppeteer is not going to automatically wait on. So the rule of thumb here is that any time that you make an AJAX request to some backend API, which occurs when we click on this button, you probably have to wait for that action to be completed. Now we already saw an example of waiting for something to occur inside of our page.js file. So you'll recall when we go through that login process, we have down here at the very end a WaitFor statement as we wait for some content to appear on the screen. So this was another case where we were trying to reload a page or make a request to the backend server, and whenever that occurs, we have to place that WaitFor statement. So we have to do that same WaitFor here as well, because we are clicking on this button and we have to wait for that request to go to our backend server, save the post, and then wait for that navigation to occur as well. So it's a little bit of a gotcha again, but basically we just have to add a WaitFor statement, and then we can actually go ahead and let this thing or make an assertion about the content that appears. So I'm going to do await page.waitFor. And then remember, the WaitFor function expects a selector for some element that it's going to wait to appear on the screen. In this case, we can basically use any element on this blog's page that appears that does not appear on that previous page of the blog confirmation thing. So here, I'm just going to make a suggestion. You'll notice how every one of these blog post things is essentially a div with class card. So I really would only expect to see an element with class card when I'm on my blog list page. So I'm going to wait for something with a class of card to appear. And then once that appears, then we can continue on and make our actual assertion. So now we'll do we'll write our selector to get our card title out of the page and the card content from the paragraph as well. So we'll do const title is await page.get contents of card title, and we'll do content get contents of paragraph. And let's see, we did card title, right? Yeah, I think that's what we did. Yeah, card title right here. Okay, so then we just write out our assertion. So I expect title to equal, and then we're going to use the same string here that we tried to fill in back up here with. So this is what that title and content is always going to be set equal to. So we want to make sure that they're equal to my title and my content. So my title, and make sure that we get the same capitalization here, of course, and expect content to equal my content, like so. All right, so I think we're ready for a run in our test suite. Again, I'm not going to make you watch me run this stuff, so I'm going to start up my tests, npm run test, and we'll take a pause right here and come back in the next video. At the end of the last video, we executed our test suite, and it looks like my tests are all passing. So at this point in time, we've really finished out the entire left-hand side of this tree right here. We've tested all the different cases that a user might use to interact with our blog post feature when they're signed in. So we're now going to move over to the right-hand side, and we're going to start writing some tests that make sure that the user is not allowed to do certain things if they're not signed into the application. Specifically, we want to make sure that a user cannot create blog posts and cannot view blog posts if they are not signed into the app. Now, testing this is going to be a little bit more of a challenge because if you think about it, we don't really have any client-side elements inside the React application that a user can easily access to create a blog post when they're not signed in. The other thing I want to point out here is that inside of our app, what we really want to secure is the API interaction. So the interaction between our browser or some type of request client and our Express server. We want to make sure that if some outside party makes a request to our server when they are not authenticated, we do not want to allow them to create a blog post. This is the real flow right here that we want to secure. Another way of looking at this problem might be that you would want to make sure that a user is not able to see this form right here at all if they are not signed into the app as well. Now this would also be a very meaningful test to write, to make sure that if you are not signed in, you should not be able to access this form. You could definitely write a test like this on your own, but we're going to kind of skip this test in the context of this course because that's a test that's a lot more about the React side of this application. One other thing I want to throw out there about this is that the way that the React application is wired up right now, it doesn't actually prevent this behavior. So you actually can get to this form right here if you're not signed in, but you cannot submit the form to the back end and have a post created. So this feature on the client side is only kind of like half implemented right now. Anyways, back to what we really care about. So we want to make sure that if you are not signed into the application, you should not be able to create a blog post. There's a couple different ways to actually implement this interaction. So we could somehow rig up our test suite to make an API request directly from our Jest code over to our server and make sure that that request is somehow denied or blocked. The other way that we could implement this would be to write some actual code that gets executed inside of our Chromium browser. Now that's going to be the approach that you and I take. We're going to figure out a way to get our Chromium browser to make a direct post request over to the Express API right here. The idea behind this approach is to make sure that if we say log into the application and then log out, it really truly clears our entire session, and there's no possibility of us then reaccessing the API and trying to create a blog post. So again, although we could implement some testing that reaches directly over to our server, we're going to have all these requests that attempt to make a blog post be issued through our browser or through the Chromium browser, just because this more closely emulates how a user would actually use our application in the wild. So let's take a quick break right here. We're going to come back in the next video and we're going to figure out how we're going to somehow get our Chromium browser to create a post request to make a new blog post. In the last section, we spoke about how we were going to write a test that makes sure that a user is not able to make an API request directly from their browser to our backend API to create a new blog post if they are not signed in. So that's our goal. Let's take a look at a diagram that's going to walk us through the steps for the test that we are going to eventually write. All right, so here's the test. This is the code that we're going to write to somehow make sure that all this error handling stuff works the way we expect it to. You and I are going to create a new Chromium browser instance, as we usually do. We're then going to have that navigate to localhost 3000, but then we're not going to sign in. So we're not going to sign in at all. We'll then use that Chromium instance to somehow issue a AJAX post request directly to our backend API. That request is going to attempt to create a new blog post. We'll then somehow capture the results of that request and we'll write an assertion to make sure that it displays some type of error message. Essentially, we just want to make sure that that request fails in some fashion. Now this middle step right here is where things get a little bit tough. So you and I very much already know how to go to an address. We know how to not sign in, and that's certainly easy. And we definitely know how to write a basic assertion. The hard part here is figuring out how to get our Chromium instance to issue a post request to our backend API. To figure out how to better do this, we're going to first do a quick review of our API logic. So we're going to look at the route we need to access and the data we need to provide. We'll then write out a test request that will execute directly inside of our own browser, and then we'll figure out how to implement that with Chromium. So 3 different steps. Let's first start off by taking a look at our existing backend API code and figure out how we create a new blog post at all. So I'm going to go over to my code editor. I'm then going to open up the routes directory, and I'm going to open up the blogroutes.js file inside there. So we've looked at this file a couple of times. Let's scroll on down to the bottom, or maybe about halfway, I should say. Right around here, you'll see a post request handler for the route API/blogs. So API/blogs is the route that you and I care about. We want to make a post request to this route right here. When we make that post request, we have to pass along 2 separate properties. First is title, and the second is content. So we have to attach those 2 properties to the post request body, and then send that in. When we do so, it should successfully create a brand new blog post for us. Okay, so now that we have a better idea of how this route handler works, let's try to write out some code that we could execute directly inside of our browser's console to create a new blog post. We'll then verify that this code works correctly inside of a normal browser, like the one that you and I are running right now, and then we'll be able to take that over to Chromium and make sure that we somehow integrate it into our test suite as well. So in other words, we now want to write some code inside the console right here to somehow automatically create a new blog post for us, rather than going through this entire flow of clicking on the button and all that kind of stuff. Rather than writing this test code, or this kind of like code to create the blog post directly in the console right here, I'm going to instead open up a new file inside my code editor. This is going to be a temporary file, so I am going to delete it. I'm just writing the code over here so that you can more easily see it on the screen. Okay, so inside of here, temporary file to create a new blog post. That's all. So to actually create this blog post, we have to make an AJAX request to our backend API. If you've ever made use of the Axios module before, that's what we might usually make use of. So usually we would do something like axios.post and then put in the route and the data and whatever else. However, as we said earlier, this is code that needs to eventually be executed from inside of our Chromium browser. And so there's not necessarily any guarantee that Axios will be available inside of Chromium. So instead, we are going to use a slightly different module that is definitely included inside of Chromium by default, and that is the Fetch API. Fetch is a request handler, or a request maker, I should say, that was included with ES 2015. It's a function that allows us to make requests to some arbitrary endpoint directly from our browser without any additional libraries or anything like that. So if you go back over to your browser right now and type into your console simply fetch, you should see something like this appear on the screen. Something that says, yep, this function is defined. So this is a globally defined function that you can get access to directly inside of your browser without requiring in any modules or anything like that. So we're going to use fetch to make our post request to our API to make the new blog post. To actually do this, we're going to pass in a couple of different options and arguments. The first argument is going to be the path that we want to make our request to. So as we saw just a moment ago, it's API/post, like so. And then the second argument is going to be an object that contains a bunch of different options that you and I are going to want to use. The first one is going to be the method of the request. So is it a GET request, a POST, a PUT, a DELETE? Well, in our case, it's definitely going to be a POST request. So we'll enter in POST like so. Next, we're going to add in another property called credentials. By default, fetch does not automatically include cookies with requests. All of our authentication is tied directly to cookies, so we need to make sure that fetch tries to use our cookies whenever it makes a request to our backend API. Now, as I said, as we very well know at this point, we want to make sure that we are testing making a blog post when we are not signed in. However, kind of including these cookies and making sure that they're being sent along in a very real request is really a part of what we're trying to achieve here and what we're trying to test. We want to make sure that if someone signs out of the application and has no session, they can still send along their cookies, which should essentially be empty, and not get access to the API. So we want this request to be as real as it possibly can. So that's why we are going to include any cookies we have available here. So to do so, we're going to say credentials, same origin, like so. Next, we're going to set a header. So we set this headers property and then assign it a value of an empty object. And inside of here, we list all the different headers that we might want to provide along with the request. In our case, we want to provide just one to mark this as a JSON type request. So I'm going to pass in content type. Notice how it's capital C, capital T, and I've put it inside of quotes right here, because this would not be a valid JavaScript key inside of an object otherwise. And then this thing's value will be application JSON. And then finally, we need to pass along some data to include in this post request. So we're going to assign that to a body property. And then the data here is going to be the actual data that represents the blog post we want to create. As we saw just a second ago, that should be an object with some title property and content property. So we're going to pass in a title of essentially anything you want, like my title, and then a content of my content. Now just one other thing, this body property right here must be provided in the form of JSON. So we have to manually turn this thing to JSON by calling json.stringify. And then we're going to pass in that whole object like so. Okay, so we're going to now take this request right here. We're going to paste it inside the console of our running browser, and we're just going to verify that it normally, in like normal operation, when we are correctly signed in, this normally would create a blog post. So that's what we want to do first. We want to make sure this code actually can create a blog post. And once we're comfortable that it can, we'll then sign out and verify that if we run it again, we should see some error message that says, no, you can't create a blog post. So as you might imagine, this is testing 101. We want to make sure that our code can succeed before we start writing a test that says like, oh yeah, it always fails. Because if for some reason, you and I start pinging the wrong route or something like that, well then of course this request right here is always going to fail, and we would not be writing a very effective test. Okay, so I'm going to take this entire fetch statement. I'm going to copy the whole thing. I'm going to go back over to my running application. I'm going to make sure that I'm logged in. I'm going to open up my network request tab. Here it is right here. And I'm going to filter by XHR requests. So now I'm going to paste our request code in here. and I'll run it. Okay, so now you'll see that I get a nasty message that says 404 not found. I made a small typo in the route. Now that I look at it, it's not API/post. I just deleted that character. It's API/posts, like so. Let's double check that. Oh, blogs. I'm totally in left field. Blogs, there we go. All right, much better. You're probably sitting there thinking, why is he writing post at all? Post requests, blog posts, it's all the same terminology. All right, let's try that again. Okay, much better. So now we make that request. Here's the request right here. It's 200, so it looks like it was successful. And now if we refresh our page inside the browser, we should see that new post appear on the very bottom of the list. So here it is right here, my title and my content. The one right above it was a post that we had made previously when we went through the actual creation process in the actual blog creation flow. We could just as easily change that title to like my other title. Now there's the request for it. And if we refresh again, okay, I think that we're very comfortable saying, yes, this does successfully work. So let's now try logging out of the browser, and then we're going to make that same request and see the error message that appears. So I'm going to log out. Now I'm definitely logged out of the application, and I'm going to, again, put that same content down inside of my console. I'm going to run it again, and now you'll see an error that says 401 unauthorized. So this would be the message that we would expect to see if we ever try to make an API request to our backend if we are not signed in. Okay, so now we have a very good idea of what code we would write to try to make a request directly from our Chromium browser. And we know what we would expect to see if it succeeds, and we know what we would expect to see if it fails. So now we can take that code that we just wrote and figure out how to somehow execute it from inside of our Chromium instance. So quick break, and we'll tackle that in the next video. In the last section, we saw what would happen if we made a request to our backend API to create a new blog post when we were not signed in. So ultimately, we're going to expect to get back an object with an error property and a string that says you must log in. Now that we know how to make this request right here, we need to figure out how we can somehow execute it from inside of our Chromium browser. Again, one thing I want to remind you about this entire process is that our Jest test suite could totally make this request directly over to our API. That is totally an option. We could definitely do that. But I want to use a Chromium browser because it more closely reflects how a user would be using our application. So let's figure out how we can somehow make this request from inside of our Chromium instance. I've taken the liberty of pulling up the Puppeteer documentation again. So I'm at github.com, I'm looking at the Puppeteer repository here, and I've already gone to the API documentation document. On this document, I'm going to find the class page one more time. So here's class page, and on this class, I'm going to find the method called evaluate. Here's evaluate right here. We can use the evaluate function to execute some arbitrary code inside of our Chromium instance. So we could definitely use this thing right here to somehow execute our request over in the Chromium browser and then return the result of that back over to us on the Jest side of things. Notice how the arguments to this thing are the first argument of page function. So this is the function that we want to actually execute inside of our Chromium instance. One thing that is very easy to make a mistake here is to just take that entire request that you and I just formed up, so like this whole thing right here, and pass this directly to that page.evaluate function. We don't want to pass this directly to page.evaluate. We want to pass in a function that will execute this code. So in other words, we're not going to take this chunk right here and pass it to page.evaluate. We're going to put this into a function like so. So this whole function will be turned into a string. It'll be sent over to our Chromium instance. It will be cast back into JavaScript code and then executed. So again, very easy mistake to make. If we just passed in this request right here directly to that page.evaluate function, then this code would be evaluated from inside of our test suite, which is definitely not the behavior we want. We want to take this entire thing right here and have it be executed directly by Chromium. Okay, so page.evaluate, we're going to pass in a function to be executed. Now, some things to also note here are that when our code gets executed over in the Chromium instance, there's two very special things about it. First off, whatever the result of that evaluate is, it will be eventually returned to us. So we can take whatever comes out of that function body and assign it to some value inside of our test suite. And then we can inspect that thing and figure out exactly what it is and what values are inside of it. The other thing that is very nice about how Chromium handles this inner function is that the inner function that we pass in right here, so here's like the inner function that you and I are going to pass in, that can return a promise. And Chromium will automatically wait for that promise to be resolved before taking the result from it and sending it back over to our Jest test suite. And that's very important for us because we want our request to be resolved by the API or to be completed by the API before we try to take a result from it and send it back over to our test suite. Okay, so now we've got a better idea of how to execute arbitrary code inside of Chromium. So let's take a quick pause right here. We're going to come back to the next video and wire all this stuff up inside of our test suite. In the last section, we took a look at the page.evaluate function. We're now ready to actually make use of this inside of our test suite. I'm going to go back over to my test file of blog.test.js. Here it is right here. And then down at the very bottom of the file, I'm going to create a new describe block that describes the counter case to the one we already put together. So we already have the case where we are logged in. Now down at the very bottom of the file, outside of any other describe block, we're going to handle the case when user is not logged in. And we'll put on our async function like so. Inside this describe block right here, we're going to put down one or two tests. Again, the purpose of these are to make sure that we are not able to create a blog post or get any blog posts if we are not signed in. Those two tests that we're going to write will have access to the page variable that was already declared inside of our before each at the very top. So this code, this before each and this after each, is going to run for every single test inside this file. So we do not have to recreate a page here. All we have to do is write the actual test itself. So we want to make sure that when a user is not logged in, user cannot create blog posts. That's the real thing that we're trying to assert here. So we'll place our async function like so, and that's pretty much it. So now we're going to use that page.evaluate function to execute our request over on our Chromium instance. So I will say page.evaluate. I'm going to give myself a little bit of space here because this is going to be a giant little code block. I'm then going to go back over to that request file that we put together just a second ago. So here's our sampler request. I'm going to make sure that I have on a opening and closing curly brace to make the function body, because remember, we have to pass in a function to that function. I'm going to copy this whole thing. I'll go back over to the blog's test file, and I'm going to paste it inside of page.evaluate like so. I'm going to put a little bit of white space in here just so you can more easily see that segment of code by itself. Okay, so there's a lot of stuff going on here. Here's the opening parenthesis for page.evaluate, and here's the closing one down here. And then we've got the opening curly brace for the request and the closing one right here. Now, before we try to run this code right here, there's one last tiny little gotcha that you need to be aware of if you've never made use of this fetch API before. When fetch returns a response to you, it streams it back into our browser as raw data. So we have to take that response, that raw data, and actually convert it into JSON and then return that. So traditionally, whenever we use the fetch API, we put on, or we chain on a .then to the fetch call, and then inside that we say res is res.json, like so. So again, this takes the response that comes back from our server and it actually turns it into some JSON data. Note that I chained on this .then right here to the actual fetch statement. So if I put in a little bit more white space here to further make this more clear, so the .then just got chained onto the fetch function call. And then that's all wrapped inside of our arrow function right here. Okay. So now Puppeteer in this case is going to take this whole function, it's going to turn it into a string and send it over to Chromium. Chromium is going to execute it. It's going to take the result, so whatever comes back from this res.json call right here, and then it's going to send it back over to our running test suite. So the last thing we have to do is take that value that gets sent back over from page.evaluate and assign it to an actual variable. So I'm going to assign the results of this thing right here to a variable, and let's call that simply, how about const result, like so. And then one other extremely important thing that I want to point out with great detail here, don't forget to put on the await keyword for page.evaluate. Okay, so that's pretty much it here. We're now ready to actually test this out at the terminal. But we need to make sure that we actually kind of inspect this result thing right here and get a better idea of what it is. So we're not going to make any assertion just yet. Let's just do a console.log of result right here and make sure that this stuff is actually working the way we expect. So I'm going to save this file, and then I'm going to go run my test suite. Now this time I'm going to make you sit here and watch me run these things. It doesn't take that long. So we're going to see again these two separate suites start to appear and run their tests in parallel. This is the big feature around Jest. This is the reason that we're using the Jest test suite. It will run your tests in parallel as long as they are split into separate files. And so it's a thing that can very easily dramatically decrease the amount of time that it takes for our entire suite to run. Okay, so it looks like we finished up with the header tests, and now the blog tests are still running as well. Notice how it's taking a lot longer to run our test suite at this point because of just all the additional stuff that we're adding in here. So now you'll notice that when we get back that console log right here, it came back as undefined. So this is a little bit of a gotcha. I made a tiny mistake. I just realized it. When we wrote that function body right here inside the page.evaluate, we put on the curly braces, but we never actually returned the result of fetch. So the promise never actually got returned. That was my mistake. Let's fix that up very quickly. So we're going to say return fetch right here, and then we're going to run those tests one more time. All right, so now we're going to do that again. And I had something to say last time these things ran, but this time I have nothing to say. So we have to sit here in silence. No, I'm just kidding. Like I was saying before, Jest is running these tests in parallel, which is really just fantastic from a performance standpoint. One thing that you might want to do on your own once you get through all this testing stuff, you can take all the tests that we wrote and actually break them up into smaller sub-files. Because again, it just tries to run each file by itself in a big chunk. So if you have smaller test files, more of them will be executed in parallel and your test will run faster. Okay, so this is much better. Now you'll see that the value that got assigned to result is an object that says error, you must log in. So as the very last step here, let's actually write out an assertion for that. So instead of console.log result, I'm going to replace it with expect result to equal error, you must log in. And we need to make sure that this string right here is identical to what we just saw inside of our console. Because if it's not identical, this test is going to fail. So I'm going to triple check that really quick. Yeah, you must log in. Let's see, I definitely got it right. Cool. All right, so I'm going to run my test one more time. And then this time I'm going to pause the video here and I'll catch up with you in the next video and we're going to make sure that all these tests worked. So quick break and I'll see you in a minute. At the end of the last video, I ran my request suite or my test suite again, and it looks like everything came out just fine. So this is definitely very good news. It means that people cannot create post requests inside of our application if they are not signed in. Now there's just one more test I want to walk through that's going to be very similar to the one we just put together. So essentially, we want to make sure that you can not only not create a post, but we also want to make sure that you cannot somehow retrieve a list of posts. So if you're not signed into the application, it doesn't make any sense to get a list of posts back at all, because you have no posts assigned to you. In this case, we need to again look at our request handler to retrieve a list of posts. We'll then write up a new test that makes sure that you cannot call that thing if you're not signed into the app. So let's first start off by pulling up our blog routes route handler again. So here's my routes directory. I'm going to find blog routes, and then I'll go up to the top right about here or so, and I'll find the request handler to get back a list of blogs. So we need to make a GET request to API/blogs. And if we do so, in theory, we would get back all the blogs that belong to us. Just as before, let's try writing out this request inside of our code editor, and then we'll try moving it over to Chrome and just making sure that it works the way we expect. So I've still got the previous request handler here on the screen, or excuse me, request executor. If you already deleted this thing, that's totally fine, because this time around we don't need to pass in a body. And the only other change is that our method is now going to be a get. So this right here is what we want to actually execute from inside of our browser. So again, if you deleted this, you could very quickly retype it. Once you have it all put together, we'll then copy it, and we're going to go execute it inside of our browser console again. So here I am inside of my application. I'm currently not logged into the app. I'm going to put that entire request right here inside the console, and I'll execute it. Now, as before, I get a 401 error with some text that says you must log in, which is perfect, definitely what we expect. But then just as before, we need to make sure that this would work if we were signed in. That's the key here. We need to make sure that this stuff actually works when we are signed in. Otherwise, the test is a little meaningless. So I'll sign into the application, and then I will run that request again. And now it does, in fact, retrieve a list of blog posts. So cool. I think this is working out just fine. Let's take another quick pause. We're going to come back in the next video, and we'll put together the actual test that's going to make sure that we cannot fetch this route if we're not signed in. We've now got a working request right here that will attempt to fetch our list of blog posts. Now, one quick fix I'm going to put on here before I forget, like I did previously, we want to return the result of fetch from this function right here, because that's a promise that we want to be eventually resolved and then have the resolved value be sent back over to our test suite. So I'm going to make sure I put in the return keyword right there. Okay, so now we're going to add an additional test to our blog's test file. Down towards the bottom of the file, here's our describe block for checking to see that the user is not, or excuse me, that's saying the user is not logged in here. And then inside this describe block, we're going to add in one last test. So we're going to say user cannot get a list of posts, like so. Then we'll put in our async keyword, and now we can call that page.evaluate thing again. So we'll say page.evaluate. I'm going to open up my set of parentheses, and then we're going to go copy paste that request from that other page again. So here's the request right here. It's making a GET request to API/blogs. I'm going to take the entire statement, including that return keyword that we just added in. I'm going to copy it. I'll then go back over to blog test, and I'm going to put it in here for page.evaluate. Cool, so that looks good. I'm going to again put in a little bit of white space just so you can make sure you've got the correct parenthesis alignment. Okay. Now, as before, we want to wait for this thing to eventually return some value. So we're going to put in a wait and then page.evaluate, and then we're going to assign whatever gets returned to a variable called result. And then one other quick thing that we added on to the last one is that res.json statement at the bottom. So on the fetch function right here, here's the closing parenthesis for the fetch function. Here's the opening one. Here's the closing one. We're going to make sure we chain on a .then. We take res and return res.json, like so. And then when I save my code, it of course all reformats on the screen. So I end up with what you see right here. Now the very last thing to do is to write out an actual assertion at the bottom here. So I'll do expect result to equal, and again we're going to expect this to be the exact same thing as before. So it should be an object that has an error property that says you must log in. So we're going to expect result to equal error you must log in. Great. I'm going to save this file, and I'm going to go back over to my terminal, and I'll do another npm run test. And then as before, I'm going to pause the video here so that you can just wait and not have to watch me run these tests. So quick break, and I'll see you in a minute. At the end of the last video, we executed our new test that makes sure that a user cannot get a list of blog posts if they're not signed in. And looking at my terminal, it looks like everything is a-okay. So we've now ran through quite a gamut of tests around our application. We've written out tests that make sure that the user is logged in. We've written tests that make sure that the user can do certain things if they are logged in. And then we also wrote assertions around the counter case, where the user was not logged in and tried to access some protected resources. Now there's just one last thing that I want to do as a refactor to our current setup. But here's the thing. I do not want you to have to do this refactor if you don't want to. So the last refactor that I want to do here is just a little bit of a nice thing to have. And it's going to be a little bit of code that dramatically simplifies how we make these tests right here to try to access some resource that we should not have access to. These are completely optional refactors. So if you don't want to do this, pause the video right now and continue on the start of the next section. So however many videos it is to the next section, just continue on to that next topic. Otherwise, stick around and we're going to do a refactor that dramatically simplifies all this logic. Okay, so if you're still here, I assume that you want to see what this refactor is. And it really is going to dramatically simplify how we do these tests right here that check to make sure that the user cannot do some particular action. So the thing that you need to really realize about these requests is that we might end up with a ton of different routes inside of our application that we want to test to make sure that a user does not have access to if they are not signed in. In this case, we just tested 2 of these routes. Like here's one right here, the create blog post, and then one to make sure that a user can't get a list of blog posts as well. But in any professional application, we might end up with dozens of different routes, right? We can easily have dozens, if not hundreds, of different routes that we might want to test. So we're going to think up some way to write dramatically less code to execute or to test each of those different routes. Honestly, we don't want to have to write out this block right here again and again and again. So you might be thinking, all right, Steven, I get it. Let's try to make a helper function on our page object right here that just simplifies the making of a post request. Well, that's definitely something we could do. Maybe we can make a helper that tries to just more automatically create a post request. So kind of encapsulate some of these options right here, just make life a little bit more easy. Maybe that's a good place to get started. Maybe we should try to do a simple refactor like that and then see if there's any other kind of approach we could take to even further simplify it after that. All right, so I'm going to open up my helpers page.js file, and then down towards the bottom of our custom class, I'm going to add in a new function. We're going to start off first by trying to take care of that GET request. We're going to try to automate that GET request a little bit more than it is right now. So down here, I'm going to say GET. So GET right here is going to represent a GET request that we want to make. We're going to have separate requests handlers here, or separate functions to automate these requests. One is going to be GET, and the other we'll set up as like a post function as well. So if you ever want to automatically execute some code that makes a GET request, you're going to call GET right here. Whenever we make a GET request, the only variable in the request itself is the path that we want to make the request to. If we go back over to our tests right here, where we try to get that list of blog posts, you'll notice by looking at the fetch call that there really is only one variable inside of here that's ever going to change, and it is the route. That's the only thing that changes. So with that in mind, we can probably say that whenever you call this GET function right here, the only argument you have to pass in will be the path that you want to make the request to. Then inside the GET function itself, we can place all of our logic to somehow make a request using that page.evaluate function. So this is where the refactor is going to get a little bit crazy because I'm going to start moving around a lot of code. So I'm going to go back over to my test suite. Here's the test to get a list of blog posts. I'm going to find everything from page.evaluate right here all the way down to the closing paren for the page.evaluate function. So all this stuff. I'm going to cut this, and now I'm left only with const result equals await and the expect statement right here as well. I'm then going to take this over to the page.js file, and I'm going to paste the entire thing directly inside the GET function. Okay, so that looks good. We do have to fix up this code just a little bit. So notice that right now we're not returning anything from this function. We do have to return a value so that our test suite knows that it has to wait for this promise to be resolved, and then eventually get a value off the promise itself. So I'm going to put in return page.evaluate. The other thing to keep in mind is that inside of our custom page class, the reference to our current page that we're working with is not simply page, it's this.page. And this goes back to the topic of how we set up this page, my custom page class originally. So the actual Chromium instance, or the actual Puppeteer browser tab, is available as the variable this.page inside of here. The next thing we have to do is make sure that we try to make the request to the path that is provided by our GET argument right here, not this hard-coded API/blogs. Now this is where things start to get really crazy, okay? This gets really crazy. So I'm going to put in some incorrect code here for just a second. So I'm going to delete that route, and then I'm going to do what you might think be the obvious thing and put in fetch with path, like so. Here's why this is an issue. Let me get a little bit of space here around the get function so we can just isolate this part right here. I want you to remember that the evaluate function right here takes this first argument of a function, it turns it into a string, and then it sends it on over to the Chromium instance. Now when we reference path right here, in normal JavaScript code, referencing path would be totally fine. This reference of path is included in what's called the closure scope of this inner function right here. So normally we could absolutely do a reference like this with no problem whatsoever. And we could access this path variable through our closure scope. However, when we take this function right here and turn it into a string, the only data that we have about this function whatsoever is the fact that it is a string, and no other scope, no other variables, nothing else gets included along with it. So if we ran this code right now, it would be essentially equivalent to taking this function right here, this inner function right here, copying it, taking it over to the browser, pasting it in, and running it. And if we did that, what do you think would actually occur? Well, let me put in some actual parentheses here so we can actually execute it. So if we actually try to run this thing right here, we're going to see an error message that says that path is an undefined variable. Like so, path is not defined. So if we ran our test suite as is right now, we would expect to see an error message like this, because we do not automatically get these variables coming across with these stringified functions as closure scope variables. So to fix this issue, let's go take a look at the Puppeteer documentation one more time. So here's the documentation for evaluate. You'll notice that the second argument here is ... args. So this is a list of different arguments that will be turned into a string as well, and then eventually passed into that page function when it gets invoked. So in other words, if we want to reference any variables or get any arguments to that page function, that first argument, we have to pass them in directly as additional arguments to the evaluate function. Those arguments get turned into strings, they go over to the Chromium instance, they get turned back into actual values, and then we can reference them from within our function. So back at the get function that we're putting together right here, I'm going to find the closing curly brace for the function that we're sending on over to our Chromium instance. So here's the closing curly brace right here. And then as a second argument to the evaluate function, so that's what this is right here, this is the second argument, I'm going to reference, or I'm going to pass in path, like so. So path right here is what comes in as an argument when we call this function. Now just to be clear, when we pass in path, that does not allow us to automatically just magically get access to path inside the function itself under closure scope. Instead, this variable right here is provided as an argument to this arrow function. That's what the documentation was actually saying. It says this is an argument that gets passed to that function. So now we can reference that path variable as an argument here. Rather than calling this thing path though, because now we've got the word path flowing all around and it's in completely different contexts, like completely different variables we're talking about here. So rather than calling this thing path, I would recommend calling it like underscore path, or you could call it simply p or something like that. I think maybe underscore path makes some sense. And then inside the fetch statement right here as the first argument, we're going to be really clear and say, yeah, we're referencing underscore path right here. And this has really no necessarily direct tie to the path variable outside the function. Okay, so that's a lot of discussion about what's going on here. So let's save this file, and we're going to go refactor our blog test file to make use of this helper function. So I'm going to save this thing. It looks like everything looks good. I'm going to go back over to my page test, or to my blog test. Here's where we had just copy-pasted all of our code from, and then I'm going to replace this with page.get, and then we're going to pass in the route that we want to try to get. So that's going to be /API/blogs, like so. And then we'll flip on over to our terminal, and we're going to run our tests again. Now I do want this to be just like one self-contained variable or video, of all this extra stuff we're doing. So unfortunately, we are gonna like just keep on going here. I'll go back over and we'll start working on the next thing while these tests run, and we'll come back over in just a second. So the next thing we are probably gonna wanna do here is make a very similar helper to handle post requests as well. So post requests are gonna be pretty straightforward too. In this case, we have two variables inside of every post request. The first is the route or the path, just like we had previously, but then the second variable here is the data that we want to pass in to the request body. So we're going to also make that post request handler on our page, or the post request executor. I keep saying handler. It really is an executor of sorts. We're going to make another helper, but this one's going to take in the two separate arguments, the two separate variables, the route and the body as well. Now really quickly, let's just make sure that our tests are still passing. Yep, they are. That's very good. So let's now go back over. We're going to open up our page.js file again, and we're going to also define the post function in here as well. So whenever we call page.post, it should execute a post request in the context of our Chromium instance. This time, our post function, unlike get up here, is going to take two arguments. First is path, and then the second argument will be the actual data, which we'll call simply data. Then inside this thing, we're going to have a very similar setup to what we had before. So we're going to say return. Actually, let's leave off the return right here. Let's just go and copy paste that entire handler from our test over here. So here's our blog post posting code right here. I'm going to take the exact same copy paste we did before. So I'm going to go from page all the way down to the closing paren for the page function. I'm going to copy it, and now we should be left with simply await and the expect statement. And then I'll go back over to page. I'm going to put the entire thing directly inside of here, like so. Now, just like before, I want to return the results of all this. So we're going to return whatever comes back from page.evaluate. And then just like before, we're going to make sure that we extract this route right here, and we're going to pass in the path that we're trying to make this post request to as a second argument to the evaluate function. So here's my opening paren for evaluate. Here's the closing paren right here. So I'm going to put in as a second argument the path that we want to make the request to. We will then receive that argument as underscore path, and then I will replace API/blogs with underscore path like so. Now, one other thing we need to handle this time around is data as well. So just to be clear, back here in the documentation, when it says ... args right here, that means we can pass in as many arguments as we want, and they will all be passed to that inner function. So we're not restricted to just the path here. We can also pass in data, and this argument right here will be passed into the inner function as an argument as well, after it gets sent on over to our running Chromium instance. So I will also receive this as underscore data, and then we'll say that this data argument right here, we'll say that it's what we pass to that JSON stringify call. So we don't have to pass in the fully stringified thing. We'll say that we'll make this actual code right here do the JSON stringifying for us, because I don't know about you, but I don't want to actually have to stringify this data again and again. So now, rather than passing in directly this whole big object right here, I'm going to delete it, and I will replace it with underscore data. So let's trace the code path one more time. Whenever we call post, we pass in the path and some object to post to this path. This data gets provided to the evaluate call. Data gets turned into a string. It gets communicated over to our Chromium instance. It gets turned back into an object, and then is provided as the second argument to our inner function right here, which we are calling underscore data. We then take that thing, we turn it into JSON, and we include it with our actual post request. Okay, so this looks good as well. So let's save this. Notice when I save, it does the big refactor, but it's the same code, it just reformats it. So now we can go back over to our test inside of blogs.test.js, and I will replace result await with await page.post. We want to make this post request to API/blogs, and then as a second argument, we'll pass in the request body. Remember, that thing is supposed to have a title and some content. In this case, the actual values don't matter because we're not trying to make an assertion about the values. So we'll simply say title of, I don't know, T and content of C, like so. All right, so that looks pretty good. Let's now run our test suite again. And I'll let that thing just do its thing for a moment. We'll come back over to our test suite over here. So at this point, we have dramatically simplified how much code we have to write to make these GET requests and POST requests. As you might imagine, you might want to eventually expand these request executor helper functions to not only have GET and POST, maybe you would also want a put and also want a, I don't know, a delete or whatever else. Now, even these two helpers right here could be even further simplified from where they are right now. Technically, we could probably combine the GET and the POST into one single execute request function that took in the request type as an argument. So there's probably even more simplification you could do between these two functions right here, but I will leave that as an exercise to you. All right, so let's check our test really quickly. It looks like there is an error here. We are going to, it's not page.evaluate, it's this.page. I missed that one. Back inside of page.js, let's fix that up really quickly. Inside of the post handler, post function, we'll do this.page like so. And then I will execute my tests again. All right, so at this point, I'm pretty sure these are going to pass. So let's talk about the next refactor we're going to do here to even further condense the code you see here. So as I said earlier, you might eventually end up inside of an application with many, many, many different routes that you want to make some assertion about for being secure in some fashion. This testing code that we're writing right here is much more compact, but again, I think that we could even get it to be more concise than what you see right here. So I think we could even do an improvement upon this. So let's talk about how we're going to do that. All right, I'm just pulling some code up really quickly. All right, so looking at these two separate requests right here, these two different tests we have, I want you to now look at these two different requests here. So here's one for post and one for get. And I want you to point out all the different variables or the things that are changing between these two function calls. So it looks like the only things that are really changing here are whether or not we are making a post or a get, so essentially the method type, the route that we're making the request to, and then an optional data variable as well. So if I were to kind of like write up a schema of sorts that would kind of characterize how these requests are being made, there really is only 3 different variables. And I feel like I could kind of summarize these 3 variables inside of a single object. So I'm going to do something really weird here. It's going to look weird at first. Above our first test right here, I'm going to put in a couple new lines. And I'm going to create a new object called actions, like so. I'm going to make this an array. And inside of here, I'm going to put one object for right now. So I want inside of this object to kind of take those 3 variables that we just discussed and summarize them inside that object. So again, we've got like this method that seems to change over time. We've got the route that seems to change over time, or the path, call it whatever you want. And then also this optional data right here. So if I wanted to kind of characterize, like let's say this GET request right here in those 3 variables, I might summarize them inside of this single object right here as something like method of GET and path of API logs, like so. Now again, this might look a little bit strange for right now, but just bear with me for a second. Now, if I wanted to also kind of characterize this post request in object form, I might write something like inside a second object inside this array, that one has a method of post, a path of also API/blogs, and that one also has some data, which was a title of T and a content of C, like so. So now we've got this array of objects right here that very closely kind of summarize what that test is using as variables or as parameters. Everything else inside of both these tests is completely identical, besides the description, of course. But the actual, what we're doing with that result, completely identical. So in both cases, we're taking back that result and then making sure that it's equal to this object right here, in both cases. So here's what I think we could do. Let me cut to the crux of the issue of what we're trying to accomplish. I think that we could end up making an array of objects like this. We could then iterate over this array, and for every object in the array, we could create a new request and issue it to our backend API through our Chromium instance. We could then collect all the responses that come back and make sure that every single one of them is equal to the object error you must log in. So in short, I think that we could dramatically simplify the amount of test writing we have to do by summarizing each of these tests inside this array right here as separate objects, loop over these objects, and kind of execute each individual request. Okay, that's the idea. Now before we do that, let's go make sure that our test that we executed just a second ago actually passed. Okay, it looks like our fix did work. So our tests are definitely working right now. All right, so let's go back over, and we're going to start to tackle this kind of like actions array thing right here. I'm going to first get started by deleting both of the tests that we just wrote out. So I'm just going to delete them entirely. And I'm going to replace it with one single test. And I'm going to give this a description of blog-related actions are prohibited. So remember, this test statement right here really chains on to the describe above it. So you can kind of read this thing as, when the user is not logged in, blog-related actions are prohibited. That's pretty much what we're saying here. And then in the body, we'll do async. And then we'll write out some code that, like I said, iterates over this list of objects right here, makes all those calls, gets an array of all the results, and then makes sure that every single result is equal to you must log in. Now chances are, as usual, we probably might want to repeat all this helper logic in some other test as well. You know, this is maybe right now the only feature that we want to limit inside of our application, but maybe we also eventually add in other requests or other features that we want to restrict access to as well. So rather than doing the logic to loop over this array of objects right here inside of this test file, let's put all that logic on our page.js thing instead. So I'm going to go back over to the page.js file, and then down underneath the get and post functions, I'm going to add on a new function that takes in that array of actions and tries to execute every single one inside there. So I'm going to do a new function that's called exec requests, which is short for execute requests. Like just take a whole bunch of requests and do them all at once, all at the same time. So we're going to call this thing with that array of objects, which we're going to refer to as our actions that we want to somehow execute. We'll then map over this actions array right here. So we're going to use the map function, and for every object inside there, we're going to try to call either our post request function or our get request function, and we'll pass in the path and data where appropriate. Okay. So inside of exec requests, I'll do actions.map. We will map over that array of objects, or that array of actions. So that's this thing right here. And we'll get these objects as arguments. Now these objects only ever have the property method, path, and data. That's like the only way to customize them. So inside of the map statement right here, rather than return or like receive the entire action object as an argument, I'm going to immediately destructure out the method, path, and data properties. Now, quick thing to keep in mind here, whenever we are mapping over an object and we are doing some destructuring with an arrow function, we have to wrap those curly braces with a set of parentheses like so. So that's why you see this set of parentheses around the curly braces. So now we've got method, path, and data. The most important thing to realize here is that method is the name of the function that we want to call, either post or get. So to actually make the request, we can call this and then square bracket method like so. This is a reference to the current page object that we are working with. So when we do this with method, that's going to return either this post function right here or this get function right here. So then we can take that function and invoke it with the path and data properties that are contained inside the action, which we just destructured off right here. So this is either our get function or our post function. We can then invoke it by putting our set of parentheses like so. We'll pass in as a first argument our path, and then as a second argument data like so. In the case of data, we are not actually providing any data along with GET requests, but that's totally fine. If no data is passed in for the GET requests, this will simply be undefined, and the actual GET function itself will just ignore that argument. So it's totally fine here that we're passing in data even if it might not be used. Okay, so this right here is going to call the function, and it's going to pass in the appropriate arguments. We're then going to make sure we return the result of that. So now this entire statement right here is going to result in an array of promises. These are promises that represent the running evaluate function that's being executed over inside of our current Chromium instance. And we might have many of these requests right here trying to be executed at the exact same time. After all, that's why we are trying to do the map right here. So to make sure that this array of promises right here, to make sure that we wait for all of them to be resolved before trying to make assertions about any of them, we're going to take this entire thing right here and we're going to pass it in to a promise.all, like so. And I'll do a little bit of new lining here just to make this code a little bit more clear. All right, there we go. So we're mapping over that array of actions. For each action object, we call the appropriate function and pass in the appropriate arguments. Those all return promises. So we end up with an array of promises for the actions.map statement. We then take that array of promises and pass it to promise.all. And then promise.all is going to wait for them all to resolve before we actually attempt to do anything with them at all. So we'll then return promise.all. Again, this thing is going to take all those promises and combine them down to one single promise. And when that single promise resolves, that means we're ready to inspect all these things and make sure that the result of every single request was that object that says, error, you must be logged in. So now the last thing we have to do is actually make use of exec requests from our actual test file. So back inside my test file, here's our actions object. Here's the test function. So we're going to call exec requests. So we'll do await page.exec requests, and we'll pass in that actions object or that actions array that we just defined right here. So we're going to pass that thing in. It does all the mapping. It makes the request. It returns a single request or single promise that has been produced by the promise.all call, and we're going to await for that thing to be resolved. So this await right here is for whatever gets returned from the promise.all. So we'll take the result of all that and we'll assign it to, in this case, results, because this is going to be an array that has the result of every single request that we had made. So in reality, we would expect this results variable right here to be an array of objects where each object has the error property that says you must log in. So the last thing we're going to do is loop over this object right here, and for everything inside of it, every value inside of it, we're going to make sure that it's equal to that error object. And for that, we can use a simple for of loop rather than doing a map or a for each or anything like that. So we can say for let result of results. Remember, we use the of keyword when we're iterating over an array. And then inside of here, we can expect result. So that's the individual value that we're pulling off, dot to equal error, you must log in, like so. All right, so I'm going to save this file. I'm going to save the page file as well, and then I'm going to run these tests. So back at my terminal, I'll do npm run test, and let's see how this goes. Now this section has been like a little bit more haphazard, and like I said, I wanted to combine everything into one because I really do consider this to be just at the absolute peak of advanced stuff right here. You know, this is like as basically hard as it's going to get. And so that's why if you're here, I'm kind of assuming that, you know, you can bring yourself along. And that's why I didn't go into quite as much detail or quite as many diagrams as I usually would. Okay, so now our tests are running here. And you'll notice that, in fact, yeah, believe it or not, they all pass. They all pass. So this has been one way that we could take a ton of different requests that we want to make at one time and just send them all out to our Chromium instance at the same time and just let them all be executed all at the same time, all in parallel. So taking this approach right here is actually going to dramatically speed up our test suite as well, because all these actions are going to be executed at the same exact time. So now if we had other actions or other routes that we wanted to make sure were secured inside of our application, we could just add on additional like configuration objects here. So I could do like, say, a method of get and a path of API slash, I don't know, my bank balance or something like that. So now our little exec request function right here would try to make a get request to the route my bank balance, and then we would end up writing an assertion that makes sure that we saw an error message that says you must log in if you want to actually access that. So just a quick example of how you would then take this structure and expand it on for adding in additional routes as well. And I'm going to delete that because we don't actually have that route, and we would see an error if we ran that. Okay, so again, this is a very, very, very advanced thing. If it seems like I just kind of crashed through it as fast as possible, well, maybe not as fast as possible, but I did crash through it just because if you're here, again, kind of expecting you can pick a little bit of this stuff up. So hopefully that was a little bit of fun. So let's now take a break. We're going to continue the next video, and we're going to start working on our next big topic.